does it say no video? Oh, come on. It's working. I think. Okay, so wherever I left off yesterday, finish it up today. Hopefully, get the shader program done. So we can get to the JavaScript standard. And yada yada. Still loading. Loaded. I don't know. I need to like suck down some more pop. Pepsi, whatever. Not have energy to talk. I gotta figure out where I left off yesterday. And get everything sorted up. I need winter to come back. It's so freaking hot. Can't take it. I want to move to Alaska. Alaska would be nice, cool temperature all year round. Alright, so as I left off on the loop, so I need to make the 4 and 5 modes for the call to pass it in as an address or like access something in the array, because there's like the head descriptor. For the type. there's like a head descriptor for the type. And then after the head descriptor is, well, not after the head descriptor, it's pointed to. It's like the data holds a pointer. The allocation that holds the array of whatever is in the vector. So I pass it in as, or to get the address of it, to the Vulkan API. Like right here, whatever. I need to pass in the address without the header descriptor. And then right now, all these call modes, they use a block or whatever. This is call mode 2. So we need to make call mode 4 or 5. So 4 and 5, they won't be contained in a block. And then I'll be able to like assign it to the left hand side as a value, or access it as an array. Easier. I gotta turn a fan, it's so fucking hot. Holy crap. I cannot take the weather. So I'm gonna try to set up these two modes or whatever. If I can get this done and the vector class working, I gotta make an array class or whatever. And then I can go through the Vulkan tutorial, here, this, whatever. And then rip out the C++, put in my calls instead. I'll be able to like get the stupid image onto the quad. And then this whole shader program thing will be done. And I can actually get back to working on the JavaScript engine. And then the whole like battle for the internet will begin again. A whole new battle of who can make the best browser. Again. Because it's not over till it's over. I'm gonna win. I gotta focus. Turn on a fucking fan. define what this method is being called. Setup modes 4 and 5. Save a backup first, and I'll get started. Programming is so much fun. Not really. Well, programming would be fun if the computer wasn't complete trash, if the compiler didn't suck, and if the languages weren't so poorly optimized, then programming would be fun. But programming in 2025 is the same thing as programming in 1950s. It's ridiculous. The hardware gets slightly more advanced every year, but the programming software is fucking just static. And the operating systems are trash. I can get this done.
To new declarative environment, E. The abstract operation new declarative environment takes argument E, an environment record or null, and returns a declarative environment record. It performs the following steps when called. Let env be a new declarative environment record containing no bindings. Set env to E. Return env, 1, 2, 3 new object environment, O, W, E. The abstract operation new object environment takes arguments O, an object, W, a boolean, and E, an environment record or null, and returns an object environment record. It performs the following steps when called. Let env be a new object environment record. Set env to O, set env to W, set env to E. Return env, 1, 2, 4 new function environment, F. New target. The abstract operation new function environment takes arguments F, an ECMA script function object, and new target, an object or undefined, and returns a function environment record. It performs the following steps when called. Let env be a new function environment record containing no bindings. Set env to F. If F is lexical, set env to lexical, else. Set env to uninitialized, set env to new target, set env to F, return env, 1, 2, 5 new global environment, G, this value. The abstract operation new global environment takes arguments G, an object, and this value, an object, and returns a global environment record. It performs the following steps when called. Let objrect be new object environment, G, false. Null. Let DCLrec be new declarative environment, null. Let env be a new global environment record. Set env to objrec. Set env to this value. Set env to DCLrec. Set env to a new empty list. Set env to null. Return env, 1, 2, 6 new module environment, E. The abstract operation new module environment takes argument E, an environment record, and returns a module environment record. It performs the following steps when called. Let env be a new module environment record containing no bindings. Set env to E. Return env, ECMA International 2024 151, 9.2 Private environment records. A private environment record is a specification mechanism used to track private names based upon the lexical nesting structure of class declarations and class expressions in ECMA script code. They are similar to, but distinct from, environment records. Each private environment record is associated with a class declaration or class expression. Each time such a class is evaluated, A new private environment record is created to record the private names declared by that class. Each private environment record has the fields defined in Table 23. Table 23. Private environment record fields. Field name, value T, IP, meaning, outer private environment. A, private environment record or null. The private environment record of the nearest containing class null if the class with which this private environment record is associated is not contained in any other class. Names, a list of private names. The private names declared by this class. 9. 2. 1 private environment record operations. The following abstract operations are used in this specification to operate upon private environment records. 9. 2. 1. 1 new private environment. Outer privy NV. The abstract operation new private environment takes argument outer privy NV, a private environment record or null, and returns a private environment record. It performs the following steps when called. Let names be a new empty list. Return the private environment record. Outer privy NV. Names, 2. 1. 2 resolve private identifier. Privy NV. Identifier. The abstract operation resolve private identifier takes arguments privy NV, a private environment record, and identifier, a string, and returns a private name. It performs the following steps when called. Let names be privy NV. For each private name Pn of names, do A if Pn is identifier. Then, I return Pn. Let outer privy NV be privy NV. Assert. Outer privy NV is not null. Return resolve private identifier. Outer privy NV. Identifier. Point 3 realms. Before it is evaluated, all ECMA script code must be associated with a realm. Conceptually, a realm consists of a set of intrinsic objects, an ECMA script global environment, all of the ECMA script code that is loaded within the scope of that global environment, and other associated state and resources. A realm is represented in this specification as a realm record with the fields specified in Table 24, 52, copyright sign, ECMA International 2024, Table 24. Realm record fields, field name, agent signifier, intrinsics, global object, global ENV, template map, an object or undefined value, an agent signifier, a record whose field names are intrinsic keys and whose values are objects, a global environment record, a list of records with fields, a template literal parse node, and V, an array, F, the agent that owns this realm, the global object for this realm, the global environment for this realm, meaning, the intrinsic values used by code associated with this realm, a list of records, with fields are, a string, and a module record. Note 1: once a parse node becomes unreachable, the corresponding is also unreachable, and it would be unobservable if an implementation removed the pair from the list. Anything default value is undefined. Note 2: as mentioned in host load imported module 16.2.1. 8 Note 1. In realm records is only used when running an import expression in a context where there is no active script or module field reserved for use by hosts that need to associate additional information with a realm record. Template objects are canonicalized separately for each realm using its realm records. Each value is a parse node that is a template literal. The associated ALU is the corresponding template object that is passed to a tag function, a map from the specifier strings imported by this realm to the solved module record. The list does not contain two different records with the same 9. 3. 1 create realm. The abstract operation create realm takes no arguments and returns a realm record. It performs the following steps when called. Let realm rec be a new realm record. Perform create intrinsics. Realm rec, set realm rec to agent signifier, set realm rec to undefined, set realm rec to undefined, set realm rec to a new empty list, return realm rec, ECMA International 2024 153, 9. 3. 2 create intrinsics. Realm rec, the abstract operation create intrinsics takes argument realm rec, a realm record, and returns unused. It performs the following steps when called. Set realm rec to a new record. Set fields of realm rec with the values listed in Table 6. The field names are the names listed in column 1 of the table. The value of each field is a new object value fully and recursively populated with property values as defined by the specification of each object in clauses 19 through 28. All object property values are newly created object values. All values that are built-in function objects are created by performing create built-in function steps, length, name, slots, realm reg, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the function's name property. Length is the initial value of the function's length property. Slots is a list of the names, if any, of the function's specified internal slots. And prototype is the specified value of the function's internal slot. The creation of the intrinsics and their properties must be ordered to avoid any dependencies upon objects that have not yet been created. Perform. Capital A, D, D, capital R, E, S, T, R, I, C, T, E, D, capital F, U, N, C, T, I, O, N, capital P, R, O, P, E, R, T, I, E, realm reg, return unused, 3.3 set realm global object, realm reg, global OBJ, this value, the abstract operation set realm global object takes arguments realm reg, a realm record, global OBJ, an object or undefined, and this value, an object or undefined, and returns unused. It performs the following steps when called if global OBJ is undefined. Then, A. Let intrinsics be realm reg. B. Set global OBJ to ordinary object create. Intrinsics. Assert. Global OBJ is an object if this value is undefined. Set this value to global OBJ. Set realm rec to global OBJ. Let new global env be new global environment. Global OBJ. This value. Set realm rec to new global env. Return unused. 3.4 set default global bindings. Realm rec. The abstract operation set default global bindings takes argument realm reg, a realm record, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called let global be realm rec. For each property of the global object specified in clause 19, do A. Let name be the string value of the property name. B. Let desc be the fully populated data property descriptor for the property, containing the specified attributes for the property. For properties listed in 19.2, 19.3, or 19.4, the value of the attribute is the corresponding intrinsic object from realm rec. C. Perform. Define property or throw, global, name, desc, return global. Point 4 execution contexts. An execution context is a specification device that is used to track the runtime evaluation of code by an ECMA script implementation. At any point in time, there is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution context in this specification denote the running execution context of the surrounding agent. The execution context stack is used to track execution contexts. The running execution context is always the top element of this stack. A new execution context is created whenever control is transferred from the executable code associated with the currently running execution context to executable code that is not associated with that. 54. Copyright sign, ECMA International 2024. Execution context. The newly created execution context is pushed onto the stack and becomes the running execution context. An execution context contains whatever implementation-specific state is necessary to track the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 25. State components for all execution contexts. Component, purpose, code evaluation state, any state needed to perform, suspend, and resume evaluation of the code associated with this execution context. Function. If this execution context is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of a script or module, the value is null. Realm. The realm record from which associated code accesses ECMA script resources, script or module. The module record or script record from which associated code originates. if there is no originating script or module, as is the case for the original execution context created in initialize host-defined realm. The value is null. Evaluation of code by the running execution context may be suspended at various points defined within this spec. Bifurcation. Once the running execution context has been suspended, a different execution context may become the running execution context and commence evaluating its code. At some later time, a suspended execution context may again become the running execution context and continue evaluating its code at the point where it had previously been suspended. Transition of the running execution context status among execution contexts usually occurs in stack-like last-in, first-out manner. However, some ECMA script features require non-LIFO transitions of the running execution context. The value of the realm component of the running execution context is also called the current realm record. The value of the function component of the running execution context is also called the active function object. ECMA script code execution contexts have the additional state components listed in Table 26. Table 26. Additional state components for ECMA script code execution contexts. Component purpose. Lexical environment identifies the environment record used to resolve identifier references made by code within this execution context. Variable environment identifies the environment record that holds bindings created by variable statements within this execution context. Private environment identifies the private environment record that holds private names created by class elements in the nearest containing class null if there is no containing class. The lexical environment and variable environment components of an execution context are always environment records. Execution contexts representing the evaluation of generators have the additional state components listed in Table 27. ECMA International 2024 155. Table 27. Additional state components for generator execution contexts. In most situations, only the running execution context, the top of the execution context stack, is directly manipulated by algorithms within this specification. Hence, when the terms lexical environment and variable environment are used without qualification, they are in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. It is impossible for ECMA script code to directly access or observe an execution context. 4.1 Get active script or module. The abstract operation get active script or module takes no arguments and returns a script record, a module record, or null. It is used to determine the running script or module based on the running execution context. It performs the following steps when called. If the execution context stack is empty, return null. Let EC be the topmost execution context on the execution context stack whose script or module component is not null. If no such execution context exists, return null. Otherwise, return X script or module. 4.2 Resolve binding, name, env. The abstract operation solve binding takes argument name, a string, and optional argument env, an environment record or undefined, and returns either a normal completion containing a reference record or a throw completion. It is used to determine the binding of name. env can be used to explicitly provide the environment record that is to be searched for the binding. It performs the following steps when called. If env is not present or env is undefined, then set env to the running execution context's lexical environment. Assert env is an environment record if the source text matched by the syntactic production that is being evaluated is contained in strict mode. Code, let strict be true, else let strict be false. Return, get identifier reference, env, name, strict. 4.3 Get this environment. The abstract operation get this environment takes no arguments and returns an environment record. It finds the environment record that currently supplies the binding of the keyword this. It performs the following steps when called. Let env be the running execution context's lexical environment 2. Repeat. Component purpose. Generator. The generator that this execution context is evaluating. 156. ECMA International 2024. Note the result of resolve binding is always a reference record whose field is name ABCDE. Let exists be env has this binding. If exists is true, return env. Let outer be env. Assert outer is not null. Set env to outer. Note the loop in step 2 will always terminate because the list of environments always ends with the global environment which has this binding, 4.4 resolve this binding. The abstract operation resolve this binding takes no arguments and returns either a normal completion contain on an ECMA script language a value or a throw completion. It determines the binding of the keyword thus using the lexical environment of the running execution context. It performs the following steps when called. Let envrec beget this environment. Return envrec get this binding, 4.5 get new target. The abstract operation get new target takes no arguments and returns an object or undefined. It determines the new target value using the lexical environment of the running execution context. It performs the following steps when called. Let envrec beget this environment. Assert envrec has a field. Return envrec, 4.6 get global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It performs the following steps when called. 2.5 Let current realm be the current realm record. Return current realm, jobs and host operations to enqueue jobs. A job is an abstract closure with no parameters that initiates an ECMA script computation when no other ECMA script computation is currently in progress. Jobs are schedule, ed for execution by ECMA script host environments in a particular agent. This specification describes the host hook's host enqueue generic job. Capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R host enqueue promise job and host enqueue timeout job to schedule jobs. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs. Hosts may define additional abstract operations which schedule jobs. Such operations accept a job abstract closure and a realm record or null, as parameters. If a realm record is provided, these operations schedule the job to be performed at some future time in the provided realm, in the agent that owns the realm. If null is provided instead for the realm, then the job does not evaluate
So like this is like the shader program for Windows, whatever.
The following requirement.
I tried to find one on Linux, but I couldn't.
When there is no running context in the agent for which the
It literally just distorts the screen.
text stack is empty, the implementation must.
So I gotta remake that program for Linux.
Job abstract.
But I'm gonna use that video.
Find cleanup step.
Like just a video I took whatever from years ago.
Context stack must be
I'm gonna like put the desktop into my video.
open at any point.
Because I could use this guy's video, but then I'm like, I'm remaking the program anyways, so I might as well use my own video.
The abstract closure must
So I'm gonna like get the desktop capture into that square
International 2000
when I'm working on code that I'm not showing for free.
one host environment.
Because anything I do that's like free, because it's on the internet, is free. So like, if I do the whole program, if I do the whole JavaScript engine,
Already than other work, future features may add jobs that are not treated at such a high
if I go through this entire standard,
module
but like before the standard 2,
will record
and just show all the code, there'll be no engine release.
the following
Because everyone will just copy me.
script module.
So I gotta go through from page 1 to 816.
The script
Like I'm doing like the entire engine,
topmost X
and I'm gonna meet every single spec in the standard.
script or module component.
Because no engine has ever done that,
Component of
let alone one person.
particular time.
So I'm like set a standard because people don't know how to even meet them in the first place.
Following conditions are true.
And it's just ridiculous, whatever.
Stack is not empty. The realm
And JavaScript is a brand. The ECMA 262 is the standard for the brand.
Jobs have additional
In JavaScript, they claim to be a JavaScript engine,
callback records.
but they're like a car without wheels because they fucking don't even meet the standard.
Find value.
Oh man, time keeps moving.
Quoted by the
I get this done today.
find context.
It's taking way too long to get done.
Job abstract closures should not capture and call function.
Stupid shader program.
Use host make job callback
I found a couple programs on Linux that do what the other program did,
listed in table 28.
but they ate up too much resources. Because this is a 15, 16-year-old computer.
Callback.
I don't know if it's 15 or it's 16, one or the other.
Callback takes argument callback, a function object, and returns a job callback record and implement.
I'm getting my JavaScript engine to run optimally on this first gen i7,
Callback record whose
because this is a one potato computer.
reference may prepare an execution to evaluate code by pushing execution contexts onto the execution context stack. The
So 860, 2.8 gigahertz.
choice of realm is up to the host environment. This initial execution
What's that chatbot?
in use before any callback function is invoked. When a callback function related to a job, like a promise handler, is invoked, the invocation pushes its own execution context and realm. Note the WHATWG-HTML specification, https://html.spec.whatwg.org, for example, uses the host-defined value to propagate the incumbent settings object for promise callbacks. Field name, value, meaning, callback, a function object, the function to invoke when the job is invoked. Host-defined, anything default value is empty. Field reserved for use by hosts. 158, ECMA International 2024. The default implementation of host make job callback performs the following steps when called. 1. Return the job callback record. Callback. Empty. ECMA script hosts that are not web browsers must use the default implementation of host make job call.
And there's a difference between
List call job callback. Job callback. V. Arguments list.
consumer grade products
Job callback takes argument.
and non-consumer grade.
Callback record.
As a consumer,
MA script.
we all get fucked. We pay so much money
CMA script.
for shit for the bottom end.
Returns either in
Like you think the i9 is fast.
a script language.
You're buying a consumer grade product.
Form to the
You don't know what fast is.
perform and return the result of call. Job callback. V. Argument.
We, like, those of us that live in first world countries,
When called
we think we're first world,
back is true. Return.
but no. I don't know.
List. ECMA
Money privilege, they go hand in hand,
must use the
whatever.
implementation of host call job call
So message chatbot,
for host enquire generic job. Job. Realm. The host-defined abstract operation host enquire generic job takes arguments job, a job abstract closure, and realm, a realm record, and returns unused. It schedules job in the realm.
alright, so message chatbot.
ECMA 262. What is the current gen of the Intel i7/i9 lineup and compare the first gen i7 860 at 2.80 GHz to the most advanced consumer grade i9. One. What is the current generation of Intel Core i7/i9?
Alright, so it's 14. Alright, so I'm like setting up my JavaScript engine to support the first generation i7 to the 14th generation i7. So anything that runs on this one potato i7 will run on a 14 potato i9. Clearly, I need to add support for the newer coprocessors that are added on to the 14th gen i9. And clearly, I understand that I have to do that, so it's not like running code designed for the first gen i7 will just magically run 14 times faster on the 14th gen i9. I have to write an assembly, and I have to like actually scrape the bottom of the barrel for every little bit of performance that's available. And I gotta do that after I just like get stuff set up for the first gen i7. So like this is like the baseline computer for my engine, whatever. I don't know what Chrome V8 was designed for. I'm pretty sure it's designed for whatever the most modern CPUs at the time. So I'm going a little bit backwards in supporting old tech and working my way up. Because I believe that when you buy a machine, you get what you fucking pay for. It doesn't matter what year it is. It doesn't matter whose pockets need to be padded. That software shouldn't intentionally be written. I don't know, whatever. I still gotta pick a base video card if I'm gonna go full competition and write an engine and stuff for like video games and stuff. Right now I'm just doing JavaScript, but I may have to take it a step further. And I need this shader program done. I'm tired of programming in C. I need to write an assembly. But like, when my whole screen is on display, I want to stream every little thing to show, I don't know, the process, whatever, but I can't show all the code I'm doing. So I need to be able to click a button to like distort the screen. So you can't see what I'm working on, but you can see that I'm working. And there's stuff I want to test in assembly that I can't do right now. I need to write an assembly. I can't take C programming. C programming is just as bad as C++. I hate C. Because of like the CPU, whatever. The diagram somewhere. So like, hardware development is difficult. You design a chip, and then you rely on programmers to write code for your hardware. So it takes really intelligent people to make hardware. But anybody can write code. So like, Intel makes CPUs, whatever. And what was it? Windows 90, whatever. Chatbot is so biased and it's always wrong. I hate asking Chatbot. But it's slightly more convenient than Google. What version of Windows? Only allowed 64 kilobytes of stack space. Okay, so 16-bit Windows. It was on a 32-bit CPU. There's like a disconnect between hardware and software. So asking chatbot in 16-bit Windows ran on 32-bit CPUs? Question mark. Now, do you know why they're based off these CPUs? The 8086 and the 80286. Because Gary Cadell he wrote CPM whatever. He's a teacher, whatever. And he wrote the operating system, CPM, whatever it was called, for specifically the 8086 and the 80286, and also lower end, low powered, low spec CPUs. So he designed an operating system for 16-bit CPUs basically. And Windows stole DOS from him, legally though. And Windows was stuck with this 16-bit CPU software operating system, but 32-bit computers were out. And at some point, the hardware had to add things that the operating system wasn't capable of doing because they stole the operating system from Gary Cadell in the first place. So the hardware company had to step in and do stuff. So like hardware, whatever. Eight oh eight, 80386. It's like paging for virtual memory. For page tables. Alright, so computers, they run off segmented memory. That means the physical RAM that you plug into your motherboard that you buy on the internet by this very poorly depicted ASCII character map drawing, whatever. Was it DDR5? Alright, so your motherboard, right? This RAM that plugs in motherboard. And what's funny is that you spend a shitload of money on a high-end computer and then you run Chrome V8 and you're wasting performance, high-end, top, best in line you can buy gaming computer, and you run Python and you run JavaScript, and that's acceptable. The performance of JavaScript is 32-bit based, and that's considered acceptable. So you waste gigabytes and gigabytes of RAM to run the worst, the shittiest, the most poorly designed / optimized software in existence. What a waste of money to buy a high-end computer and then run JavaScript. Except anyways, all this memory, it's managed as segments. It's not just a big flat piece of memory. Because you can see there's like 2 chips here on this board. This board has 4 chips, so I don't know, whatever. So physically, as you can see, it's separate chips. So at CPU level, it's actually accessed as separate chips also. But on Windows, in the modern OS, you get a flat memory, which means memory works like this. You get like an address, like here, whatever, 0x, blah blah blah, and it's all just a flat memory address. And then theoretically it's treated like if you have 32 gigs installed of RAM, of motherboard RAM, you can just access RAM very simply from 0 to 32 gigs. And that's how it's done. That's not at all how it works behind the scenes. Behind the scenes, there's a memory map manager on the MMU, on the motherboard, whatever. And things have changed over the years. Certain things are like absorbed into the processor. Some things are rejected. So I don't know, things change all the time. But basically, there's an MMU and it remaps the memory for like the virtual space for all the programs. And it splits up the memory and the RAM. So you get like a flat address space. So it seems like one big, large flat piece of memory. But actually, it's not. And that's called segmented memory. And Windows 16-bit Windows wouldn't let you access more than 64 kilobytes of the stack because it would pull different programs into memory and swap them out and pull them in and swap them out. There was no paging on the CPU yet. Wait, was there paging? I gotta double check that. So what CPU was out when, if there was paging, when Windows 16-bit was out, and Windows didn't apply paging? That's ridiculous. I can't believe that would happen. There's no way. Alright, I gotta check. So I'm asking what CPU was out when Windows 16-bit? So what, Windows 1.0? Even at 3.0? Man, Windows. Jeez. Yeah, I'm so tired of Windows. And IBM. So I'm asking it, what CPU was out when Windows 1.1 was out, and at the time of Windows 3.0? I'll Google if they had paging. Damn, 1985. Alright, I'm gonna ask it, what year did Gary Goodall die? I can't remember how to spell Goodall. I have so many other things to remember. 1994. 1985. Huh. It says there's been some subject of debate and rumor. Would you like me to explain the circumstances of his death? (1974). 1975 to 1976. The Zilog was a coprocessor. 1975 to 1976. And then QDOS for quick, dirty operating system. The ripoff of CPM was released what year? Or was sold to Microsoft, IBM. (1981). So 1980. Man, when was the first version of Windows released? Alright, so I'm asking, what was the first version of Windows released, the year also, and what CPU was it designed for specifically? And what IBM machine was that at the time? Because IBM made machines, I wouldn't call them computers. They were like shitty rip-offs of other people's computers. I'll do like /PC. Windows was 1985. Intel 8086. Windows 1 was still 16-bit, segmented memory as MS-DOS. IBM machine available at the time. PC 1984. Huh. So the older IBM PC, 1981, 1808, 8, were still widely in use. Windows 1 could run on them, though more slowly, because IBM makes some crappy hardware, and they just stole everyone else's stuff. That's why Windows ran more slowly in them. Alright, so the 8086. Wasn't the 8088 for a calculator? I didn't know it was in desktop CPUs. Yeah, so the 8088 is an 8-bit microprocessor with 8-bit data bus. And the 8086 had a 16-bit data bus. And I think like Intel wanted to release the 8086 and the 8088 and not distinguish the difference between the two. And have like the instructions that work on both, but one would just be a little bit slower. I think they had to like just pick the 16-bit mode one because it's too much work to like maintain both or something. Alright, where's Wikipedia? Alright, so I searched for the word protected. It doesn't say protected. So it didn't have protected mode, I don't think. Okay, so First version of Windows was released, designed for the 8086 and 8088. Entirely 16-bit, segmented memory. I'm gonna ask chatbot, what CPU, CPM was designed for? CPM is written for the 8088 or the 8080. Man, 8080. Okay, so it's like alright, so there's like the Intel 880, 8080, and 8086. Z80 is a completely separate CPU. And then CPM was written in C language or assembly. I don't know. Ask chatbot. (1974), Zilog 1976, and this guy, he's really smart. Too smart for Intel. Yeah, Intel is terrible. Like, he left Intel, and then he made Zilog 80, Z80, and then the Z80 still did better than the Intel CPU. So really, this guy, I don't know. It literally takes one smart person, and when they lose that person, the world needs more smart people. Alright, so 1974, 16-bit, Intel 886 for 16-bit. So these are all 8-bit, even though they had so that means Gary Cadell wrote his what was it? What's the PLM compiler? What? PL stands for Programming Language for Microcomputers. It is a high-level programming language developed by Goodall. At Intel, wait, he worked at Intel? It was specifically designed for programming 8-bit microcomputers, particularly Intel's 808, 808, and 8080. The language is known for being block-oriented and structured, requiring variable declarations. C language, basically. Before C language was a thing, and utilizing control flow structures like if else then else, and do loops, and supports procedures. Wow. Wow. Intel is a real piece of shit. Holy fuck. Intel is just as shady as IBM and Microsoft. Man, these companies are terrible. And the people that run them are horrible. Holy fuck. Man, they fuck over people. Okay, so basically, the 8086 was first 16-bit x86 CPU. The paging came around 80836. It says this is a mechanism modern operating systems, Windows, Linux, etc. rely on for virtual memory. So 1985. Windows 3.0. Alright, so Windows 3.0, 1985, Intel 80386 had enhanced mode, which is protected mode. It says 808, 80386 here. So 1985 is when paging was added. So, before paging was added, Windows only ran with 64 kilobytes I guess, I would assume. So messy chatbot. So before paging was added, Windows only had 64 kilobytes of RAM per process or program. Oh, so chatbots to be precise. Before paging, memory model was segmented. Each segment could only be 64 kilobytes, but a program could use multiple segments. So total usable memory per program could exceed 64 kilobytes logically, but not for a single continuous linear block. Because now, even though you have however many RAMs a stick plugged in to your CPU, it's treated as a single contiguous, however the fuck you say it, block of memory, even though behind the scenes it's not. So like it's accessed as a program for the user on the operating system as a single chunk of memory, but really it's segmented. Because physically it's segmented, it doesn't just magically become a single chunk of memory that's accessible byte by byte. And then there's like the overhead of paging is like quite a bit. I don't know, I'm already off topic, whatever. I won't get into that. But paging is ridiculous. It's really slow. So Windows 1 to 16-bit, default stack 64 kilobyte. Overall programs were extremely memory limited, usually less than 1 megabyte. Because of the segmented 8086, 286 architecture. After paging 32-bit, Windows Enhanced Mode could map to 32-bit virtual memory, theoretically address up to 4 gigabytes. Paging allowed virtual memory, swapping in protected mode without being constrained by 64 kilobytes. Before 386 paging, a single segment was 64 kilobyte, but programs could combine multiple segments. You weren't strictly limited to 64 kilobytes total, but contiguous memory, or contiguous, however it's said, was limited, making programs large and data handling cumbersome. Paging in 386 flat memory removed these limits, enabling large applications. So, this part here, and that's what I'm saying about paging had to be added to the CPU because the operating system doesn't know how to cook, because the operating system is a piece of shit, and the hardware had to step in and do something because there's more RAM available, but the operating system is designed by people who don't know what they're doing. And the only way that'd be possible for users to like actually use the CPU would be if the operating system had paging or something, or the CPU had to like, the people that designed the CPU had to add things for the operating system because the operating system was incapable of implementing that stuff itself. Alright, so message chatbot. Then why do people complain about only 64 kilobytes on 16-bit Windows? One chatbot said you weren't strictly limited to 64 kilobytes in total. And I'm saying, and if the CPU did not add paging, name one operating system that allowed more than 64 kilobytes that had its own way to manage memory without needing paging. Did the CPU add paging because this OS was not able to adjust its design to enable those features? Question mark. It says, this is a subtle but important historical point. Let's go carefully. So like the dates and stuff up here, you really can't, I guess technically, simply like prove causation because there's so much stuff going on. Except the people that started the whole thing, they did basically get fucked. And the people that profited off everything were the people doing the fucking. Alright, it says, why people complain about 64 kilobyte on 16-bit Windows. Segmentation limits. Each segment can only be 64 kilobyte. Program perspective, a single array, stack, or data structure couldn't exceed 16 kilobytes without segment juggling. Segmentation was cumbersome. Yes, a program could combine multiple segments, but the programmer or compiler had to manage far pointers, segment offsets, and memory copying. This was error prone. So when people said only 64 kilobytes, they meant no single contiguous block of memory could exceed 64 kilobytes, which really limited large data structures. Man, are programmers stupid? I mean, the convenience of being able to access hundreds of gigs with narrow access is nice. I guess that's it. It's just convenience. Because when it gets down to it, yeah, whatever. It has to be convenience. That's why everybody uses C++ and vectors. Nobody knows what they're doing, but apparently everyone can program. Just like how everybody can draw. Everybody can do it. But can it be done well? Well, it doesn't matter when everyone can do it. Were there operating systems that exceeded 64 kilobytes without CPU paging? Yes, by using clever bank switching, overlays, or multiple segments. Some operating systems allowed more memory. CPM. Programs could switch banks of 64 kilobytes in and out manually, but no true contiguous memory greater than 64 kilobytes. So CPM had that ability, but Windows didn't. Is Windows stupid? I mean, they stole CPM, but they didn't get the whole thing. That's probably why it's called QDOS, for Quick and Dirty Operating System. He probably stole parts of it, but not the whole thing. Which is probably why, legally, they got away with it. Because they only had parts of the OS, not the whole thing. Apple DOS, ProDOS, used bank switching to address more memory than 6502, 16-bit address space. Wait, what? Apple ran off of 6502? There's no way. Apple's early computers did use the 6502. It's not Intel. What? Apple 1 was a 6502. I thought Apple ran on, what was it? Like PowerPC. Was PowerPC 6502? Man, I just lost my question. Oh, so Apple switched from 6502 to the Motorola 68K, then to PowerC, to PowerPC, then to Intel, then back to basically 6502. Because 6502 is like ARM based or kind of, with, well, that's nuanced. Why is CPU added paging? CPUs didn't wait for operating systems to figure it out. The OS could have tried overlays and segmentation tricks, but these were messy and didn't scale. Paging on the 80386 gave the OS full control over virtual memory protection in large contiguous address space without programmers manually juggling segments. In other words, paging made memory management safe, scalable, and automatic. Something impossible with 16-bit CPUs alone. 64-bit complaints was over the size of it. CPU paging was added because operating systems couldn't make large protected linear memory simple and safe without hardware support. That's ridiculous. I'm gonna ask chatbot. Is it possible for an operating system to implement paging without hardware support? And I kind of like lost point of what my original point was. You know, I started like learning some new stuff, and I'm like distracted. I didn't know Apple ran Alpha 6502. So I was like complaining about memory and how like by a computer you have gigs of memory of RAM, whatever. It's like a waste to run JavaScript or Python because it takes gigs of memory to run those programs. And the performance is so like crappy that's kind of pointless to buy a high-end computer if it's not gonna run high performance programs. And I got into like memory and how like it used to be managed, how it's managed, and how the hardware developers had to actually update the CPU because as chatbot said here, the OS wasn't able to figure out how to do it because the operating system is written by idiots. And it says right here too, CPUs didn't wait for operating systems to figure it out. The OS could have tried overlays, segmentation tricks, but these were messy and didn't scale. So basically I'm getting at hardware is hard to design, and software developers are like writing programs for the hardware. Very lazy. Most of them don't know what they're doing. And the people that write the operating systems, they're even worse. And that's why the hardware had to like design things for the operating system, because the operating system, they don't know what they're doing. They wouldn't be able to figure it out. So like everything that's been added to the CPU or whatever, they add things whatever to the CPU. So like I'm setting up my engine for the first gen i7. I gotta get to the stupid standard or whatever. Except when I meet the standard for JavaScript, I'm gonna meet the entire standard, but I'm also setting it up, like I said, for first gen i7. Because computers, they update over the years, new things are added. Operating system, like apart from that. So I'm like add support for all the stuff along the ways. So like whatever runs on first gen i7, I'm gonna make sure it runs on the 14th gen i9, whatever it is. So the performance between my engine, between the modern JavaScript engine, there should be a huge difference when I'm done. I'm not gonna say how much, because if I said how much, I doubt anybody would try to beat me to it, because they don't believe me anyways, so it doesn't matter. But if I said how much faster, then someone could like go, oh, that much faster, and then know how much to adjust the engine to make it faster to beat me. So if I don't say how much faster it is, nobody knows how much faster it is. So we can release it, and then it'll be known wherever. So, I don't know. It's stupid to run shitty programs on a high-end PC. But basically, when I meet the standard and stuff, and I release my engine, I'm designing it for high-end computers. and stuff. So like running my engine will actually take advantage of the CPU and the hardware. Because right now, nobody does that. And apparently performance is a joke or whatever. Because it's like, just run Python, just run 32-bit JavaScript, just run all this crappy software. I don't believe with that. I think like you buy the machine, you get the hardware, the software should run just as optimally as hardware does. So that's why I'm like writing my engine for first Gen i7 and then like the 14 Gen i7. And why I think performance is like an important, a big deal, the main thing, whatever. Alright, so I don't know. I think that covers everything. That's trying to talk about whatever. It's like paging, whatever. I message chatbot. Is it possible for an operating system to implement paging without hardware support? I don't know, do that. I gotta wrap this up. I had a point, but I got like a bunch of things to look into now that I didn't know before. So I can have an even better point if I like look up all this other stuff. A much sharper point. So it says yes, it is technically possible, but with major limitations on overhead. Let me break down carefully. So here, major limitations and overhead. MS chatbot. MS chatbot. How much performance is lost to paging on the XE6? What is the cost, performance-wise, of no paging versus paging in percentage? Because chatbot said it's possible for the OS to do, but with major limitations and overhead. Except paging itself has major limitations and overhead. It says the performance cost of paging on XE6 depends on heavily whether the page is already memory or not. Whether you have translation look side buffer hit misses. Let's look side by side. So paging, if it's in memory, 0%. Occasional table lookup, 5 to 10%. Page fault, hundreds of cycles milliseconds. Software only paging, 10 to 100 times slower. And no, you can get software only paging really fast. To the point where you don't even need paging. That's a lie. Hardware paging has very low runtime cost. That's a lie. How do I ask it? update the website. Alright, so first, I said is it possible for the operating system to implement paging without hardware support? It said it could, but with major limitations overhead. CPUs have a memory management unit that translates virtual address to physical address. The MMU automatically traps accesses to unmapped pages, enabling virtual memory protection and demand paging with minimal CPU overhead. Before hardware paging, an OS could simulate paging using software techniques. Divide a program into segments, swap segments, being switching, traps, illegal memory access. Some systems would deliberately access invalid memory address to trigger a software interrupt, then handle mapping in software. This is much slower than hardware MMU paging. Alright, so I'm gonna ask you about MMU paging does not involve traps at all. So Chatbot said traps, illegal memory access, deliberate access memory to trigger software interrupt, then handle mapping software. He says this is much slower than hardware paging. So I'm saying, to state and pasting what it said, then I'm asking, so paging does not utilize traps. It's a primary mechanism for how it is implemented, of how it is implemented, or of its, I don't know, whatever. Here we go. Exactly. Paging does not rely on traps for normal operation. Let me clarify. Hardware paging, CPU automatically translates normal memory access if the page is present, permissions are correct, no trap occurs. Only exceptions, trigger traps, page fault. The page is not memory. CPU generates a page fault exception with the OS handles to load the page or terminate the process. Traps are secondary. Paging relies on traps. And it says up here, it says, traps via illegal memory access very slow. Chatbot says, some systems would deliberately access invalid memory to trigger a software interrupt, then handle mapping in software. It says this is much slower than hardware paging. I asked Chatbot, is it possible for an operating system to implement paging without hardware support? And Chatbot says, yes, it's possible with major limitations overhead. And then Chatbot says, traps are much slower than hardware memory managed paging using protected mode. Except protected mode inherently relies on using traps. That's how protected mode works. And then Chatbot says, let's be precise here. And it's just full of bullshit. And then I said, so paging does not utilize traps as a primary mechanism of how it's implemented. The chatbot said exactly, paging does not rely on traps for normal operation. The CPU, blah 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 blah, no trap occurs. Only exceptions handle traps. Only exceptions trigger traps. So traps are secondary for handling exceptions. Software only paging. On CPUs without MMU, some systems tried to simulate paging by deliberately accessing illegal addresses, causing a trap. Man, these people don't know how to write an operating system. It says this makes every memory access potentially very slow. That's funny. This makes every memory access potentially very slow. That is literally what using protected mode does. It makes every memory access very slow. There was a percentage on this website last time of how much slower the paging was, but I don't see it anymore. So, I don't know. There's a couple different percentages. And it might not have been this page. I don't know if I find it later, I'll find it. Alright, so I'm gonna ask Chatbot. Is CPU hardware protected mode possible without paging? my chatbot, is it possible for protected mode at hardware level to be implemented without the utilization of traps at all? Name one instance of anything where protected mode is in use without the need of traps as a fundamental mechanism for the paging operation itself. How the fuck you spell mechanism? It says yes, it is possible, and in fact, this is exactly how modern x86 protected mode with paging works. In normal operation. Chatbot is such a piece of shit. So I'm saying, no, I'm not talking about normal operation. I'm talking about operation as a system in general. Is it possible for protected mode to exist without the utilization of traps? Yes or no? Do not give me bullshit. So I'm asking chatbot, no, I'm not talking about normal operation. I'm talking about operation as a system in general. Is it possible for protected mode to exist without the utilization of traps at hardware level? Yes or no? Do not give me bullshit. And chatbot says, no. Chatbot says, no. Protected mode fundamentally relies on hardware enforced privilege checks and exception mechanisms to enforce memory protection, segmentation limits, and page faults. Without traps at hardware level, the CPU cannot prevent illegal memory access or enforce privilege levels, so it cannot implement true protected mode. And even protected mode is not even protected. Traps are integral to the system level enforcement of protected mode, even if normal accesses don't trigger them. The CPU runs so much slower in protected mode. The high-end, high-performance gaming computer you buy runs protected mode. The modern OS is garbage. The computer is so much faster than it runs right now. But I am only writing a JavaScript engine, so I'll talk about the CPU later. But as a customer, you really get ripped off using Windows or the modern OS, especially if you're running software like JavaScript or Python. The CPU is so fucking fast without all the shit. So fucking fast. And the fact that chatbot says that it's not possible for an operating system to implement memory protection without traps and all this stuff, is then saying traps are slow when protected mode relies on traps. It fundamentally relies on hardware enforced privilege checks and exception mechanisms. there is no reason for hardware to make like paging. It's because the people writing Windows don't know what the fuck they're doing. So the hardware had to step in and make some kind of like attempt to help the operating system. Because the operating system is complete trash. So the first Gen i7, which is this computer, .860 whatever, 2.8 gigahertz. So I don't know, there's like a history with computers. Yeah, the ones that made it, the ones that are in use now, they all have baggage and stuff. Except I want to support, or well, I'm going to support the first Gen i7 all the way up to the modern i7. So like this i7 is from 2009.
Intel Core i7860, first gen, Linfield, released around 2009. Now extremely outdated. Single thread and multi-thread performance are modest by today's standards.
Modest. So it's outdated, except the multi-thread performance is modest. That's because the newer computers aren't really that much better.
Most advanced consumer-grade i9 let's compare with Core i9 149,900K, 14th gen, and Core Ultra 9285K, Arrow Lake, Core Ultra.
Alright, so the i9 I guess.
8 performance plus 16 efficiency equals 24 threads.
I don't know, chatbot's just giving a bunch of stats. It's not really comparing them. It's comparing like the Core i9 with like the Core Ultra 9. It's not even comparing the two I asked. So basically, the CPU on this computer is like first Gen i7. It's really not that slow. But it is, in some aspects, whatever. Except it's 2009, whatever. So I'm writing my JavaScript engine. Might get the shader program done. Might get the standard for this first Gen i7 computer. .2009 computer. And after like, so like it's gonna run for this computer first. I'm gonna get everything running. I'm gonna optimize for this one potato computer, then these 14 potato computers, the newer ones. Like the Core i9, whatever. I'm gonna count for like the extra threads and stuff to make sure my engine utilizes threading more like effectively, whatever. Because this computer doesn't have many threads. And the cache is way smaller. So I do have to like rewrite and add more code to the program for the newer CPUs. So like, I don't know. I'm gonna support the base CPU and the more modern CPU. Because really, it's not like a hardware thing, it's a programmer thing. The laziness and like the performance of JavaScript, Python, all the modern everything, it all comes down to the programmer, but also the OS, because I can only do so much on Windows. Without Windows, so many things are possible. So I don't know. I'm really disappointed with everything. It's 2025 and everything is shit. So I'm gonna like get this stupid engine done, release it, and that'll be a start for like less shit, because everything's literally shit. I don't know. I got like Apple ran off a 6502, the Apple one. I just found out like a bunch of like interesting facts that I gotta look up. So I don't know, I'm like distracted now. I get some more pop. Alright, I gotta like get this done though. I gotta focus. I'm gonna get some pop, try to focus, get some done. There's something else. Whatever, remember, whatever. I'll get some pop.
Primary expression, this, literal, array literal, object literal, function expression, class expression, generator expression, async function expression, async generator expression, regular expression literal, template literal, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, member expression, expression, member expression. Identifier name member expression template literal super property meter property new member expression arguments member expression private identifier new expression new expression left hand side expression call expression, optional expression, return false, comma 4.5 runtime semantics, named evaluation, the syntax-directed operation named evaluation takes argument name, a property key or a private name, and returns either a normal completion containing a function object or an abrupt completion. It is defined piecewise over the following productions. Primary expression, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N. Let X be the parenthesized expression that is covered by capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N. Return named evaluation of expr with argument name parenthesized expression assert is anonymous function definition expression is true. Return named evaluation of expression with argument name function expression.
Like memory management
Return
and accessing memory and data.
P A N T I A T E, capital O R.
That's like a huge factor
Y
on everything computer related. like how you access the main RAM.
N, capital E,
That's like the bottleneck of every single freaking program,
greater expression, function, formal parameters,
is how the secondary memory, because the CPU die,
F,
that's fast memory, but the secondary memory, the RAM on the motherboard,
A, T, E, capital G,
how that's accessed is literally determines the entire program.
capital F, U, T, I,
And it sucks.
capital E, X, of generator expression with argument name, a synth generator expression, a synth function, formal parameters, a synth generator body, return, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital G, E, N, E, R, A, T, O, R, capital F, U, N,
Like
E, of a synth generator expression.
vector in C++.
Copyright sign, ECMA International 2024, a synth function expression.
And like anything on like how people normally manage memory.
Body 1. Return, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital F, U, N, C, T, I, O, N, capital E, X, P, R, E, S, of a synth function expression with argument name, arrow function, arrow parameters equals, concise body, return,
Alright, so let's check out.
vector in C++. What does it do when the allocation limit has been reached?
And it's a pub. And Shepard says,
In C++, when you use a std vector, it manages its own dynamic array. If you keep adding elements to the vector using pushback or similar methods and it reaches its current allocation limit, that is, capacity, here's what happens under the hood.
there's way too much stuff going on under the hood. I'll just have Shepard read it. I don't know, memory is like the main thing in any program. And when you write a program, or at least I don't know what I figured out as I write programs, you gotta work around all these like stupid, I don't know, I want a new operating system because modern OS is garbage. Yeah, I gotta stop complaining and get something done. But like, the CPU, if you remove all these things going on, all these things like,
Under the hood.
and if you like, or if someone were to rewrite things, the OS would be so much faster. Like, insanely faster. Just like if someone were to do with JavaScript. Just rewrite JavaScript, bottom up. Make it a lot faster.
When a std vector reaches its allocation limit, backhand index finger pointing right, it automatically reallocates a larger block of memory. 1. New allocation. A new, larger block of memory is allocated, usually double the previous capacity, but this growth factor is implementation defined. Point 2. Element copy move. All existing elements are copied or moved into the new memory block. 3. Old memory freed. The previous memory block is deallocated. 4. New element added. The new element is inserted.
So basically, C++ and how every modern program runs. You have an array of data in a vector. And it has to be a flat, linear chunk of memory. Even though CPU is split up into several chunks, linear memory is like the big thing. So instead of treating this as separate chunks in the first place, like segmented memory, the programmer is expected to make a copy of this memory to a new location, a bigger chunk of memory. This is like chasing your fucking tail. It's not a linear memory was not the problem. I mean, the solution to the problem. The solution was to teach people how to write a program with segmented memory and to come up with like good ways to implement programs in that way, not to just use flat memory. So with segmented memory, I mean linear memory, you make a new allocation twice that size, and you make a copy of it to the new allocation, and then you can access more memory. But you have to copy it over. So like if it resizes again, then you take this new size, you make a new allocation, and you have to copy everything over to the new one. Each time you need to like resize. So like let's say it's like this is maybe like 10 bytes. So in 20 bytes, 30 bytes, 40 bytes. Except data structures aren't usually that small, usually around a couple hundred bytes. So every time you resize, it's copying hundreds and thousands of bytes. The high-end PC is wasting so much of its performance on copying data. And it does cache it, but that caching comes at the overhead of caching, and there's a huge overhead to caching. If an operating system were written, if so, that removed both these limits, took off the hood, that would like unleash real performance. Because the CPU is so baby right now. Because the operating system is crap, and programmers don't know how to program. Which is why hardware had to add paging in the first place.
Drawing pin, important details, growth strategy. Most implementations, like GC Celebs++, double the capacity when more space is needed. For example, 124816, copy move constructor call. When reallocating, the elements are moved if possible. C++ 11 onward, or copied if not. Invalidation, reallocation invalidates pointers, references, and iterators to elements in the vector. Summary: When std vector reaches its allocation limit, it automatically allocates a larger buffer, moves copies elements to the new memory, deallocates the old one, and continues growing. This is why it's amortized constant time for pushback.
That's why I hate programming. For this at least. Like right here, I have to make a call to make a new allocation to resize it because I have to make a copy of the old data and put it to a new allocation. That's ridiculous. And it's so annoying. I hate having to like write code like this. It feels like a waste of time. And I have a loop here. I gotta loop through and copy the stuff from A to B. And I gotta free the old memory when it's done. Because linear memory is really dumb. I hate everything about 2025. Everything is so fucking out of date. And the CPU wastes so much time with memory. And then, the best thing, or like the worst thing, well, the best, depending on how you look at it, if you're writing an operating system to compete with the modern operating system, the good thing is that nobody knows how to manage RAM without memory leaks. So it's not that hard to compete to make a new operating system that doesn't leak memory from the first place. So I guess it's a good and a bad thing, depending on perspective. So maybe it is a good thing that computers are so poorly designed. Well, the software part, the hardware is pretty stable. Because the hardware has to literally make up for the software part. So it says, when it reaches the allocation limit, it automatically allocates a larger buffer, moves copies, deallocates the old one. It continues growing. So if you like, draw that up, whatever. Yeah, like linear memory. Alright, let's say like, let's say you have like 64 gigs of RAM. But you have like a 2 terabyte hard drive. So you got like this much RAM. And like this much hard drive. So like, that's not to scale. That's just example. So like, with linear memory, behind the scenes, paging will remap the 2 terabyte to 64 gigabyte. So 64 gigabyte can only hold 64 gigs. But if you have a 2 terabyte hard drive and you use over 64 gigabytes RAM, which you probably won't even do in the first place, because most programs don't even know how to use RAM. You can only access 64 gigabytes at a time before you go to the main memory. So it gets like partitioned up in little chunks scattered across the hard drive, if you ever even reach hard drive level. But basically, let's say you have like an array of you have an array of vector. Let's say you have an array of vk device q create info. So you have an array of these, right? I mean, let's say there's like 100 of them. So they're not going to be like small things, maybe like 400 bytes each. Let's just say like it takes up 1,000 bytes. Alright, so like, let's say it resizes, you need to hold more VK device Q create info things. So you need 200 or you need 300. So you make a new allocation in the linear memory. Let's see, it's like here, whatever. Alright, so now this is 3 times the size of the first one, which had 100. It's 3 times bigger. So the CPU sends to the memory management unit that manages the RAM of the system. The RAM, you know, like the RAM you buy for your computer. And that, it's just chip whatever, finds more space to map. And it gets like 3 times the space, so you can use this, whatever. So it passes back the new allocation, this one, for use. So now when you get it, you can copy those 100 bytes over to the new one. So now those 100 bytes have been copied over a new one. Except that wasn't a small allocation, it was like maybe like 5,000 bytes or something. So the new one, let's just say like whatever 5,000. So the new one, when you do 5,000 bytes, you add more memory. You add more memory. Now you have 5,000 times 3 bytes. when this has to resize again, it's going to allocate more memory. However many times big it has to be, is going to waste CPU time copying all this over the new one. And every single program does this. Every single program, most of them use SCD vector. Every single program. Let's say you work with segmented memory. You have like 100 items. And like, let's say that you split it up because it's smaller banks of memory. So you have like 50 items on the left hand side and 50 on the right one. And let's say you have to add more bytes, or you need more memory. Because you want to make, or you need to add more VK device, create info queue things. Because you didn't have enough, you need more, just like the other case. So let's say you want to allocate 3 times the amount. The CPU, whatever, will find like 2 more banks of memory, assuming there's memory, pass it back for use. Except the CPU doesn't need to find 3 times the amount of memory. Because now that I'm using segmented memory, I don't need to allocate 3 times the space. That it was here. I only need to allocate 2 times. Because I already have the 1 chunk, I only need more chunks. So now, there's more memory. I didn't have to copy. So these original 2 chunks, they exist here. And the new chunks are there. Oh my god, would you look at that? Now I can hold 300 items, 3 times the amount as first, and I didn't have to copy memory from A to B. I wonder how much faster a computer would be. Like, let's say like I have to resize it 10 times bigger, so I need to hold like 10,000 items or something. If it's fragmented or segmented memory, or designed in a way to handle that, then you just make more memory that you need. Well, it wouldn't make memory, it would find it and then pass it back for use. So it would find more memory, you could use it. And whatever memory you had at first would still be used. So you can add memory to the existing memory as segments. And there's no need to make a copy and a copy and a copy and a copy every single time. Segmented memory makes so much more sense than linear memory. The CPU could run so much faster. The amount of time wasted making copies of copies of copies. If the CPU was able to allocate memory, it didn't have to waste time making copies to the new place memory. The whole system would be so much more responsive quicker, even quicker than it already is. And I don't know, that's why I'm like annoyed with setting up this stupid thing for like simulating C++. But it's not just this. This API, whatever, expects flat arrays. So really my problem is with programming in general. And like the lazy factor. Because the lazy factor is so high. And I hate having to like make an array and having to like copy it. To like a new allocation. It feels like a waste of time. Because if things were set up, segmented, whatever, this wouldn't need to be done. And I could just like keep track of a descriptor and link on new things. So I don't know, memory in memory management is like a huge deal when programming. And like so many people don't have that figured out. So Mass Chatbot,
How much time is spent of the CPU resizing vectors, copying to new copies of other copies only to copy again later, would you guess? In percentage form. ChatGPT said, "Great question, and a very practical one. While the exact percentage of CPU time spent on STD, vector resizing, and copying depends heavily on your program's behavior, I can walk you through some concrete insights and estimations."
here it is.
In real-world programs that don't optimize vector growth, 10-40% of CPU time can easily be spent just reallocating and copying, especially for complex object types. With good design reserve, move semantics, this drops to almost zero.
Here. You can reserve as much memory as you think you need. But the program needs to resize at some point. And the whole like flat memory addressing mode is really stupid. If the whole thing was designed around segmented memory, and the operating system wasn't a piece of crap. The expensive gaming computer that you buy, it wouldn't waste 10 to 40% of the time making copies of copies of copies. That means your computer could run at least twice as fast. And this is like, Chatbot's like accounting for a program. The computer runs like 10, 20, 30 programs. And they're all using vector, and they're all vector of some sort. I don't know. Modern computing is a crapshoot. The CPU wastes so much time on stupid little things. Alright, I gotta like try and focus because I'm done. So I don't know. Might meet the standard. I have different opinions on tech and how things should run. So I think like my engine, there'd be like a big difference performance.
The has binding concrete method of an object environment record envrec takes argument in a string and returns either a normal completion containing a boolean or a throw completion. It determines if its associated binding object has a property whose name is n. It performs the following steps when called. Let binding object be env.
Alright, so I think like set the stuff up now, whatever.
Binding object n if found.
I'm done with like my little rant on memory.
If envrec is false.
Like
Let unscopable.
CPU memory is like the big factor of everything. It's just ridiculous
Then a let blocked beta boolean
how it's like not optimized at all.
n b if
It's really annoying.
return false, return true, comma 1
But luckily, using vector,
ding n d
after I get it all in place,
binding concrete
I don't have to deal with that again. It's all just behind the scenes.
takes arg
And I can call vector, let's just do what it does.
boolean and returns
And then like waste
store a throw completion
10 to 40% of the CPU time until it gets running. Once it gets running and all allocations are made,
value and
it becomes static at some point,
the new property.
so then it doesn't waste CPU time.
Otherwise it is set to false.
So I guess it does depend on the program, how much time is wasted, because sometimes the program doesn't have to always keep resizing. Lots of times it does.
Binding object n property descriptor undefined
So I'm gonna like
true d return unused
finish this up, then that's like, I won't have to worry about allocating memory. Just use vector call
environment record is with environment
and get this demo running.
record is created for a with statement.
Where it puts the image.
It will not have a binding for
That's the quad.
the semantics of defined property or throw may result in an existing binding being replaced or shadowed or cause an
It's just whenever I have to like
international
deal with making a copy of data to a new copy,
9 1
I just get annoyed because it's like I gotta waste time making these stupid loops and stuff.
immutable binding concrete method of an object
So I got that set up. It looks like it's working
specification
because I ran it
1 2
and I checked it and it literally looks like it's working. It's like the simplest thing ever.
binding concrete method
It's just annoying to do.
and record env
So that's done.
then a string and v an ECMA script
So I gotta add these two modes,
either a normal
4 or 5, whatever,
unused
so I can get the address and so I can access this array.
the bound value of the current binding of the identifier whose name is n to the value v
Then pull out C++, put my stuff in,
rec set mutable binding n v
get the shader program running,
used comma 1 1 2 5 set mutable binding
and I can get rid of the spinning quad because I actually have it in the window
method of an object environment
and make the shader program.
rec takes arguments n
And then I can get back
ECMA script length
to JavaScript Engine
a boolean
and adding all the mechanics from the standard.
containing unused store a throw completion. It attempts to set the value of the
Oh, this is so boring.
associated binding object's property whose name is n to the value
Almost done though.
normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called. Let binding object be envrec. Let still exist is b. Has property binding object n if still exists is false and s is true. Throw a reference error exception.
I complain about like
Binding object
memory, whatever,
v.
on the CPU.
Return unused, comma 1 1 2 6
I really can't talk about optimization.
you concrete method of an object
I should just keep that to myself.
takes arguments n a string and s a boolean
I don't know, whatever.
either a normal
I'm gonna add these two modes, try to get this running.
language a value or a throw
Once this program's done, I can actually get back to JavaScript Engine.
whose name is and the property should already exist.
So I'm gonna find the macro
It performs the following steps when called let binding object be
that initializes the types when it's created. This thing, whatever.
false. Then, if s is false, return undefined. Otherwise, throw a reference error exception for
And then I have to add
binding object n, 1, 1, 2,
for these whatever.
n. The delete binding concrete method of an object environment record envrec takes argument n, a string, and returns either a normal completion
These two lines.
row completion. It can only delete bindings that correspond to properties of the environment
I need to make a define.
value true. It performs the following steps when called. Note in this specification, all uses of create mutable binding for object environment records are immediately followed by a call to initialize binding for the same name. Hence, this specification does not explicitly track the initialization state of bindings in object environment records. 2. Let binding object be envrec. Return binding object N40 ECMA International 2024 9 1 1.
I spell parentheses.
It has this binding. The
Just like parenth.
of an object environment record envrec takes no argument.
So like right now I have this mode
It performs the following steps when called return false, 1.
where it's in a block scope.
9 has super binding. There has super
So you need to define a begin and end for a block.
vrec
For the beginning and the end.
false. It
And then for parentheses, for instance close parentheses instead of a block.
1
I can define this.
row with base object. The with base object concrete method of an object
Call it list or something, I don't know.
rec takes no arguments and return.
And I gotta like put this at top bottom.
It performs the following steps when called. If envrec is true, return envrec. Otherwise, return undefined, 1 1 3 function environment
So now I have two options. I can have a block or I can have a list.
environment
So then if I glue to these
scope of a function and if the
a word or a number,
provides this binding
I could tag 4 to this one,
function
5 to this one,
function environment
and then now
is the state that is used to
I can make this macro do both things.
function in
It'll do textual replacement,
fields listed in table 18. Table 8
but it'll do either a block,
record
if I need a block like it is right now, or
provided this binding note object
if it's the mode that's defined to have parentheses, then it'll be a list,
view and EC
like here, whatever on the right hand side.
value. This is the this value used for this invocation of the function. This binding status
It didn't copy, that's cool.
or uninitialized. If the value is lexical, this is an
So now it's like a list.
have a local this value function object.
So like modes 0, 1, 2, 3 are all scopes.
An object whose invocation caused this environment record to
So define this as like a base or something,
or undefined. If this environment record was created,
and then from that,
is the value of the new target parameter. Otherwise, its value is undefined. Copyright sign, ECMA International 2024 41. Function environment records support all of the declarative environment record methods.
I'm adding
6
these two modes.
specification
So 4, 5.
except for has this
Right now I have mode 2. So mode 2 is still going to be a block like it was.
support the methods listed in table 19. Table 19. Additional methods of function environment records. Method purpose. Find this value v. Set the n record that it has been initialized. Get
So this is mode 0,
value of this environment.
mode 1, mode 2,
Throws a
mode 3,
this binding has not been initialized. Get super base.
mode 4, mode 5.
For super property accesses bound in this environment record. The value undefined indicates that such accesses will produce runtime errors. The behavior
Oh, I did that backwards.
specification methods for function environment records as defined by the following algorithms, 1.
So this needs to go on the right hand side.
And this value, v. The
I'll call this like select.
method of a function environment record envrec takes argument v, an ECMA script language value, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called assert. envrec is not lexical. If envrec is initialized, throw a reference error exception. Set envrec to v. Set envrec to
Programming sucks.
1. 1.
I hate programming in C.
This binding. The has this binding
There should be better everything. Everything is subpar.
takes no argument.
This is the dumbest way to have to write a program to do what I need.
Steps when called if envrec.
Because I'm stuck to the fucking language.
Otherwise, return true 9.
I hate everything.
1. 3. 3 has super binding. The has super binding concrete method of a function.
I'm not gonna use C++ though.
Takes no
Because C++ is garbage. It's trash.
performs the following steps when
Alright, so now
rec is lexical.
what I do is I do this.
If envrec is undefined, return false. Otherwise, return true, 1.
And then the thing to select, whatever mode it is, the macro. 1, 2, 3, 4, 5.
Function environment
Whatever one it is.
takes no arguments and return
That gets passed in to here, whatever.
script language of
Behind the scenes I glue to select the number passed in.
called a
So if it's 2,
rec is not lexical.
then I'll pick the block. Because for 2,
Throw a reference
for this keyword with the number 2,
42 ECMA
right here,
2024 9 1
I have it defined to this,
get super base
which is here,
base concrete
which is a block scope.
record en
So for the 2 macro,
and returns
it'll template the code to put this,
not or undefined.
so it's correctly the block.
Performs the following steps when
And then for the 4 or 5 mode,
home is undefined. Return undefined. Assert.
what does it glue here?
Return home.
Pass in 4 or 5, let's say 4.
Environment record.
I look for this macro name
Record is used to represent the out
with the number 4 glued to it.
ECMA script elements that are processed in a common realm.
I go down here,
And record provide
it's right here, which means 4 is going to get these two,
the global
because these both have 4.
declarations 8 2 9 the 8th of February 2000 and
So then this macro, where it's used,
environment
when it's 4, we'll get these,
is a composite encapsulating an object environment record and a declare
which hold these, which is a list.
environment record has as its base object the global object of the associated realm record. This global object is the value returned by the global
So these macros will be list formatted.
The object environment record component of a global environment record contains the bindings for all built-in globals, clause 19, and all bindings introduced by a function declaration.
So I can use the same macro
Declaration. A
and get either blocks or lists.
stable statement
Lists or blocks.
other ECMA script declarations in global code are contained in the declarative environment record component of the global environment record. Properties
So you get the same thing, or the different list or block mode with the same macro
the global
by just gluing the name.
contain both bindings
Because the language is a problem in this case.
generated
Because this language, C language, it sucks just as much as C++.
declaration.
Just as much as the memory management. It sucks.
Properties of the global object
There are solutions to all these problems.
bindings were explicitly
I'm tired of everything. It's all garbage. I'm tired of all of it.
contains a list of the names bound
So I gotta start bringing change or whatever, because nothing's gonna fucking change.
create methods
So I gotta like focus on just this for now and work with this stupid language,
on table 20
because this is a lot of work to do something so simple,
words field name value meaning
because the language sucks
environment
and the hardware's garbage.
object is the global object. It contains
So I'm gonna like work on these macros, try to get this running,
generator declaration,
and finish up this shader program then.
a sync generator declaration, and
So we're gonna actually get back to working on JavaScript Engine
associated realm.
and meeting the standard to release the JavaScript Engine.
This in global scope. Hosts may provide any
Oh, I hate everything.
value.
Everything fucking sucks.
A declarative environment record.
It's probably take like an hour
Declarations in
to get this in
code except
and then check other things.
generated
Like not just this, like when I get this in, there's other things I gotta like check and tweak.
variable declaration bindings, var names, a list of strings,
So I'll get some water
bound
and then I'll get back to finish up.
declaration, a sync function declaration, a sync
I don't know, baby. Alright, I gotta like actually focus now.
declarations in global code for the associated realm. Copyright sign, ECMA International 2024, 43, Table 21. Additional methods of global environment records. Method purpose. Get this binding. Return the value of this environment records this binding has a declaration. N determines if the argument identifier has a binding in this environment record that was created using a variable declaration. Function declaration. Generator declaration. A sync function declaration or a sync generator declaration has lexical declaration. N determines if the argument identifier has a binding in this environment record that was created using a lexical declaration such as a lexical declaration or a class declaration, has restricted global property. N determines if the argument is the name of a global object property that may not be shadowed by a global lexical binding, can declare global var. N determines if a corresponding create global var binding call would succeed if called for the same argument. N can declare global function. N determines if a corresponding create global function binding call would succeed if called for the same argument. N create global var binding. N D used to create and initialize to undefined a global var binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a var. The string value n is the bound name. If D is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows var declarations to receive special treatment. Create global function binding. N, V, D, create and initialize a global function binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will H have attribute values appropriate for a function. The string value n is the bound name. V is the initialization value. If the Boolean argument D is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows function declarations to receive special treatment. The behavior of the concrete specification methods for global environment records is defined by the following algorithms. 1, 1, 4, 1 has binding. N, the has binding concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is one of the identifiers bound by the record. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding, n is true, return true. Let objrec be envrec. Return objrec has binding. N, 1, 1, 4, 2 create mutable binding. N, D, the create mutable binding concrete method of a global environment record envrec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new mutable binding for the num n that is uninitialized. The binding is created in the associated 44 copyright sign, ECMA International 2024 declarative record. A binding for n must not already exist in the declarative record. If D is true, the new binding is marked as being subject to deletion. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding, n is true, throw a type error exception. Return dclrec create mutable binding. N, D, 1, 1, 4, 3 create a mutable binding. N, S, the create immutable binding concrete method of a global environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new immutable binding for the num n that is uninitialized. A binding must not already exist in this environment record for n if s is true. The new binding is marked as a strict binding. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding, n is true, throw a type error exception. Return dclrec create a mutable binding. N, S, 1, 1, 4, initialize binding. N, v. The initialize binding concrete method of a global environment record env-rec takes arguments n, a string, and v, an ECMA script language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. An uninitialized binding for n must already exist. It performs the following steps when called let DCL-rec be env-rec. If DCL-rec has binding, n is true, then a return. DCL-rec initialize binding, n, v, assert. If the binding exists, it must be in the object environment record. Let obj-rec be env-rec. Return obj-rec initialize binding, n, v, 1, 1, 4, 5 set mutable binding, n, v, s. The set mutable binding concrete method of a global environment record env-rec takes arguments n, a string, v, an ECMA script language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is n to the value v if the binding is an immutable binding and s is true. A type error is thrown. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called let DCL-rec be env-rec. If DCL-rec has binding, n is true, then a return DCL-rec set mutable binding, n, v, s. Let obj-rec be env-rec. Return obj-rec set mutable binding, n, v, s, 1, 1, 4, 6 get binding value, n, s. The get binding value concrete method of a global environment record env-rec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its bound identifier whose name is n if the binding is an uninitialized binding. Throw a reference error exception. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called let DCL-rec be env-rec. If DCL-rec has binding, n is true, then a return DCL-rec get binding value, n, s. ECMA International 2024 145. 3. Let obj-rec be env-rec. Return obj-rec get binding value, n, s, 1, 1, 4, 7 delete binding, n. The delete binding concrete method of a global environment record env-rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called let DCL-rec be env-rec. If DCL-rec has binding, n, is true, then a return DCL-rec delete binding, n. Let obj-rec be env-rec. Let global object be obj-rec. Let existing prop be has own property, global object, n. If existing prop is true, then a let status be obj-rec delete binding, n. B if status is true and env-rec contains n, then I remove n from env-rec. C return status. Return true, 1, 1, 4. 8 has this binding. The has this binding concrete method of a global environment record env-rec takes no arguments and returns true. It performs the following steps when called return true, 1, 1, 4. 9 has super binding. The has super binding concrete method of a global environment record env-rec takes no arguments and returns false. It performs the following steps when called return false, 1, 1, 4, 1, 0 with base object. The with base object concrete method of a global environment record env-rec takes no arguments and returns undefined. It performs the following steps when called return undefined. 9, 1, 1, 4, 1, 1 get this binding. The get this binding concrete method of a global environment record env-rec takes no arguments and returns a normal completion containing an object. It performs the following steps when called return env-rec. 146. ECMA International 2024. Note: Global Environment Records always provide this binding. Note: Global Environment Records do not provide a super binding. 9.1.1.4.1.2 HASVAR Declaration. N. The HASVAR Declaration concrete method of a global environment record env-rec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a variable statement or a function declaration. It performs the following steps when called. Let var declared names be env-rec. If var declared names contains n, return true, return false, 1.1.4.1.3 has lexical declaration. N. The has lexical declaration concrete method of a global environment record env-rec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a lexical declaration such as a lexical declaration or a class declaration. It performs the following steps when called. Let DCL-rec be env-rec. Return. DCL-rec has binding n, 1.1.4.1.4 has restricted global property n. The has restricted global property concrete method of a global environment record env-rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is the name of a property of the global object that must not be shadowed by a global lexical binding. It performs the following steps when called. Let obj-rec be env-rec. Let global object be obj-rec. Let existing prop be global object. N. If existing prop is undefined, return false. If existing prop is true, return false. Return true, 1.1.4.1.5 can declare global var. N. The can declare global var concrete method of a global environment record env-rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global var binding call would succeed if called for the same argument and redundant var declarations and var declarations for pre-existing global object properties are allowed. It performs the following steps when called. Let obj-rec be env-rec. Let global object be obj-rec. Let has property be has own property, global object, n. If has property is true, return true. Return is extensible, global object. Note: properties may exist upon a global object that were directly created rather than being declared using a var or function declaration. A global lexical binding may not be created that has the same name as a non-configurable property of the global object. The global property undefined is an example of such a property. ECMA International 2024 147 9.1.1.4.1.6 can declare global function n. The can declare global function concrete method of a global environment record env-rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global function binding call would succeed if called for the same argument, and it performs the following steps when called. Let obj-rec be env-rec. Let global object be obj-rec. Let existing prop be global object. N. If existing prop is undefined, return is extensible, global object. If existing prop is true, return true. If is data descriptor, existing prop is true and existing prop has attribute values, true, enumerable, true, return true, return false, 1.1.4.1.7 create.
Going through and like
D. The create global var binding concrete method of a global environment record env-rec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing a
so you see whatever.
creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists,
I have like my own variant, whatever, at this point,
following steps when called
of C++.
env-rec. Let global
So I can like get the shader program running without using C++.
object n. Let extensible be is
Because I'm like replacing C++
property is
to use my calls instead.
form OBJREC create mutable binding. N, D, B perform. OBJREC initialize binding. N, undefined. If envrec does
So like C++.
then a appendent to envrec 7. Return unused, 1, 1, 4, 1, 8 create global function binding. N, V, D, the create global function binding concrete method of a global environment record envrec takes arguments N, a string, V,
It's not an engine.
U, and E.
It's like a collection of like calls and stuff. Like in C.
It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list.
Like JavaScript.
It is 2,
It's an engine basically.
7, 8, replaced. It performs the
Because it's not simply C. There's like a whole bunch of like
object BOBJREC. Let exist
this whole thing.
global object N if exists
It's not just like C with extensions.
true, then
It's like a data collection.
true, true. D
It's really complicated, whatever.
D descriptor V perform. Define property or throw global object N desk perform.
I don't know, there's no point making a diagram.
Object N V false.
Like making a template is C++,
Dependent to E
even though it's not exactly the same.
unused 48
It doesn't even look like C++ at this point,
4
because C++ would be like just this.
always represented as own properties of the global object. If possible,
I wouldn't need the macro wrapper,
be configured to have a step.
but I need the macro wrapper
Step 7 is a
to get the functionality, whatever.
binding concrete method would do, and if global object is a proxy will produce the same sequence of proxy trap calls.
But that's how like
5 module environment records. A module environment record is a declarative environment record that is used to represent the outer scope of an ECMA.
I don't know. That's basically
Additional to
how I made my JavaScript engine.
module environment records also provide a mutable
I just went through a different program I wrote.
access to a target
I found all the calls I have, all the data types,
record. Module environment records support
and just like I'm doing now with C++,
record methods list
I figured out what I need
specifications for all of those methods except for get binding value.
so that I can run JavaScript, but without Chrome, the browser, whatever.
What the methods listed in table 22. Table 22
So like, it'd be a waste of time
records the behavior of the addition
to make my own C++ engine,
environment
because C++ isn't really an engine,
comma 1
and it's free in the first place.
1 get binding value N S the get binding value
I don't know.
module environment record
I hate making something that already exists,
and F
or like improving on it.
and returns either
It's more fun to make something new that doesn't exist.
value or a throw completion. It returns the value of its bound identifier whose name
So I could get this done.
is an indirect binding.
This is getting old.
Binding is returned if the binding exists but is uninitialized.
Because JavaScript sucks.
Following steps when called assert
I want to release something better,
env
but I get one thing done out of the way first.
for n is an indirect.
So I could get it. So I don't know, I gotta get the standard then.
The indirection values provided when this bind
Meet the standard, finish this thing up,
NVBN
get it released.
env is empty
Then I can
and Sarah exception
work on other things to release them.
value n2 true if the binding for n in envrec is an uninitialized binding.
I get this shader program done.
Return the
Alright, so I'm gonna like adjust the macro,
rec
try to add
true because
nodes 4, 5,
1 1 5
get the concat the tokens,
n the delete button.
set this stuff up, and get running.
The environment record is never used within this specification. Method purpose create import binding n m n2
I'm waiting for more Pepsi to get cold.
environment record.
I have to get something done before then though, so I'm gonna try to work on it.
M is a module record and n
This is so boring.
in M's module environment record. Get this binding, return the value of this environment records this binding, copyright sign, ECMA International 2024 149. Note: module environment records are only used within strict code, and an early error rule prevents the delete operator in strict code from being applied to a reference record that would resolve to a module environment record binding. C135111,1, 5 has this binding. The has this binding concrete method of a module environment record envrec takes no arguments and returns true. It performs the following steps when called: return true, 1, 5, 4 get this binding. The get this binding concrete method of a module environment record envrec takes no arguments and returns a normal completion containing undefined. It performs the following steps when called: return undefined, 1, 5, create import binding, n2. The create import binding concrete method of a module environment record envrec takes arguments n, a string, m, a module record, and n2, a string, and returns unused. It creates a new initialized immutable indirect binding for the name n. A binding must not already exist in this environment record, for n2 is the name of a binding that exists in m's module environment record. Accesses to the value of the new binding will indirectly access the bound value of the target binding. It performs the following steps when called: assert. Envrec does not already have a binding for n. Assert. When m is instantiated, it will have a direct binding for n2. Create an immutable indirect binding in envrec for n that references m and n2 as its target binding, and record that the binding is initialized. Return unused, 1.2 environment record operations. The following abstract operations are used in this specification to operate upon environment records. 9. 1, 2, 1 get identifier reference, env, name, strict. The abstract operation get identifier reference takes arguments env, an environment record or null, name, a string, and strict, a boolean, and returns either a normal completion containing a reference record or a throw completion. It performs the following steps when called: if env is null, then a return the reference record, unresolvable, name, strict. This value, empty. Let exists be env has binding, name. If exists is true, then a return the reference record, env, name, strict, empty. Else. 150. ECMA International 2024. Note: module environment records always provide this binding AB. Let outer be env. Return get identifier reference, outer, name, strict. 9. 1, 2. To new declarative environment E. The abstract operation new declarative environment takes argument E, an environment record or null, and returns a declarative environment record. It performs the following steps when called: let env be a new declarative environment record containing no bindings. Set env to E. Return env, 1, 2, 3 new object environment O, W, E. The abstract operation new object environment takes arguments O, an object, W, a boolean, and E, an environment record or null, and returns an object environment record. It performs the following steps when called: let env be a new object environment record. Set env to O. Set env to W. Set env to E. Return env, 1, 2, 4 new function environment F. New target. The abstract operation new function environment takes arguments F, an ECMA script function object, and new target, an object or undefined, and returns a function environment record. It performs the following steps when called: let env be a new function environment record containing no bindings. Set env to F. If F is lexical, set env to lexical. Else. Set env to uninitialized. Set env to new target. Set env to F. Return env, 1, 2, 5 new global environment G. This value. The abstract operation new global environment takes arguments G, an object, and this value, an object, and returns a global environment record. It performs the following steps when called: let objrec the new object environment G, false, null. Let dcl rec the new declarative environment null. Let env be a new global environment record. Set env to objrec. Set env to this value. Set env to dclrec. Set env to a new empty list. Set env to null. Return env, 1, 2, 6 new module environment. The abstract operation new module environment takes argument e, an environment record, and returns a module environment record. It performs the following steps when called. Let env be a new module environment record containing no bindings. Set env to e. Return env. ECMA International 2024 151, 9.2 Private environment records. A private environment record is a specification mechanism used to track private names based upon the lexical nesting structure of class declarations and class expressions in ECMA script code. They are similar to, but distinct from, environment records. Each private environment record is associated with a class declaration or class expression. Each time such a class is evaluated, a new private environment record is created to record the private names declared by that class. Each private environment record has the fields defined in Table 23, tar. 23. Private environment record fields, field name, value type, meaning, outer private environment, A, private environment record or null, the private environment record of the nearest containing class null if the class with which this private environment record is associated is not contained in any other class. Names, a list of private names, the private names declared by this class. 9. 2. 1 Private environment record operations. The following abstract operations are used in this specification to operate upon private environment records. 9. 2. 1. 1 New private environment. Outer privy env. The abstract operation new private environment takes argument outer privy env, a private environment record or null, and returns a private environment record. It performs the following steps when called. Let names be a new empty list. Return the private environment record. Outer privy env. Names, 2, 1. 2 Resolve private identifier. Privy env. Identifier. The abstract operation resolve private identifier takes arguments privy env, a private environment record, and identifier, a string, and returns a private name. It performs the following steps when called. Let names be privy env. For each private name pn of names, do a if pn is identifier. Then, I return pn. Let outer privy env be privy env. Assert. Outer privy env is not null. Return resolve private identifier. Outer privy env. Identifier. 3 realms. Before it is evaluated, all ECMA script code must be associated with a realm. Conceptually, a realm consists of a set of intrinsic objects, an ECMA script global environment, all of the ECMA script code that is loaded within the scope of that global environment, and other associated state and resources. A realm is represented in this specification as a realm record with the fields specified in Table 24, 52, copyright sign, ECMA International 2024, Table 24. Realm record fields, field name, agent signifier, intrinsics, global object, global env, template map, an object or undefined value, an agent signifier, a record whose field names are intrinsic keys and whose values are objects, a global environment record, a list of records with fields, a template literal parse node, and v, an array, f. The agent that owns this realm, the global object for this realm, the global environment for this realm, meaning, the intrinsic values used by code associated with this realm, a list of records, with fields are, a string, and, a module record. Note 1 Once a parse node becomes unreachable, the corresponding is also unreachable, and it would be unobservable if an implementation removed the pair from the list. Anything default value is undefined. Note 2 as mentioned in host load imported module. 1.6.2.1.8 Note 1. In realm records is only used when running an import expression in a context where there is no active script or module field reserved for use by hosts that need to associate additional information with a realm record. Template objects are canonicalized separately for each realm using its realm records. Each value is a parse node that is a template literal. The associated ALU is the corresponding template object that is passed to a tag function, a map from the specifier strings imported by this realm to the solved module record. The list does not contain two different records with the same 9, 3, 1 create realm. The abstract operation create realm takes no arguments and returns a realm record. It performs the following steps when called let realm rec be a new realm record. Perform create intrinsics. Realm rec, set realm rec to agent signifier, set realm rec to undefined, set realm rec to undefined, set realm rec to a new empty list, return realm rec, ECMA International 2024 153, 9, 3, 2 create intrinsics. Realm rec, the abstract operation create intrinsics takes argument realm rec, a realm record, and returns unused. It performs the following steps when called set realm rec to a new record. Set fields of realm rec with the values listed in table 6. The field names are the names listed in column 1 of the table. The value of each field is a new object value fully and recursively populated with property values as defined by the specification of each object in clauses 19 through 28. All object property values are newly created object values. All values that are built-in function objects are created by performing create built-in function, steps, length, name, slots, realm rec, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the function's name property. Length is the initial value of the function's length property. Slots is a list of the names, if any, of the function's specified internal slots. And prototype is the specified value of the function's internal slot. The creation of the intrinsics and their properties must be ordered to avoid any dependencies upon objects that have not yet been created. Perform capital A, D, D, capital R, E, S, T, R, I, C, T, E, D, capital F, U, N, C, T, I, O, N, capital P, R, O, P, E, R, T, I, E, realm rec, return unused, 3.3 set realm global object, realm rec, global OBJ, this value, the abstract operation set realm global object takes arguments realm rec, a realm record, global OBJ, an object or undefined, and this value, an object or undefined, and returns unused. It performs the following steps when called if global OBJ is undefined. Then, A. Let intrinsics be realm rec. B. Set global OBJ to ordinary object create. Intrinsics. Assert. Global OBJ is an object. If this value is undefined, set this value to global OBJ. Set realm rec to global OBJ. Let new global env be new global environment. Global OBJ. This value, set realm rec to new global env, return unused, 3.4 set default global bindings. Realm rec, the abstract operation set default global bindings takes argument realm rec, a realm record, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called let global be realm rec. For each property of the global object specified in clause 19, do A. Let name be the string value of the property name. B. Let desc be the fully populated data property descriptor for the property, containing the specified attributes for the property. For properties listed in 19.2, 19.3, or 19.4, the value of the attribute is the corresponding intrinsic object from realm rec. C. Perform. Define property or throw, global, name, desc, return global. 4 execution contexts. An execution context is a specification device that is used to track the runtime evaluation of code by an ECMA script implementation. At any point in time, there is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution context in this specification denote the running execution context of the surrounding agent. The execution context stack is used to track execution contexts. The running execution context is always the top element of this stack. A new execution context is created whenever control is transferred from the executable code associated with the currently running execution context to executable code that is not associated with that. 54. Copyright sign, ECMA International 2024. Execution context. The newly created execution context is pushed onto the stack and becomes the running execution context. An execution context contains whatever implementation-specific state is necessary to track the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 25. State components for all execution contexts. Component, purpose, code evaluation state, any state needed to perform, suspend, and resume evaluation of the code associated with this execution context. Function, if this execution context is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of a script or module, the value is null. Realm, the realm record from which associated code accesses ECMA script resources, script or module, the module record or script record from which associated code originates. If there is no originating script or module, as is the case for the original execution context created in initialize host-defined realm, the value is null. Evaluation of code by the running execution context. XT may be suspended at various points defined within this specification. Once the running execution context has been suspended, a different execution context may become the running execution context and commence evaluating its code. At some later time, a suspended execution context may again become the running execution context and continue evaluating its code at the point where it had previously been suspended. Transition of the running execution context status among execution contexts usually occurs in stack-like last-in-first-out manner. However, some ECMA script features require non-LIFO transitions of the running execution context. The value of the realm component of the running execution context is also called the current realm record. The value of the function component of the running execution context is also called the active function object. ECMA script code execution contexts have the additional state components listed in Table 26. Table 26. Additional state components for ECMA script code execution contexts. Component, purpose, lexical environment, identifies the environment record used to resolve identifier references made by code within this execution context. Variable environment, identifies the environment record that holds bindings created by variable statements within this execution context. Private environment, identifies the private environment record that holds private names created by class elements in the nearest containing class null if there is no containing class. The lexical environment and variable environment components of an execution context are always environment records. Execution contexts representing the evaluation of generators have the additional state components listed in Table 27. ECMA International 2024 155. Table 27. Additional state components for generator execution contexts. In most situations, only the running execution context, the top of the execution context stack, is directly manipulated by algorithms within this specification. Hence, when the terms lexical environment and variable environment are used without qualification, they are in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. It is impossible for ECMA script code to directly access or observe an execution context. 4.1 Get active script or module. The abstract operation get active script or module takes no arguments and returns a script record, a module record, or null. It is used to determine the running script or module based on the running execution context. It performs the following steps when called. If the execution context stack is empty, return null. Let EC be the topmost execution context on the execution context stack whose script or module component is not null. If no such execution context exists, return null. Otherwise, return X script or module. 4.2 Resolve binding, name, env. The abstract operation resolve binding takes argument name, a string, and optional argument env, an environment record or undefined, and returns either a normal completion containing a reference record or a throw completion. It is used to determine the binding of name. env can be used to explicitly provide the environment record that is to be searched for the binding. It performs the following steps when called. If env is not present or env is undefined, Then, A set env to the running execution context's lexical environment. Assert. Env is an environment record if the source text matched by the syntactic production that is being evaluated is contained in strict mode. Code. Let strict be true, else let strict be false. Return. Get identifier reference. Env name strict, 4.3 get this environment. The abstract operation get this environment takes no arguments and returns an environment record. It finds the environment record that currently supplies the binding of the keyword this. It performs the following steps when called. Let env be the running execution context's lexical environment 2. Repeat. Component purpose. Generator the generator that this execution context is evaluating. 156. ECMA International 2024. Note the result of resolve binding is always a reference record whose field is name. ABCDE. Let exists be.
So I don't know. That calls the opening macro and the closing macro.
To outer. Note the loop in step 2 will always terminate because the list of environments always ends with the global environment which has this.
I pass it 6.
This binding. The abstract
So like,
binding takes no arguments and returns either a normal completion.
I'm passing in 2. So I gotta set up the modes. 4 and 5.
Determines the binding of the keyword.
In the other modes, we're passing 2. We're passing 6.
It performs the following steps when called. Let envrec beget this environment. Return envrec get this binding, 4.5 get new target. The abstract operation get new target takes no arguments and returns an object or undefined.
So these macros that are blocks
The lexical
will include the block code, and the macros that are lists, like parentheses separated, comma separated lists. 4 and 5, whatever.
The abstract
Those modes include this to make it a list instead.
is an object. It returns the global object used by the currently running execution context. It performs the following steps when called. 2.5 Let current realm be the current realm record. Return current realm. Jobs
Except the complicated part will take an hour maybe.
is an abstract.
It's not going to update everything inside the block.
CMA script compute
So this ends in a semicolon.
progress. Jobs are shared
You can't have a semicolon in a list.
environments.
So I'm going to go through and update all the other things inside here.
Host enqueue generic job. Capital HOST
Something's wrong with the fucking keyboard.
UE capital FINALIZ
In this part, I can't.
capital
I could.
G
It depends.
STR host enqueue promise job and host enqueue timeout job to schedule job. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs.
So the list macros,
Operation
4, 5,
such operation
they won't have temporary variables.
are
So I'm going to get rid of this part.
provided.
I'm going to update every freaking thing
Time in the
to
provided
make it fit in a fucking list.
owns the realm. If null is provided instead for the
Damn.
not evaluate ECMA script code. Their implementations must conform
I literally hate everything.
point in time
Everything is stupid.
context in the agent for which the job is scheduled.
From computer memory to modern software.
Action must
Everything is so stupid. It could all be so much easier.
perform any host defined
But no, it's not.
execution context stack must be empty. Only one job may be
C language is just as bad as C++.
once evaluation of a job starts, it must run
And macros are just a band-aid. Because the language itself can't do stuff.
implementing its own handling of errors.
It's worse than a band-aid. It's a patch.
157. Note 1 host environments are not required to treat jobs uniformly with respect to scheduling. For example, web browsers and Node.js treat promise handling jobs as a higher
Oh, this is so boring.
future
I need some water.
that are not treated at such a high
I gotta focus.
any
It's so hard to focus when everything is so boring
The active script
and repetitive. It's always the same thing,
script or module.
over and over and over.
If script or module
Like writing a program,
will record.
including macros, making copies of memory.
Execution context stack whose script or module component is script or module.
Over and over and over.
At any particular time, an execution is prepared to evaluate
Oh, it gets water, baby.
the following conditions are true. The execution context stack is not empty. The realm component of the topmost execution context on the execution context stack is a realm record. Particular kinds of jobs have additional conformance requirements. 5.1 Job callback records. A job callback record is a record value used to store a function object and a host-defined value. Function objects that are invoked via a job include by the host may have additional host-defined context. To propagate the state, job abstract closures should not capture and call function objects directly. Instead, use host make job callback and host call job callback. Job callback records have the fields listed in Table 28. Table 28. Job callback record fields, 5.2 host make job callback. Callback. The host-defined abstract operation host make job callback takes argument callback, a function object, and returns a job callback record. An implementation of host make job callback must conform to the following requirements. It must return a job callback record whose field is callback. Note to host environments may prepare an execution to evaluate code by pushing execution contexts onto the execution context stack. The specific steps are implementation defined. The specific choice of realm is up to the host environment. This initial execution context and realm is only in use before any callback function is invoked. When a callback function related to a job, like a promise handler, is invoked, the invocation pushes its own execution context and realm. Note the WHATWG-HTML specification, https://html.spec.whatwg.org, for example, uses the host-defined value to propagate the incumbent settings object for promise callbacks. Field name, value, meaning, callback, a function object, the function to invoke when the job is invoked. Host-defined, anything default value is empty. Field reserved for use by hosts. 158, ECMA International 2024. The default implementation of host make job callback performs the following steps when called. 1. Return the job callback record. Callback. Empty. ECMA script hosts that are not web browsers must use the default implementation of host make job callback, 5.3 host call job callback. Job callback. V. Arguments list. The host-defined abstract operation host call job callback takes arguments job callback, a job callback record, V, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. An implementation of host call job callback must conform to the following requirements. It must perform and return the result of call. Job callback. V. Arguments list. The default implementation of host call job callback performs the following steps when called. Assert. Is callable. Job callback. Is true. Return. Call. Job callback. V. Arguments list. ECMA script hosts that are not web browsers must use the default implementation of host call job callback, 5.4 host enqueue generic job. Job. Realm. The host-defined abstract operation host enqueue generic job takes arguments job, a job abstract closure, and realm, a realm record, and returns unused. It schedules job in the realm in the agent signified by realm to be performed at some future time. The abstract closures used with this algorithm are intended to be scheduled without additional constraints, such as priority and ordering. An implementation of host enqueue generic job must conform to the requirements in 9.5, 9, 5, 5 host enqueue promise job. Job. Realm. The host-defined abstract operation host enqueue promise job takes arguments job, a job abstract closure, and realm, a realm record or null, and returns unused. It schedules job to be performed at some future time. The abstract closures used with this algorithm are intended to be related to the handling of promises, or otherwise, to be scheduled with equal priority to promise handling operations. An implementation of host enqueue promise job must conform to the requirements in 9.5 as well as the following. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that execution is prepared to evaluate ECMA script code at the time of job's invocation. Let script or module beget active script or module at the time host enqueue promise job is invoked. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that script or module is the active script or module at the time of job's invocation. Jobs must run in the same order as the host enqueue promise job invocations that scheduled them. Note this is called at the time that the callback is passed to the function that is responsible for its being eventually scheduled and run. For example, promise then action, calls make job callback on then action at the time of invoking promise prototype then, not at the time of scheduling the reaction job. Note this requirement means that hosts cannot change the behavior of function objects defined in this specification. ECMA International 2024 159. Note the realm for jobs returned by new promise resolved thenable job is usually the result of calling get function realm on the then function object. The realm for jobs returned by new promise reaction job is usually the result of calling get function realm on the handler if the handler is not undefined. If the handler is undefined, realm is null. For both kinds of jobs, when get function realm completes abnormally, that is called on a revoked proxy, realm is the current realm record at the time of the get function realm call. When the realm is null, no user ECMA script code will be evaluated and no new ECMA script objects, for example error objects, will be created. The WHATWG-HTML specification, https://html.spec.whatwg.org, for example, uses realm to check for the ability to run script and for the entry, https://html.spec.whatwg.org entry. Concept, 5.6 host enqueue timeout job, realm, milliseconds. The host-defined abstract operation host enqueue timeout job takes arguments timeout job, a job abstract closure, realm, a realm record, and milliseconds, a non-negative finite number, and returns unused. It schedules timeout job in the realm in the agent signified by realm to be performed after at least milliseconds. An implementation of hostenc UE timeout job must conform to the requirements in 9.5, 9.6 initialize host defined realm. The abstract operation initialize host defined realm takes no arguments and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let realm be create realm. Let new context be a new execution context. Set the function of new context to null. Set the realm of new context to realm. Set the script or module of new context to null. Push new context onto the execution context stack. New context is now the running execution context. If the host requires use of an exotic object to serve as realm's global object, let global be such an object, created in a host-defined manner. Otherwise, let global be undefined, indicating that an ordinary object should be created as the global object. If the host requires that this binding in realm's global scope return an object other than the global object, let this value be such an object created in a host-defined manner. Otherwise, let this value be undefined, indicating that realm's global this binding should be the global object. Perform set realm global object, realm, global, this value 0. Let global obj be. Set default global bindings, realm 1. Create any host-defined global object properties on global obj 2. Return unused. 0.7 agents. An agent comprise is a set of ECMA script execution contexts, an execution context stack, a running execution context, an agent record, and an executing thread. Except for the executing thread, the constituents of an agent belong exclusively to that agent. An agent's executing thread executes algorithmic steps on the agent's execution contexts independently of other agents. except that an executing thread may be used as the executing thread by multiple agents, provided none of the agents sharing the thread have an agent record whose field is true. Note 1. Some web browsers share a single executing thread across multiple unrelated tabs of a browser window. For example, 60. Copyright sign, ECMA International 2024. While an agent's executing thread is executing algorithmic steps, the agent is the surrounding agent for those steps. The steps use the surrounding agent to access the specification level execution objects held within the agent, the running execution context, the execution context stack, and the agent records fields. An agent signifier is a globally unique opaque value used to identify an agent. Table 29. Agent record fields. Field name, value, meaning, little endian, a boolean. The default value computed for the is little endian parameter when it is needed by the algorithms get value from buffer and set value in buffer. The choice is implementation defined and should be the alternative that is most efficient for the implementation. Once the value has been observed, it cannot change. Can block, a boolean, determines whether the agent can block or not. Signifier, an agent signif, IER, uniquely identifies the agent within its agent cluster. Is lock-free 1, a boolean, true if atomic operations on 1 byte values are lock-free. False otherwise. Is lock-free 2, a boolean, true if atomic operations on 2 byte values are lock-free. False otherwise. Is lock-free 8, a boolean, true if atomic operations on 8 byte values are lock-free. False otherwise. Candidate execution. A. Candidate execution record. See the memory model. Kept alive. A list of either objects or symbols. Initially a new empty list, representing the list of objects and or symbols to be kept alive until the end of the current job. Once the values of and have been observed by any agent in the agent cluster, they cannot change. Note 2. The values of and are not necessarily determined by the hardware, but may also reflect implementation choices that can vary over time and between ECMA script implementations. There is no field. 4-byte atomic operations are always lock-free. In practice, if an atomic operation is implemented with any type of lock, the operation is not lock-free. Lock-free does not imply wait-free. There is no upper bound on how many machine steps may be required to complete a lock-free atomic operation. That an atomic access of size n is lock-free does not imply anything about the perceived atomicity of non-atomic accesses of size n. Specifically, non-atomic accesses may still be performed as a sequence of several separate memory accesses. See read shared memory and write shared memory for details. ECMA International 2024 161. Note 3. An agent is a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. 7.1 Agent signifier. The abstract operation agent signifier takes no arguments and returns an agent signifier. It performs the following steps when called. Let AR be the agent record of the surrounding agent. Return AR, 7.2 Agent can suspend. The abstract operation agent can suspend takes no arguments and returns a boolean. It performs the following steps when called. 2.8 Let AR be the agent record of the surrounding agent. Return AR, agent clusters. Note in some environments it may not be reasonable for a given agent to suspend. For example, in a web browser environment, it may be reasonable to disallow suspending a document's main event handling thread, while still allowing workers' event handling threads to suspend. An agent cluster is a maximal set of agents that can communicate by operating on shared memory. Every agent belongs to exactly one agent cluster. All agents within a cluster must have the same value for the field in their respective agent records. All agents within a cluster must have the same values for the field in their respective agent records. Similarly, for the field, all agents within a cluster must have different values for the field in their respective agent records. An embedding may deactivate, stop forward progress, or activate, resume forward progress, an agent without the agent's knowledge or cooperation. If the embedding does so, it must not leave some agents in the cluster active while other agents in the cluster are deactivated indefinitely. Note 1. Programs within different agents may share memory by unspecified means. At a minimum, the backing memory for shared array buffers can be shared among the agents in the cluster. There may be agents that can communicate by message passing that cannot share memory, They are never in the same agent cluster. Note to the agents in a cluster need not all be alive at some particular point in time. If agent A creates another agent B, after which A terminates and B creates agent C, the three agents are in the same cluster if A could share some memory with B and B could share some memory with C. Note 3: if different agents within an agent cluster have different values of it becomes hard to use shared memory for multi-byte data. 62. Copyright sign, ECMA International 2024. Note 4. The purpose of the preceding restriction is to avoid a situation where an agent deadlocks or starves because another agent has been deactivated. For example, if an HTML shared worker that has a lifetime independent of documents in any windows were allowed to share memory with the dedicated worker of such an independent document, and the document and its dedicated worker were to be deactivated while the dedicated worker holds a lock, say, the document is pushed into its Windows history, and the shared worker then tries to acquire the lock, then the shared worker will be blocked until the dedicated worker is activated again, if ever. Meanwhile, other workers trying to access the shared worker from other windows will starve. The implication of the restriction is that it will not be possible to share memory between agents that don't belong to the same suspend-wait collective within the embedding. An embedding may terminate an agent without any of the agent's cluster's other agents' prior knowledge or cooperation. If an agent is terminated not by programmatic action of its own or of another agent in the cluster but by forces external to the cluster, then the embedding must choose one of two strategies: either terminate all the agents in the cluster, or provide reliable APIs that allow the agents in the cluster to coordinate so that at least one remaining member of the cluster will be able to detect the termination. With the termination data containing enough information to identify the agent that was terminated, each of the following specification values, and values transitively reachable from them, belong to exactly one agent cluster. Candidate execution record, shared data block, waiter list record. Prior to any evaluation of any ECMA script code by any agent in a cluster, the field of the agent record for all agents in the cluster is set to the initial candidate execution. The initial candidate execution is an empty candidate execution whose field is a list containing, for each agent, an agent events record whose field is that agent's agent signifier, and whose and fields are empty lists. Note 5 examples of that type of termination are operating systems or users terminating agents that are running in separate processes, the embedding itself terminating an agent that is running in process with the other agents whenever. Agent resource accounting indicates that the agent is run away. Note 6. All agents in an agent cluster share the same candidate execution in its agent records field. The candidate execution is a specification mechanism used by the memory model. Note 7. An agent cluster is a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. Point 9. Forward progress. For an agent to make forward progress is for it to perform an evaluation step according to this specification. An agent becomes blocked when its running execution context waits synchronously and indefinitely for an external event. Only agents whose agent records field is true can become blocked in this sense. An unblocked agent is one that is not blocked. Implementations must ensure that every unblocked agent with a dedicated executing thread eventually makes forward progress. In a set of agents that share an executing thread, one agent eventually makes forward progress. ECMA International 2024 163. An agent does not cause another agent to become blocked except via explicit APIs that provide blocking. Point 10. Processing model of weak ref and finalization registry targets 9.10. 1. Objectives. This specification does not make any guarantees that any object or symbol will be garbage collected. Objects or symbols which are not live may be released after long periods of time, or never at all. For this reason, this specification uses the term may when describing behavior triggered by garbage collection. The semantics of weak refs and finalization registries is based on two operations which happen at particular points in time. When weak ref prototype derif is called, the referent, if undefined is not returned, is kept alive so that subsequent, synchronous accesses also return the same value. This list is reset when synchronous work is done using the clear-kept object's abstract operation. When an object or symbol which is registered with a finalization registry becomes unreachable, a call of the finalization registry's cleanup callback may eventually be made after synchronous CCMA script execution completes. The finalization registry cleanup is performed with the cleanup finalization registry abstract operation. Neither of these actions, clear-kept objects or cleanup finalization registry, may interrupt synchronous CCMA script execution. Because hosts may assemble longer, synchronous CCMA script execution runs. This specification defers the scheduling of clear-kept objects and cleanup finalization registry to the host environment. Some ECMA script implementations include garbage collector implementations which run in the background, including when ECMA script is idle. Letting the host environment schedule cleanup finalization registry allows it to resume ECMA script execution in order to run finalizer work, which may free up held values, reducing overall memory usage. 10.2 Liveness. For some set of objects and/or symbols, a hypothetical weak ref oblivious execution with respect to S is an execution whereby the abstract operation weak ref derif of a weak ref whose referent is an element of S always returns undefined. This, along with the liveness guarantee in the memory model, ensures that all sexEST writes note eventually become observable to all agents. Note 1 weak ref obliviousness, together with liveness, capture two notions. 1. That a weak ref itself does not keep its referent alive. 2. That cycles in liveness does not imply that a value is live. To be concrete, if determining V's liveness depends on determining the liveness of a weak ref referent, as liveness cannot assume
So like,
be circular reasoning.
I think I gotta like group up each parts of these to separate chunks,
Values to
then define them.
defined on
It's like the number at the end of each part.
ref referent in a cycle will be considered live even though its identity is only observed by other weak ref reference in the cycle.
Say for 1, 2, 3, 4, whatever mode.
An object or symbol is live if every set containing it is live.
Place it inside each block.
And or symbols S is considered live if either of the following conditions is met. Any element in S is included in any agent's list 164. ECMA International 2024, there exists a valid future execution with
So that this macro will
note for
concat to form what to select.
is live if it
Each of these will be defined up here for whatever.
weak ref means. A value's identity may be observed by observing a strict equality comparison or observing the value being used as key in a map. Note 5. Presence of an object or a symbol in a field
I just want to be done.
imply that the value is live. For example, if the value in
Oh, I gotta hurry up and get this done. It's taking so long. I'm so tired of this.
this is the case for keys in a weak
I'm ready to frickin'
fields of a finalization registry cell record. The above definition implies that if a key in a weak map is not live, then its corresponding V alu is not necessarily live either. Note 6 live
go from page 1 to page 816. I'm ready to go.
liveness is defined here.
I just want to get to this.
Significant implementation leeway, 10.3 execution. At any time, if a set
This stupid shader program.
does not live, an ECMA script implementation may perform the following steps atomically. For each element value of S, do A for each weak ref
Oh, that's so boring.
I set ref to empty. B for each finalization registry FG such that FG
Oh, I gotta get this done.
value. Do I set cell to empty. 2. Optionally, perform capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R F G C for each weak map such that map contains a record R such that R value. Do I set R 2. set R to empty. D for each week set such that set contains value. Do I replace the element of set whose value is value with an element whose value is empty. ECMA International 2024 165. Note 1. Together with the definition of liveness, this clause prescribes optimizations that an implementation may apply regarding weak refs. It is possible to access an object without observing its identity. Optimizations such as dead variable elimination and scalar replacement on properties of non-escaping objects whose identity is not observed are allowed. These optimizations are thus allowed to observably empty weak refs that point to such objects. On the other hand, if an object's identity is observable, and that object is in the internal slot of a weak ref, optimizations such as rematerialization that observably empty the weak ref are prohibited, because calling capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R is optional. Registered objects in a finalization registry do not necessarily hold that finalization registry live. Implementations may omit finalization registry callbacks for any reason. For example, if the finalization registry itself becomes dead, or if the application is shutting down. Note 2. Implementations are not obligated to empty weak refs for maximal sets of non-live objects or symbols. If an implementation chooses a non-live set S in which to empty weak refs, this definition requires that it empties weak refs for all values in S simultaneously. In other words, it is not conformant for an implementation to empty a weak ref pointing to a value V without emptying out other weak refs that, if not emptied, could result in an execution that observes the value of V, 10.4 host hooks, 10, 4, 1, capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, T, R. Finalization registry. The host-defined abstract operation, capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, T, R, takes argument finalization registry, a finalization registry, and returns unused. Let T cleanup job be a new job abstract closure with no parameters that captures finalization registry and performs the following steps when called. Let cleanup result be completion, cleanup finalization registry. Finalization registry. If cleanup result is an abrupt completion, perform any host-defined steps for reporting the error. Return unused. An implementation of capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, T, R, schedules cleanup job to be performed at some future time, if possible. It must also conform to the requirements in 9.5.11 clear-kept objects. The abstract operation clear-kept objects takes no arguments and returns unused. ECMA script implementations are expected to call clear-kept objects when a synchronous sequence of ECMA script executions completes. It performs the following steps when called. Let agent record be the surrounding agent's agent record. Set agent record to a new empty list. Return unused. 66. ECMA International 2024. 9.12 Add to kept objects. Value. The abstract operation add to kept objects takes argument value, an object or a symbol, and returns unused. It performs the following steps when called. Let agent record be the surrounding agent's agent record. Append value to agent record. Return unused. 0.13 Cleanup finalization registry. Finalization registry. The abstract operation cleanup finalization registry takes argument finalization registry, a finalization registry, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called assert. Finalization registry has and internal slots. Let callback be finalization registry. While finalization registry contains a record cell such that cell is empty, an implementation may perform the following steps. A. Choose any such cell. B. Remove cell from finalization registry. C. Perform host call job callback. Callback undefined. Cell return unused. 0.14 can be held weekly. V. The abstract operation can be held weekly takes argument V, an ECMA script language value, and returns a Boolean. It returns true if and only if V is suitable for use as a weak reference. Only values that are suitable for use as a weak reference may be a key of a weak map, an element of a weak set, the target of a weak ref, or one of the targets of a finalization registry. It performs the following steps when called if V is an object. Return true if V is a symbol and key for symbol, V is undefined. Return true, return false. Note when the abstract operation add to kept objects is called with a target object or symbol, it adds the target to a list that will point strongly at the target until clear kept objects is called. Note a language value without language identity can be manifested without prior reference and is unsuitable for use as a weak reference. A symbol value PR, produced by symbol 4, unlike other symbol values, does not have language identity and is unsuitable for use as a weak reference. Well-known symbols are likely to never be collected, but are nonetheless treated as suitable for use as a weak reference because they are limited in number and therefore manageable by a variety of implementation approaches. However, any value associated to a well-known symbol in a live weak map is unlikely to be collected and could leak memory resources in implementations. 0 Ordinary and exotic objects behaviors. 0.1 Ordinary object internal methods and internal slots. All ordinary objects have an internal slot called. The value of this internal slot is either null or an object and is used for implementing inheritance. Assume a property named P is missing from an ordinary object O but exists on its object. If P refers to a data property on the object, O inherits it for get access, making it behave as if P was a property of O if P refers to a writable data property on the ECMA International 2024 167 object. Set access of P on O creates a new data property named P on O if P refers to an unwritable data property on the object. Set access of P on O fails. If P refers to an accessor property on the object, the accessor is inherited by O for both get access and set access. Every ordinary object has a Boolean valued internal slot which is used to fulfill the extensibility related internal method invariant specified in 6, 1, 7, 3. Namely, once the value of an object's internal slot has been set to false, it is no longer possible to add properties to the object, to modify the value of the object's internal slot, or to subsequently change the value of to true. In the following algorithm descriptions, assume O is an ordinary object, P is a property key value, V is any ECMA script language value, and desc is a property descriptor record. Each ordinary object internal method delegates to a similarly named abstract operation. If such an abstract operation depends on another internal method, then the internal method is invoked on O rather than calling the similarly named abstract operation directly. These semantics ensure that exotic objects have their overridden internal methods invoked when ordinary object internal methods are applied to them. 0, 1, 1. The internal method of an ordinary object O takes no arguments and returns a normal completion containing either an object or null. It performs the following steps when called return ordinary get prototype of O10, 1, 1, 1 ordinary get prototype of O. The abstract operation ordinary get prototype of takes argument O, an object, and returns an object or null. It performs the following steps when called return O10, 1, 2, V. The internal method of an ordinary object O takes argument V, an object or null, and returns a normal completion containing a Boolean. It performs the following steps when called return ordinary set prototype of O, V10, 1, 2, 2, 1 ordinary set prototype of O, V, the abstract operation ordinary set prototype of takes arguments O, an object, and V, an object or null, and returns a Boolean. It performs the following steps when called let current be O if same value, V, current, is true. Return true. Let extensible be O if extensible is false. Return false. Let bev. Let done be false. Repeat. While done is false, A if P is null, then I set done to true. B else if same value, P, O, is true, then I return false. C else, I if P is not the ordinary object internal method defined in 1, set done to true. 2, else, set P to P, set O to V, return true. 68, ECMA International 2024. Note the loop in step 7 guarantees that there will be no circularities in any prototype chain that only includes objects that use the ordinary object definitions for and 0, 1, 3. The internal method of an ordinary object O takes no arguments and returns a normal completion containing a Boolean. It performs the following steps when called return ordinary is extensible. O1 0, 1, 3. 1 ordinary is extensible. O, the abstract operation ordinary is extensible takes argument O, an object, and returns a Boolean. It performs the following steps when called return O1 0, 1, 4. The internal method of an ordinary object O takes no arguments and returns a normal completion containing true. It performs the following steps when called return ordinary prevent extensions. O1 0, 1, 4. 1 ordinary prevent extensions. O, the abstract operation ordinary prevent extensions takes argument O, an object, and returns true. It performs the following steps when called set O to false, return true. 0, 1, 5. P, the internal method of an ordinary object O takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called return ordinary get own property. O, P1 0, 1, 5. 1 ordinary get own property. O, P, the abstract operation ordinary get own property takes arguments O, an object, and P, a property key, and returns a property descriptor or undefined. It performs the following steps when called if O does not have an own property with key P, return undefined. Let D be a newly created property descriptor with no fields. Let X be O's own property whose key is P if X is a data property. Then, A set D to the value of X's attribute, B set D to the value of X's attribute, else, A assert X is an accessor property, B set D attribute, C set D attribute. ECMA International 2024 169. 6. Set D to the value of X's attribute. Set D to the value of X's attribute. Return D 0, 1, 6. P. Desk. The internal method of an ordinary object O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called return ordinary define own property O, P, desk 1 0, 1, 6. 1 ordinary define own property O, P, desk. The abstract operation ordinary define own property takes arguments O, an object, P, a property key, and desk, a property descriptor, and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called let current be. O, P, let extensible be, is extensible. O, return, capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, O, P, extensible, desk, current, 0, 1, 6, 2 is compatible property descriptor, extensible, desk, current. The abstract operation is compatible property descriptor takes arguments extensible, a Boolean, desk, a property descriptor, and current, a property descriptor or undefined, and returns returns a Boolean. It performs the following steps when called: return, capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, undefined, extensible, desk, current 10163, capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, O, P, extensible, desk, current, the abstract operation, capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, takes arguments O, an object or undefined, P, a property key, extensible, a Boolean, desk, a property descriptor, and current, a property descriptor or undefined, and returns a Boolean. It returns true if and only if desk can be applied as the property of an object with specified extensibility and current property current while upholding invariance. When such application is possible and O is not undefined, it is performed for the property named P, which is created if necessary. It performs the following steps when called: assert, is property key, P, is true if current is undefined, then A if extensible is false, return false, B if O is undefined, return true, C if is accessor descriptor, desk, is true, then I create a known accessor property named P of object O whose, and attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. D else, I create a known data property named P of object O whose, and configurable attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. E return true. Assert, current is a fully populated property descriptor if desk does not have any fields. Return true if current is false. Then 70 ECMA International 2024 ABC, if desk has a field and desk is true, return false. If desk has a field and desk is not current, return false. If is generic descriptor, desk, is false and is accessor descriptor, desk, is not is accessor descriptor, current, return false. D if is accessor descriptor, current, is true, then I if desk has a current. 2. If desk has a current. E else if current is false, then I if desk has a field and desk is true, return false. 2. If desk has a field and same value, desk, current, is false, return false. If O is not undefined, then A if is data descriptor, current, is true and is accessor descriptor, desk, is true, then I if desk has a field, let configurable be desk, else let configurable be current. 2. If desk has a field, let enumerable be desk, else let enumerable be current. 3. Replace the property named P of object O with an accessor property whose and attributes are set to configurable and enumerable, respectively, and whose attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. B else if is accessor descriptor, current, is true and is data descriptor, desk, is true, then I if desk has a field, let configurable be desk, else let configurable be current. 2. If desk has a field, let enumerable be desk, else let enumerable be current. 3. Replace the property named P of object O with a data property whose and enumerable attributes are set to configurable and enumerable, respectively, and whose and attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. C else, I for each field of desk, set the corresponding attribute of the property named P of object O to the value of the field 7. Return true 0, 1, 7, P. The internal method of an ordinary object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. 1. Return. Ordinary has property O, P, 0, 1, 7. 1 ordinary has property O, P. The abstract operation ordinary has property takes arguments O, an O, object, and P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let has own be O, P. If has own is not undefined, return true. Let parent be O. If parent is not null, then a return parent P5. Return false 0, 1, 8. The return ordinary get O, P. Receiver ECMA International 2024 171 10 1, 8. 1 ordinary get O, P. Receiver. The abstract operation ordinary get takes arguments O, an object, P, a property key, and receiver, an ECMA script language value, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Let desk be O, P. If desk is undefined, then a let parent be O, B. If parent is null, return undefined. See return parent. If is data descriptor, desk, is true, return desk. Assert, is accessor descriptor, desk, is true. Let getter be desk. If getter is undefined, return undefined. Return, call, getter, receiver 0, 1, 9. The return ordinary set O, P, V, receiver 10, 1, 9. 1 ordinary set O, P, V, receiver. The abstract operation ordinary set takes arguments O, an object, P, a property key, V, an ECMA script language value, and receiver, an ECMA script language value, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let own desk be O, P. Return ordinary set with own descriptor O, P, V, receiver, own desk 0, 1, 9. 2 ordinary set with own descriptor O, P, V, receiver, own desk. The abstract operation ordinary set with own descriptor takes arguments O, an object, P, a property key, V, an ECMA script language value, receiver, an ECMA script language value, and own desk, a property descriptor or undefined, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If own desk is undefined, then a let parent be O, B. If parent is not null, then I return parent. I set own desk to the property descriptor undefined true, true, true. If is data descriptor own desk is true, then 72 ECMA International 2024 A B C D E. If own desk is false, return false. If receiver is not an object, return false. Let existing descriptor be receiver P. If existing descriptor is not undefined, then I. If is accessor descriptor existing descriptor is true, return false. 2. If existing descriptor is false, return false. 3. Let value desk be the property descriptor V. I've return receiver P. Value desk. Else I assert receiver does not currently have a property P. 2. Return create data property receiver P. V. Assert is accessor descriptor own desk is true. Let setter be own desk. If setter is undefined, return false. Perform call setter receiver V. Return true 0, 1, 1, 0. P. The internal method of an ordinary object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return ordinary delete O, P1, 1 ordinary delete. O, P. The abstract operation ordinary delete takes arguments O, an object, and P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called letDeskBe. O, P. If desk is undefined, return true. If desk is true, then A. Remove the own property with name P from O. B. Return true. Return false. 0, 1, 1, 1. The internal method of an ordinary object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called return ordinary own property keys. O 1 0 1 1 1 1 ordinary own property keys. O, the abstract operation ordinary own property keys takes argument O, an object, and returns a list of property keys. It performs the following steps when called let keys be a new empty list for each own property key P of O such that P is an array index in ascending numeric index order. Do A append P to keys for each own property key P of O such that P is a string and P is not an array index in ascending chronological order of property creation. Do A append P to keys for each own property key P of O such that P is a symbol in ascending chronological order of property creation. Do A append P to keys 5. Return keys 0, 1, 1 2 ordinary object create, prota, additional internal slots list. The abstract operation ordinary object create takes argument prota, an object or null, and optional argument additional internal slots list, a list of names of internal slots, and returns an object. It is used to specify the runtime creation of new ordinary objects. Additional internal slots list contains the names of additional internal slots, ECMA International 2024 173, that must be defined as part of the object, beyond, and if additional internal slots list is not provided, a new empty list is used. It performs the following steps when called let internal slots list be. If additional internal slots list is present, set internal slots list to the list concatenation of internal slots list and additional internal slots list. Let O be make basic object, internal slots list. Set O to prota, return O, 0, 1, 1 3 ordinary create from constructor, intrinsic default prota, internal slots list. The abstract operation ordinary create from constructor takes arguments constructor, a constructor, and intrinsic default prota, a string, and optional argument internal slots list, a list of names of internal slots, and returns either a normal completion containing an object or a throw completion. It creates an ordinary object whose value is retrieved from a constructor's prototype property, if it exists. Otherwise, the intrinsic named by intrinsic default prota is used for internal slots list contains the names of additional internal slots that must be defined as part of the object. If internal slots list is not provided, a new empty list is used. It performs the following steps when called assert. Intrinsic default prota is the specification's name of an intrinsic object. The corresponding object must be an intrinsic that is intended to be used as the value of an object. Let prota be. Get prototype from constructor, intrinsic default prota. If internal slots list is present, let slots list be internal slots list. Else, let slots list be a new empty list. Return ordinary object create, prota, slots list, 0, 1, 1 4 get prototype from constructor, intrinsic default prota. The abstract operation get prototype from constructor takes arguments constructor, a function object, and intrinsic default prota, a string, and returns either a normal completion containing an object or a throw completion. It determines the value that should be used to create an object corresponding to a specific constructor. The value is retrieved from the constructor's prototype property, if it exists. Otherwise, the intrinsic named by intrinsic default prota is used for. It performs the following steps when called assert. Intrinsic default prota is the specification's name of an intrinsic object. The corresponding object must be an intrinsic that is intended to be used as the value of an object. Let prota be. Get constructor prototype. If prota is not an object, then a let realm be. Get function realm. Constructor, B set prota to realms intrinsic object named intrinsic default prota, return prota. Note, although ordinary object create does little more than call make basic object, its use communicates the intention to create an ordinary object, and not an exotic one. Thus, within this specification, it is not called by any algorithm that subsequently modifies the internal methods of the object in ways that would make the result non-ordinary. Operations that create exotic objects invoke make basic object directly. 174. ECMA International 2024. Note, if constructor does not supply a value, the default value that is used is obtained from the realm of the constructor function rather than from the running execution context. The 10th of January 2015 require internal slot. O. Internal slot. The abstract operation require internal slot takes arguments O, an ECMA script language value, and internal slot, an internal slot name, and returns either a normal completion containing unused or a throw completion. It throws an exception unless O is an object and has the given internal slot. It performs the following steps when called. If O is not an object, throw a type error exception. If O does not have an internal slot, throw a type error exception. Return unused. 0.2 ECMA script function objects. ECMA script function objects encapsulate parameterized ECMA script code closed over a lexical environment and support the dynamic evaluation of that code. An ECMA script function object is an ordinary object and has the same internal slots and the same internal methods as other ordinary objects. The code of an ECMA script function object may be either strict mode code 1.1, 2, 2, or non-strict code. An ECMA script function object whose code is strict mode code is called a strict function. One whose code is not strict mode code is called a non-strict function. In addition to and ECMA script function objects also have the internal slots listed in Table 30. Table 30. Internal slots of ECMA script function objects. Internal slot. Type. Description. Environment. An environment record. The environment record that the function was closed over. Used as the outer environment when evaluating the code of the function. Private environment. A. Private environment record or null. The private environment record for private names that the function was closed over null if this function is not syntactically contained within a class. Used as the outer private environment for inner classes when evaluating the code of the function. Formal parameters. A parse node. The root parse node of the source text that defines the function's formal parameter list. ECMA script code. A parse node. The root parse node of the source text that defines the function's body. Constructor kind. Base or derived. Whether or not the function is a derived class constructor. Realm. A realm record. The realm in which the function was created and which provides any intrinsic objects that are accessed when evaluating the function. Script or module. A script record or a module record. The script or module in which the function W as created. This mode. Lexical, strict, or global.
Okay, so I should be able to put 6 right here.
And code body of the function. Lexical means that
The option, whatever.
you have a lexically enclosing function. Strict means that this value is used exactly as provided by an invocation of the function. Global means that this value of undefined or null is interpreted as a reference to the global object.
I gotta tweak one thing.
Is first passed to object. Copyright sign. ECMA International 2024. 75. Table 30. Internal slots of ECMA script function objects. Continued. Internal slot. Type. Description. Strict. A Boolean. True if this is a strict function. False if this is a non-strict function. Home object. An object. If the function uses super, this is the object whose provides the object where super property lookups begin. Source text. A sequence of Unicode code points. The source text that defines the function. Fields. A list of class field definition records. If the function is a class, this is a list of records representing the non-static fields and corresponding initializers of the class. Private methods. A list of private elements.
Okay, I might. There's a possibility I missed something else.
The non-static private methods and accessors of the class. Class field initializer name. A string.
So it should
Or empty. If
print like
initializer of a class field.
all 6 macro parts, whatever.
Of the field. empty otherwise, is class constructor. A boolean indicates whether the function is a class constructor. If true, invoking the functions will immediately throw a type error exception.
Wait, is there 6 parts?
A script
1, 2, 3. Okay, it's not printing 6 because there's 6. It's printing 6
method 0, 2.
just because that's like after 5. It happens to be, I don't know, whatever.
Script function object f take
I'm just adding another option to make it not one of the other ones.
list. A list of ECMA script language values.
Alright, so now I should print this,
Completion containing an ECMA script language evaluation.
and then these.
It performs the following steps when called. Let caller context be the running execution context. Let callee context be prepared.
And all I gotta do
F. Undefined. Assert.
is break this up into chunks,
Execution context.
put each part
True. Then, let error be a newly
into the correct of the 5 blocks,
created in
or the 4 blocks here.
associated realm record. See remove callee
This is so boring.
stack and restore caller context as the running execute.
And then I can have the block scope, call, and then the macro parameter list, call,
Callee context.
and they both should work.
Let result
And then I'll be closer. Then just gotta finish finding replacing.
arguments list.
I can call this demo whatever tutorial to put the freaking image onto the quad.
Running execution context. If result is a return completion, return result. Return if abrupt. Result 0. Return undefined. 176. ECMA International 2024. Note when callee context is removed from the execution context stack in step 7, it must not be destroyed if it is suspended and retained for later resumption by an accessible generator. 1 0 2 1 1 Prepare for ordinary call. F. New target. The abstract operation prepare for ordinary call takes arguments F.
So
Function object. And
hopefully it works.
undefined. And
I was gonna waste 2-3 more minutes setting it up.
it performs the following steps when called. Let caller context be the running
Finally.
context be a new
I think I'm almost
execution context.
caught back up on C.
F. Let
We're gonna write code and I have to check it
callee
because I gotta remember
the script form.
all the parts as I'm going through, whatever.
Let load
Alright, so now it calls the opening. It'll check the type, declare, but only when it's the block mode. Puts the payload, and then the routine.
context to load.
Well, the declare part and the payload part needs more water.
Suspended.
Declare part that declares the temp args, the variables
Running execute.
for the block scope, and the payload
Any exception of
puts the macro argument list after it, so everything's declared. Whatever was supposed to be assigned a value will be assigned when this is placed. And then it's a routine. So this part, these two, get left out for the comma separate list because you can't declare memory inside of a list
the context
that's enclosed in parentheses.
and this argument an ECM
So I'll still have the equality type check and then the routine
called
for the 5 and 6 or 4 and 5 modes I'm adding.
callee realm BF. Let local env be the lexical environment of callee context. If this mode is strict, then let this value be this argument.
For modes 4 and 5.
Argument is
So this part could be left out.
global env be callee realm 2. Assert global env is a global environment record. 3. Let this value be global env. B else I let this value be. To object this argument 2. Note to object produces wrapper objects using callee realm. Assert local env is a function environment record. Assert
But I'll still need to pass in
abrupt completion because local
an argument and indice. I'll figure that out after I get this set up.
value 0. Return unused 0, 2, 1. 3 runtime semantics. Evaluate body. The syntax-directed operation evaluate body takes arguments function object, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ACMA script language value or an abrupt completion. It is defined piecewise over the following productions: function body, function statement list, return, evaluate function body with argument
And after this is set up,
list, concise body, expression,
I don't know, I think I'm almost done.
evaluate concise body with arguments, function object and
I want to benchmark this against C++,
177
just to see if there's any difference.
function body, return, evaluate generated body with
I'm pretty sure mine will be slower,
arguments list,
unless C++ is optimized,
body, return, evaluate a
which I would assume it would be.
generated body with arguments, function object and
If C++ was optimized, then it would use a stack
body, return,
instead of malloc, when it's like local and never goes global. Except I don't know if C++ has that much control over the memory,
concise body of
or to know when it's local and global.
function object and arguments list, initializer, assignment expression
I know my JavaScript engine does.
is empty, assert, function object is not empty, if
It might meet the standard.
definition, assignment expression is true,
I don't know. I want to get to this. This is the fun stuff.
initializer with
I'm tired of C.
object, else, a let RHSB,
I might have to like
get
go to assembly for the stupid engine,
completion record, return,
because it's not, the C compiler sucks.
a static block statement list, a
I get one thing done at a time.
list is empty, return, evaluate class static block body of class static
Some more water.
object, 0,
So I don't know. This is almost done now.
B, F, arguments list, the
They can like tie everything together and finish this up.
takes arguments F, an ECMA script function
I gotta figure out how many vector types there are.
list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It
It shows up 31 times? I thought it was more than that.
evaluate body of F with arguments F and arguments list 1 0 2 2 arguments list, new target, the internal method of a
If I have to like define,
function object F takes arguments list, a list of ECMA script language values
the vector type for each of whatever stupid type there is that it is.
containing an object
And this is templated, so luckily I just have to copy paste it and put the name in.
context be the running
If C had actual macros,
F, if kind is back,
like assembly macros,
and recreate from
then it makes this easier because I could pass in the name as an argument and like macro expand at run or compile time or assemble time.
target
But instead, I have to manually type in each option.
2020
But at least the rest of it is templated from that point on.
function boundary
I'm gonna have to make a separate file
U N
and put all the vector types in it.
I O N
Because it's gonna be a whole bunch of stuff that's be like packed into one area.
A T
The files are getting painful to read.
capital I N S
So I don't know, I get some water. Get back to this.
A T I does not have any
And someone's gonna get done today.
is omitted. 5. Assert. Callee context is now the running execution context. If kind is base, then a performwould inner call bind this F. Callee context. This argument B let initialize result B completion, initialize instance elements. This argument F. See if initialize result is an abrupt completion, then I remove callee context from the execution context stack and restore caller context as the running execution context. 2. Return initialize result. Let constructor env be the lexical environment of callee context. Let result be completion, and recall evaluate body F. Arguments list. Remove callee context from the execution context stack and restore caller context as the running execution context. 0. If result is a return completion, then A. If result is an object, return result. B. If kind is base, return this argument. C. If result is not undefined, throw a type error exception. 1. Else, A. Return if abrupt. Result. 2. Let this binding be constructor env get this binding. 3. Assert. This binding is an object. 4. Return this binding. 0, 2, 3 ordinary function create. Function prototype. Source text. Parameter list. Body. This mode. env. Private env. The abstract operation ordinary function create takes arguments function prototype. An object. Source text. A sequence of Unicode code points. Parameter list. A parse node. Body. A parse node. This mode. Lexical this or non-lexical this. env. An environment record. And private env. A private environment record or null, and returns an ECMA script function object. It is used to specify the runtime creation of a new function with a default internal method and no internal method, although one may be subsequently added by an operation such as make constructor. Dart source text is the source text of the syntactic definition of the function to be created. It performs the following steps when called. Let internal slots list be the internal slots listed in table 30. Let f be ordinary object create. Function prototype. Internal slots list. Set f to the definition specified in 1, 0, 2, 1. Set f to source text. Set f to parameter list. Set f to body. If the source text matched by body is strict mode code. Let strict be true. Else let strict be false. Set f to strict. If this mode is lexical this. Set f to lexical. 0. Else if strict is true. Set f to strict. 1. Else. Set f to global. 2. Set f to false. 3. Set f to env. 4. Set f to private env. 5. Set f to get active script for module. 6. Set f to the current realm record. 7. Set f to undefined. 8. Set f to a new empty list. 9. Set f to a new empty list. 0. Set f to empty. 1. Let len be the expected argument count of parameter list. 2. Perform set function length. F. Len. 3. Return f. ECMA International 2024 1. 79. 1 0 2 4. Capital A D D capital R E S T R I C T E D capital F U N C T I O N capital P R O P E R T I E F realm. The abstract operation capital A D D capital R E S T R I C T E D capital F U N C T I O N capital P R O P E R T I E takes arguments f, a function object, and realm, a realm record, and returns unused. It performs the following steps when called. Assert. Realm exists and has been initialized. Let thrower be realm. Perform. Define property or throw. F. Caller. Property descriptor. Thrower. Enumerable. False. True. Perform. Define property or throw. F. Arguments. Property descriptor. Thrower. Enumerable. False. True. Return unused. 0, 2, 4, 1% throw type error %. This function is the %throw type error % intrinsic object. It is an anonymous built-in function object that is defined once for each realm. It performs the following steps when called. Throw a type error exception. The value of the internal slot of this function is false. The length property of this function has the attributes false, false, false. The name property of this function has the attributes false, false, false. 0, 2, 5 make constructor f. Writable prototype. Prototype. The abstract operation make constructor takes argument f, an ECMA script function object or a built-in function object, and optional arguments writable prototype, a boolean, and prototype, an object, and returns unused. It converts f into a constructor. It performs the following steps when called. If f is an ECMA script function object, then a assert is constructor, f is false, b assert F is an extensible object that does not have a prototype own property. See set F to the definition specified in 1.0. 2. Else, A set F to the definition specified in 1.0. 3. 2. Set F to base. If writable prototype is not present, set writable prototype to true. If prototype is not present, then A set prototype to ordinary object create. %object prototype %. B perform. Define property or throw. Prototype. Constructor. Property descriptor. F. Writable. Writable prototype. False. True. Perform. Define property or throw. F. Prototype. Property descriptor. Prototype. Writable prototype. False. False. Return unused. 80. ECMA International 2024. 1.0.2. 6. Make class constructor. F. The abstract operation make class constructor takes argument F, an ECMA script function object, and returns unused. It performs the following steps when called assert. F is false. Set F to true. Return unused. 0, 2, 7. Make method F. Home object. The abstract operation make method takes arguments F, an ECMA script function object, and home object, an object, and returns unused. It configures F as a method. It performs the following steps when called set F to home object. Return unused. 0, 2, 8. Define method property. Home object. Key. Closure. Enumerable. The abstract operation define method property takes arguments home object, an object, key, a property key or private name, closure, a function object, and enumerable, a boolean, and returns either a normal completion containing either a private element or unused, or an abrupt completion. It performs the following steps when called assert. Home object is an ordinary, extensible object. If key is a private name, then A return private element, method, closure 3. Else, A let desk be the property descriptor, closure, true, enumerable, true. B perform. Define property or throw, home object, key, desk. C note, define property or throw only returns an abrupt completion when attempting to define a class. Static method whose key is prototype. D return unused. 0, 2, 9. Set function name, F, name, prefix. The abstract operation set function name takes arguments F, a function object, and name, a property key or private name, and optional argument prefix, a string, and returns unused. It adds a name property to F. It performs the following steps when called assert. F is an extensible object that does not have a name own property. If name is a symbol, then A let description be name's value. B if description is undefined, set name to the empty string. C else, set name to the string concatenation of description, and else if name is a private name, then A set name to name. If F has an internal slot, then A set F to name. If prefix is present, then A set name to the string concatenation of prefix. The code unit 0x0020, space, and name. B if F has an internal slot, then I optionally set F to name. Perform. Define property or throw, F, name, property descriptor, name, false. Enumerable, false. True. Return unused. ECMA International 2024 181. The 10th of February 2010. Set function length, F, length. The abstract operation set function length takes arguments F, a function object, and length, a non-negative int, 0+, and returns unused. It adds a length property to F. It performs the following steps when called assert. F is an extensible object that does not have a length own property. Perform. Define property or throw, F, length, property descriptor, length, false. Enumerable, false. True. Return unused. 0, 2, 1, 1. Capital F, U, N, C, T, I, O, N. Capital D, E, C, L, A, R, A, T, I, O, N. Capital I, N, S, T, A, N, T, I, A, T, I. Func. Arguments list. The abstract operation function declare. An instantiation takes arguments func, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns either a normal completion containing unused or an abrupt completion. Func is the function object for which the execution context is being established. Note 1. When an execution context is established for evaluating an ECMA script function, a new function environment record is created and bindings for each formal parameter are instantiated in that environment record. Each declaration in the function body is also instantiated. If the function's formal parameters do not include any default value initializers, then the body declarations are instantiated in the same environment record as the parameters. If default value parameter initializers exist, a second environment record is created for the body declarations. Formal parameters and functions are initialized as part of capital F U N C T I O N, capital D E C L A R A T I O N, capital I N S T A N T I A T I. All other bindings are initialized during evaluation of the function body. It performs the following steps when called. Let callee context be the running execution context. Let code be func. Let strict be func. Let formals be func. Let parameter names be the bound names of formals. If parameter names has any duplicate entries, let has duplicates be true. Otherwise, let has duplicates be false. Let simple parameter list be a simple parameter list of formals. Let has parameter expressions be contains expression of formals. Let var names be the var declared names of code. 0. Let var declarations be the var scope declarations of code. 1. Let lexical names be the lexically declared names of code. 2. Let function names be a new empty list. 3. Let functions to initialize be a new empty list. 4. For each element D of our declarations, in reverse list order, do A if D is neither a variable declaration nor a binding nor a binding identifier, then I assert D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration. 2. Let fn be the sole element of the bound names of D. 3. If function names does not contain fn, then insert fn as the first element of function names. Note, if there are multiple function declarations for the same name, the last declaration is used. Insert d as the first element of functions to initialize. 5. Let arguments object needed be true. 6. If func is lexical, then a note, arrow functions never have an arguments object. B set arguments object needed to false. 7. Else if parameter names contains arguments, then a set arguments object needed to false. 82. ECMA International 2024. 18. Else if has parameter expressions is false, then a if function names contains arguments or lexical names contains arguments, then I set arguments object needed to false. 9. If strict is true or has parameter expressions is false, then a note, only a single environment record is needed for the parameters, since calls to eval in strict mode code cannot create new bindings which are visible outside of the eval. B let env be the lexical environment of callee context. 0. Else, a note, a separate environment record is needed to ensure that bindings created by direct eval calls in the formal parameter list are outside the environment where parameters are declared. B let callee env be the lexical environment of callee context. C let env be new declarative environment. Callee env. Deassert. The variable environment of callee context is callee env. E set the lexical environment of callee context to env. 1. For each string param name of parameter names, do a let already declared benv has binding param name. B note. Early errors ensure that duplicate parameter names can only occur in non-strict functions that do not have parameter default values or rest parameters. C if already declared is false, then I perform env create mutable binding param name false. 2. If has duplicates is true, then perform env initialize binding param name undefined. 22. If arguments object needed is true, then a if strict is true or simple parameter list is false, Then, I let AOB create a mapped arguments object, arguments list. B else, I note, a mapped argument object is only provided for non-strict functions that don't have a rest parameter, any parameter default value initializers, or any destructured parameters. 2. Let AOB create mapped arguments object, func, formals, arguments list, env. See if strict is true. Then, I perform the env create a mutable binding, arguments, false. 2. Note, in strict mode code early errors prevent attempting to assign to this binding, so its mutability is not observable. D else, I perform the env create mutable binding, arguments, false. E perform the env initialize binding, arguments, A, O, F. Let parameter bindings be the list concatenation of parameter names and arguments. 3. Else, A. Let parameter bindings be parameter names. 4. Let iterator record be create list iterator record, arguments list. 5. If as duplicates is true, then A perform iterator binding initialization of formals with arguments iterator record and undefined 26. Else, A perform iterator binding initialization of formals with arguments iterator record and env27. If has parameter expressions is false, then, A note, only a single environment record is needed for the parameters and top-level vars. B. Let instantiated var names be a copy of the list parameter bindings. C. For each element n of the var names, do. I. If instantiated var names does not contain n, then, append n to instantiated var names. Perform the env create mutable binding, n, false. Perform the env initialize binding, n, undefined. D. Let var env be env28. Else, A note, a separate environment record is needed to ensure that closures created by expressions in the formal parameter list do not have visibility of declarations in the function body. B. Let var env be new declarative environment, env. C. Set the variable environment of callee context to var env. D. Let instantiated var names be a new empty list. E. For each element n of the var names, do. I. If instantiated var names does not contain n, then, ECMA International 2024 183 1. Append n to instantiated var names. Perform var env create mutable binding, n, false. If parameter bindings does not contain n, or if function names contains n, then, A. Let initial value be undefined for. Else, A. Let initial value be env get binding value, n, false. Perform var env initialize binding, n, initial value. Note, a var with the same name as a formal parameter initially has the same value as the corresponding initialized parameter. 9. Note, an xb 3, 2, 1 adds additional steps at this point. 0. If strict is false, then, A. Let lex-env be new declarative environment, var env. B. Note, non-strict functions use a separate environment record for top-level lexical declarations so that a direct eval can determine whether any var scope declarations introduced by the eval code conflict with pre-existing top-level lexically scoped declarations. This is not needed for strict functions because a strict direct eval always places all declarations into a new environment record. 1. Else, A. Let lex-env be var env. 2. Set the lexical environment of callee context to lex-env. 3. Let lex declarations be the lexically scoped declarations of code. 4. For each element D of lex declarations, do. A note, a lexically declared name cannot be the same as a function-generated declaration, formal parameter, or a var name. Lexically declared names are only instantiated here but not initialized. B. For each element Dn of the bound names of D, do. I. If his constant declaration of D is true, then, perform lex-env create a mutable binding, dn, true 2. Else, perform lex-env create mutable binding, dn, false. 5. Let private env be the private environment of callee context. 6. For each parse node f of functions to initialize, do. A. Let fn be the sole element of the bound names of f. B. Let fo be instantiate function object of f with arguments lex-env and private env. C. Perform var env set mutable binding, fn, fo, false. 7. Return unused 0.3 built-in function objects. A built-in function object is an ordinary object. It must satisfy the requirements for ordinary objects set out in 10.1. In addition to the internal slots required of every ordinary object, see 10.1, a built-in function object must also have the following internal slots: a realm record that represents the realm in which the function was created, a string that is the initial name of the function. It is used by 2, 0, 2, 3, 5. The initial value of a built-in function object's internal slot is %function prototype %, unless otherwise specified. A built-in function object must have an internal method that conforms to the definition in 103. 1. A built-in function object has an internal method if and only if it is described as a constructor, or some algorithm in this specification explicitly sets its internal method. Such an internal method must conform to the definition in 103. 2. An implementation may provide additional built-in function objects that are not defined in this specification. Note 2b. 3.2 provides an extension to the above algorithm that is necessary for backwards compatibility with web browser implementations of ECMAScript that predate ECMAScript 2015. 84. Copyright sign, ECMA International 2024. 103. 1. This argument, arguments list. The internal method of a built-in function object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called: return, built-in call or construct, f. This argument, arguments list, undefined 103. 2. Arguments list, new target, the internal method of a built-in function object f. When the method is present, takes arguments list, a list of ECMAScript language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called: return, built-in call or construct, f. Uninitialized, arguments list, new target 103. 3. Built-in call or construct, f. This argument, arguments list, new target, the abstract operation built-in call or construct takes arguments f, a built-in function object, this argument, an ECMAScript language value or uninitialized, arguments list, a list of ECMAScript language values, and new target, a constructor or undefined, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called: let caller context be the running execution context. If caller context is not already suspended, suspend caller context. Let callee context be a new execution context. Set the function of callee context to f. Let callee realm be f. Set the realm of callee context to callee realm. Set the script or module of callee context to null. Perform any necessary implementation to find initialization of callee context. Push callee context onto the execution context stack. Callee context is now the running execution context. 0. Let result be the completion record that is the result of evaluating f in a manner that conforms to the specification of f if this argument is uninitialized, that this value is uninitialized. Otherwise, this argument provides the this value arguments list provides the named parameters new target provides the new target value. 1. Note, if f is defined in this document, the specification of f is the behavior specified for it via algorithm s, TEPS or other means. 2. Remove callee context from the execution context stack and restore caller context as the running execution context. 3. Return result 0, 3. For create built-in function, behavior, length, name, additional internal slots list, realm, prototype, prefix. The abstract operation create built-in function takes arguments behavior and abstract closure, a set of algorithm steps, or some other definition of a function's behavior provided in this specification, length, a non-negative integer or plus, name, a property key or a private name, and additional internal slots list, a list of names of internal slots, and optional arguments realm, a realm record, prototype, an object or null, and prefix. a string, and returns a function object. Additional internal slots list contains the names of additional internal slots that must. Note when callee context is removed from the execution context stack, it must not be destroyed if it has been suspended and retained by an accessible generator for later resumption. ECMA International 2024-185 be defined as part of the object. This operation creates a built-in function object. It performs the following steps when called. If realm is not present, set realm to the current realm record. If prototype present, set prototype to realm. Let
I think I'm gonna go through first.
containing the names of all the internal slots that 10.3 requires for the built-in function object that is about.
And set it up for like all modes, or 1, 2, 3, 4, 6,
Let func be in
or 0 to 5, whatever.
when called.
Then make sure it like logs correctly.
The provided argument
I'll put like the number next to it too, whatever.
defined by
Just to have everything in place.
it has internal slots whose names are
Then
slots list and an internal slot. Set func to prototype.
go through the Vulkan tutorial
Set func to null 0.
code.
Set function length func length 1.
Then it puts the image onto the quad.
A performs set function name func
Then every place.
else. A performs set function name func name prefix 13.
That vector is used.
Each built-in function defined in this specification is created by calling the create
All the types. Make a list of them.
point for built-in exotic object.
Put them in a separate file.
This specification defines several kinds
Then
of objects. These objects generally behave similar to ordinary objects except for a few specific situations. The following exotic objects use the ordinary object internal methods except with
add the
specified otherwise below. 0, 4, 1 bound function exotic objects. A bound function exotic object is an exotic object that wraps another function object. A bound function
the dot data.
it has an internal method and may have a struct internal method. Calling a bound function exotic object generally results in a call of its wrapped function.
Routine for the vector things.
Its and
I think like dot size is one of them.
methods use the following implementations, and its other internal methods use the definitions found in 10.1. These methods are installed in bound function create, bound function
Then dot size too.
internal slots of VCMA
So I want to like
listed in table 30. Instead that
define those two modes.
listed in table 31.
That's why I'm adding the 4th and 5th mode,
Lots of bound function
because they have to be wrapped in parentheses instead of a block.
description, bound target function, a callable object, the wrap function object, bound this, an ECMA script language value, the value
So like for these two, whatever.
of this value when calling the wrapped function, bound argument,
Then I can like
script language value
also like make those macros. Those aren't as difficult.
to the wrapped function.
I already have the
ECMA International 2004
resizing and stuff
1.
already set up,
This argument
so the macro's done.
list, the internal method of a
So I need to like
takes argument
make sure all the new macro wrappers or concat token concation things work. And it forms the correct macro to call, parts to call.
turns either a normal completion containing an ECMA script language.
Put in a couple more macros.
It performs the following steps when
Then I'll have the list of all the vector types.
BF let args be
Then you just have to like type everything in place,
list return
and all the vector stuff should be working.
this arg
And I have to make an array type because array shows up here too.
arguments list new target the inter
So there's vector, there's array.
def takes arguments list a list of ECMA script language values and new target a constructor and returns either a normal
So I guess this is an array of these things.
performs
I don't know what the difference is between vector and array.
f a
They seem the same thing.
constructor target is true let bound args bf
I guess vector you push to pen memory, and array you just access it.
value f new target
Does array resize?
target return
It looks like array has a length.
target args new target 0 4 1 3 bound function create
Maybe it's not resizable.
bound this bound args
Oh, it's static. Maybe I don't need to make a type for array.
target function,
Maybe we can just use a local, just normal array.
language value, and bound args, a list of ECMA script language values, and returns either a normal completion containing a function object or a throw completion. It is used to specify the creation of new bound function exotic objects. It performs the following steps.
That's a lot of work to like make an array,
Let
to make it static std.
and the internal slots
I don't know, whatever.
C1
Maybe you don't have to make one for this.
object
For the vector type I do.
slots list
So I'm gonna like try to finish this up then.
obj
There's not that much left to do.
1 if is construct
I just gotta piece back together a couple parts and then get it running.
obj is described in 104 2 set obj target function
And let's put it.
this set
If I could get this done,
0 return
the
4 to array exotic objects. An array is an exotic object that gives special treatment to array index property keys. C6 1 7. A property whose property name is an array index is also called an element. Every array has a non-configurable length property whose value is always a
getting the video
strictly less.
and like clipping out the middle to put the video in.
Property is numerically
That's like easy.
the own property whose name is an array index. Whenever an own property
And then once I get the
necessary to maintain this invariant
image onto the quad,
property is added whose name is an array index. The value of the length
resizing the quad,
vary to be one more than the numeric value of that array.
like this is a spinning quad, whatever.
The value
Resizing it, it's really easy. It's just like floating point numbers.
whose value is not smaller than the new length is deleted.
So I don't know, the rest of it is really simple.
To own ECMA International 2024
I could try to focus. If I get this done today, that'd be awesome.
properties that may be inherited from its prototypes. An object
It's a whole lot of work to get a freaking image onto the quad.
or method uses the following implement
I'm making it more work by not using C++, but
definitions
I'm not going to use C++ because
feds are in
C++ sucks.
0 4 2 1.
But after I get the vector stuff set up, I'm going to benchmark it against C++.
A property
My code, it's not optimized. So I don't know, whatever. I just want to see
containing a
if there's any difference, if it happens to be faster.
performs the following steps.
It shouldn't be, but if it is,
An 8 return
well, that's why C++ sucks. If it's not faster, then I don't know, it probably won't be.
the ordinary
Because I would assume that C++ is optimized behind the scenes.
to descriptor
But if it's not faster, it means it's not. And C++ sucks. So like, if it's not faster, I don't know, it could go either way.
non-negative
Just want to benchmark it.
index B. To
I gotta like focus and try to get done then.
length and length desk is false. Return false. H let succeeded B. Ordinary defined
More caffeine. Pepsi.
I if 6 operation array create takes argument length and optional argument prota, an object, and returns either a normal completion containing an array exotic object or a throw completion. It is used to specify the creation of new arrays. It performs the following steps when called if length 232 1, throw a range error exception. If prota is not present, set prota to %array prototype %. Let A be make basic object. Set A to prota. Set A is specified in 1 0 4 2 1. Perform. Ordinary define own property A length property descriptor length true false false return A 0 4 2 3 array species create original array length. The abstract operation array species create takes arguments original array, an object, and length, a non-negative integer, and returns either a normal completion containing an object or a throw completion. It is used to specify the creation of a new array or similar object using a constructor function that is derived from original array. It does not enforce that the constructor then a set C to get C at species. B if C is null, set C to undefined. If C is undefined, return array create length. If is constructor, C is false. Throw a type error exception. Return construct C length 0 4 2 for array set length a desk. The abstract operation array set length takes arguments a, an array, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If desk does not have a field, then a return ordinary define own property a length desk. Let new len desk be a copy of desk. Let new len be to 32 desk. Let number len be to number desk. If same value 0, new len number len is false. Throw a range error exception. Set new len desk to new len. Let old len desk be ordinary get own property a length assert is data descriptor. Old len desk is true. Assert old len desk is false. 0. Let old len be old len desk. 1. If new len old len, then a return ordinary define own property a length new len desk. 2. If old len desk le is false, return false. 3. If new len desk does not have a field or new len desk is true, then a let new writable be true. 4. Else a note setting the attribute to false is deferred in case any elements cannot be deleted. B let new writable be false. C set new len desk to true. 5. Let succeeded be ordinary define own property a length new len desk. 6. If succeeded is false, return false. 7. For each own property keep P of A such that P is an array index and 32 P new len in descending numeric index order. Do a let delete succeeded be a P. B if delete succeeded is false, then I set new len desk to 32 P plus 1. 2. If new writable is false, set new len desk to false. 3. Perform ordinary define own property a length new len desk. 5. Return false. 8. If new writable is false, then a set succeeded to ordinary define own property a length property descriptor false. B assert succeeded is true. 9. Return true. Note if original array was created using the standard built-in array constructor for a realm that is not the realm of the running execution context, then a new array is created using the realm of the running execution context. This maintains compatibility with web browsers that have historically had that behavior for the array prototype methods that now are defined using array species create. ECMA International 2024 189. Note, in steps 3 and 4, if desk is an object then its value of method is called twice. This is legacy behavior that was specified with this effect starting with the second edition of this specification. 0. 4. 3 string exotic objects. A string object is an exotic object that encapsulates a string value and exposes virtual integer indexed data properties corresponding to the individual code unit elements of the string value. String exotic objects always have a data property named length whose value is the length of the encapsulated string value. Both the code unit data properties and the length property are non-writable and non-configurable. An object is a string exotic object, or simply, a string object, if its and internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in string create. String exotic objects have the same internal slots as ordinary objects. They also have an internal slot 1 0 4 3 1 p. The internal method of a string exotic object S takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desc be ordinary get own property S p. If desc is not undefined, return desc. Return string get own property S p, 3.2 p. Desc. The internal method of a string exotic object S takes arguments p, a property key, and desc, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let string desc be string get own property S p. If string desc is not undefined, then a let extensible bs b return is compatible property descriptor extensible desc string desc return ordinary define own property S p desc 0 4 3 3. The internal method of a string exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let keys be a new empty list. Let str be O assert. Str is a string. Let len be the length of str for each integer I such that 0 I len in ascending order. Do a append to string I to keys for each own property key p of O such that p is an array index and to integer or infinity p len in ascending numeric index order. Do a append p to keys for each own property key p of O such that p is a string and p is not an array index in ascending chronological order of property creation. Do a append p to keys. 90. ECMA International 2024 8. For each own property key p of O such that p is a symbol in ascending chronological order of property creation. Do a append p to keys. 9. Return keys 0 4 3 4. String create value prototype. The abstract operation string create takes arguments value, a string, and prototype, an object, and returns a string exotic object. It is used to specify the creation of new string exotic objects. It performs the following steps when called. Let S be make basic object. Set S to prototype. Set S to value. Set S is specified in 1 0 4 3 1. Set S is specified in 1 0 4 3 2. Set S is specified in 1 0 4 3 3. Let length be the length of value. Perform. Define property or throw S length. Property descriptor length false. Enumerable false. False. Return S 0 4 3 5. String get own property S p. The abstract operation string get own property takes arguments S, an object that has an internal slot, and p, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If p is not a string, return undefined. Let index be canonical numeric index string p. If index is undefined, return undefined. If is integral number index is false, return undefined. If index is -0, return undefined. Let str be S assert. Str is a string. Let len be the length of str. If index 0 or len index return undefined 0. Let result str be the substring of str from index to index plus 1 1. Return the property descriptor result str false true false 0 4 4 arguments exotic objects. Most DCMA script functions make an arguments object available to their code. Depending upon the characteristics of the function definition, its arguments object is either an ordinary object or an arguments exotic object. An arguments exotic object is an exotic object whose array index properties map to the formal parameters bindings of an invocation of its associated ECMA script function. An object is an arguments exotic object if its internal methods use the following implementations. with the ones not specified here using those found in 10.1. These methods are installed in createMapped arguments object. Arguments exotic objects have the same internal slots as ordinary objects. They also have an internal slot. Ordinary arguments objects also have an internal slot whose value is always undefined. For ordinary argument objects, the internal slot is only used by object prototype to string 20, 1, 3, 6 to identify them as such. Note 1: while create and mapped arguments object is grouped into this clause, it creates an ordinary object, not an arguments exotic object. ECMA International 2024 191. Note 2: the integer indexed data properties of an arguments exotic object whose numeric name values are less than the number of formal parameters of the corresponding function object initially share their values with the corresponding argument bindings in the function's execution context. This means that changing the property changes the corresponding value of the argument binding and vice versa. This correspondence is broken if such a property is deleted and then redefined, or if the property is changed into an accessor property. If the arguments object is an ordinary object, the values of its properties are simply a copy of the arguments passed to the function, and there is no dynamic linkage between the property values and the formal parameter values. Note 3: the parameter map object and its property values are used as a device for specifying the arguments object correspondence to argument bindings. The parameter map object and the objects that are the values of its properties are not directly observable from ECMA script code. An ECMA script implementation does not need to actually create or use such objects to implement the specified semantics. Note: for ordinary arguments objects define a non-configurable accessor property named callee, which throws a type error exception on access. The callee property has a more specific meaning for arguments exotic objects, which are created only for some class of non-strict functions. The definition of this property in the ordinary variant exists to ensure that it is not defined in any other manner by conforming ECMA script implementations. Note 5: ECMA script implementations of arguments exotic objects have historically contained an accessor property named caller. Prior to ECMA script 2017, this specification included the definition of a throwing caller property on ordinary arguments objects. Since implementations do not contain this extension any longer, ECMA script 2017 dropped the requirement for a throwing caller accessor 0.4.4.1 p. The internal method of an arguments exotic object args takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called: let desc be ordinary get own property, args p. If desc is undefined, return undefined. Let map be args, let is map be, has own property, map p. If is mapped is true, then a set desc to get map p6, return desc 0.4.4.2 p. Desc. The internal method of an arguments exotic object args takes arguments p, a property key, and desc, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called: let map be args, let is map be, has own property, map p. Let new arg desc be desc. If is mapped is true and is data descriptor, desc, is true, then a. If desc does not have a field, desc has a field, and desc is false, then I set new arg desc to a copy of desc. 2. Set new arg desc to get map p. Let allowed be ordinary define own property, args p. New arg desc 92. ECMA International 2024 6. If allowed is false, return false. If is mapped is true, then a. If is accessor descriptor, desc, is true, then I perform map p. B else I. If desc has a field, then assert. The following set will succeed, since formal parameters mapped by arguments objects are always writable. Perform set map p. Desc false. 2. If desc has a field and desc is false, then perform map p8, return true. 0.4.4.3. The let map be args, let is map b, has own property, map P. If is mapped is false, then A. Return. Ordinary get. Args. P. Receiver 4. Else. A. Assert. Map contains a formal parameter mapping for P. B. Return. Get. Map. P. 0. 4. 4. 4. The returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called if same value. Args. Receiver is false. Then A let is map be false. Else A let map be args. B let is map B. Has own property. Map. P. If is mapped is true. Then A assert. The following set will succeed. Since formal parameters mapped by arguments objects are always writable. B perform. Set. Map. P. V. False. Return. Ordinary set. Args. P. V. Receiver 0. 4. 4. 5. P. The internal method of an argument's exotic object args takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called let map be args. Let is map B. Has own property. Map. P. Let result B. Ordinary delete. Args. P. If result is true and is mapped is true, then A perform map. P5. Return result. ECMA International 2024 193 10 4 4 6. Create and mapped arguments object. Arguments list. The abstract operation create and mapped arguments object takes arguments list, a list of ECMA script, language values, and returns an ordinary object. It performs the following steps when called let len be the number of elements in arguments list. Let obj be ordinary object create. %object prototype set obj to undefined. Perform. Define property or throw. Obj length. Property descriptor len. True. Enumerable. False. True. Let index be 0. Repeat. While index len a let val be arguments list. Index b perform. Create data property or throw. Obj to string. Index val c set index to index +1. Perform. Define property or throw. Obj at iterator. Property descriptor. %array prototype values true. False. True. Perform. Define property or throw. Obj callee. Property descriptor. %throw type error false. False. Return obj 0. 4. 4. 7. Create mapped arguments object. Func. Formals. Arguments list. env. The abstract operation create mapped arguments object takes arguments func, an object, formals, a parse node, arguments list, a list of ECMA script language values, and env, an environment record, and returns an argument's exotic object. It performs the following steps when called assert. Formals does not contain a rest parameter, any binding patterns, or any initializers. It may contain duplicate identifiers. Let len be the number of elements in arguments list. Let obj be make basic object. Set obj as specified in 1 0. 4. 4. 1. Set obj as specified in 1 0. 4. 4. 2. Set obj set obj as specified in 1 0. 4. 4. 5. Set obj to %object prototype %0. Let map be ordinary object create. Null 1. Set obj to map 2. Let parameter names be the bound names of formals 3. Let number of parameters be the number of elements in parameter names 4. Let index be 0. 5. Repeat. While index len a let val be arguments list. Index b perform. Create data property or throw. Obj to string. Index val c set index to index +1 6. Perform. Define property or throw. Obj length. Property descriptor len. True. False. True. 7. Let mapped names be a new empty list 8. Set index to number of parameters 1 9. Repeat. While index 0 94. ECMA International 2024 A B C. Let name be parameter names. Index If mapped names does not contain name, then I append name to mapped names. 2. If index len, then let G be make arggetter name env. Let P be make argsetter name env. Perform map to string index property descriptor get G false true. Set index to index 1 20. Perform define property or throw obj at iterator property descriptor percent array prototype values percent true false true 1. Perform define property or throw obj callee property descriptor func true false true 2. Return obj 0 4 4 7 1 make arggetter name env. The abstract operation make arggetter takes arguments name a string and env an environment record and returns a function object. It creates a built-in function object that when executed returns the value bound for name in env. It performs the following steps when called. Let getClosure be a new abstract closure with no parameters that captures name and env and performs the following steps when called. A return env get binding value name false. Let getter be create built-in function getClosure 0. Note: getter is never directly accessible to ECMA script code. Return getter 0 4 4 7 to make argsetter name env. The abstract operation make argsetter takes arguments name a string and env an environment record and returns a function object. It creates a built-in function object that when executed sets the value bound for name in env. It performs the following steps when called. Let setClosure be a new abstract closure with parameters value that captures name and env and performs the following steps when called. A return env set mutable binding name value false. Let setter be create built-in function setClosure 1. Note: setter is never directly accessible to ECMA script code. Return setter 0 4 5 typed array exotic objects. A typed array is an exotic object that performs special handling of integer index property keys. Typed arrays have the same internal slots as ordinary objects and additionally length and internal slots. An object is a typed array if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by typed array create 0 4 5 1 P. The internal method of a typed array takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. If P is a string, then A let numeric index be canonical numeric index string P. B if numeric index is not undefined, then I let value be typed array a get element O numeric index. 2. If value is undefined, return undefined. 3. Return the property descriptor value true true true. Return ordinary get own property O P. ECMA International 2024 195 1045 P. The internal method of a typed array takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a string, then A let numeric index be canonical numeric index string P. B if numeric index is not undefined, return is valid integer index O numeric index. Return ordinary has property O P 0 4 5 3 P. Desk. The internal method of a typed array takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a string, then A let numeric index be canonical numeric index string P. B if numeric index is not undefined, then I if is valid integer index O numeric index is false, return false. 2. If desk has a field and desk is false, return false. 3. If desk has a field and desk is false, return false. 5. If is access a descriptor, desk, is true, return false. V if desk has a field and desk is false, return false. V if desk has a field, perform. Typed array set element, O, numeric index, desk, 7. Return true, return. Ordinary define own property, O, P, desk, 0, 4, 5, 4. The steps when called if P is a string, then A let numeric index be canonical numeric index string, P. B if numeric index is not undefined, then I return typed array a get element, O, numeric index 2. Return ordinary get, O, P, receiver, 0, 4, 5, 5. The if P is a string, then A let numeric index be canonical numeric index string, P. B if numeric index is not undefined, then I if same value, O, receiver, is true, then perform. Typed array set element, O, numeric index, V, return true, 2. If is valid integer index, O, numeric index, is false, return true. Return ordinary set, O, P, V, receiver, 96. ECMA International 2024 10456 P. The internal method of a typed array O takes argument P, a property key, and returns a normal completion containing a Boolean. It performs the following steps when called if P is a string, then A let numeric index be canonical numeric index string, P. B if numeric index is not undefined, then I if is valid integer index, O, numeric index, is false, return true, else return false 2. Return ordinary delete, O, P, 0, 4, 5, 7. The internal method of a typed array O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called let tar record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, A, Y, capital W, I, T, H, capital B, U, F, E, R, capital W, I, T, N, E, S, O, sexy S, T. Let keys be a new empty list. If is typed array out of bounds, tar record, is false. Then, A let length be typed array length, tar record, B for each integer I such that 0 I, length, in ascending order, do I append to string, I, to keys. For each own property key P of O such that P is a string and P is not an integer index, in ascending chronological order of property creation, do I append P to keys. For each own property key P of O such that P is a symbol, in ascending chronological order of property creation, do I append P to key 6. Return keys 0, 4, 5, 8. Typed array with buffer witness records. And typed array with buffer witness record is a record value used to encapsulate a typed array along with the cached byte length of the viewed buffer. It is used to help ensure there is a single shared memory read event of the byte length data block when the viewed buffer is a growable shared array buffer. Typed array with buffer witness records have the fields listed in Table 32. Table 32. Typed array with buffer witness record fields 0, 4, 5, 9. Capital M, A, K, E, capital T, Y, P, E, D, capital A, R, A, Y, capital W, I, T, H, capital B, U, F, E, R, capital W, I, T, N, E, S, O, B, J, order. The abstract operation, capital M, A, K, E, capital T, Y, P, E, D, capital A, R, A, Y, capital W, I, T, H, capital B, U, F, E, R, capital W, I, T, N, E, S, takes arguments O, B, J, a typed array, and order, sexy ST or unordered, and returns a typed array with buffer witness record. It performs the following steps when called let buffer be obj. If is detached buffer, buffer is true. Then, a let byte length be detached, field name, value, meaning, object, a typed array, the typed array whose buffer's byte length is loaded, cached buffer byte length, a non-negative integer or detached, the byte length of the objects when the record was created, copyright sign, ECMA International 2024 197. 3. Else, a let byte length be array buffer byte length, buffer, order, return the typed array with buffer witness record, obj, byte length, 0, 4, 5, 1 0 typed array create, prototype. The abstract operation typed array create takes argument prototype, an object, and returns a typed array. It is used to specify the creation of new typed arrays. It performs the following steps when called let internal slots list be. Let A be make basic object, internal slots list. Set A as specified in 1 0, 4, 5, 1. Set A as specified in 1 0, 4, 5, 2. Set A as specified in 1 0, 4, 5, 3. Set A as specified in 1 0, 4, 5, 6. Set A as specified in 1 0, 4, 5, 7, 0. Set A to prototype 1. Return A 0, 4, 5, 1 1 typed array byte length, tar record. The abstract operation typed array byte length takes argument tar record, a typed array with buffer witness, record, and returns a non-negative integer. It performs the following steps when called if is typed array out of bounds, tar record, is true, return 0. Let length be typed array length, tar record. If length equals 0, return 0. Let O be tar record. If O is not auto, return O. Let element size be typed array element size. O, return length element size, 0, 4, 5, 1 2 typed array length, tar record. The abstract operation typed array length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called assert. Is typed array out of bounds, tar record, is false. Let O be tar record. If O is not auto, return O. Assert. Is fixed length array buffer, O, is false. Let byte offset be O. Let element size be typed array element size, O. Let byte length be tar record. Assert. Byte length is not detached, return floor. Byte length, byte offset, element size, 0, 4, 5, 1 3 is typed array out of bounds, tar record. The abstract operation is typed array out of bounds takes argument tar record, a typed array with buffer witness record, and returns a boolean. It checks if any of the object's numeric properties reference a value at an index not contained within the underlying buffer's bounds. It performs the following steps when called 2. Let O be tar record. Let buffer byte length be tar record. 98. ECMA International 2024. 3. Assert. Is detached buffer, O, is true if and only if buffer byte length is detached. If buffer byte length is detached, return true. Let byte offset start be O. If O is auto, then a let byte offset end be buffer byte length. Else, a let element size be typed array element size. O, B let byte offset end be byte offset start plus O element size. If byte offset start, buffer byte length or byte offset end, buffer byte length, return true. Note: 0 length typed arrays are not considered out of bounds. 0. Return false. 0, 4, 5, 1 4 is valid integer index. O, index. The abstract operation is valid integer index takes arguments O, a typed array, and index, a number, and returns a boolean. It performs the following steps when called if is detached buffer, O, is true, return false. If is integral number, index, is false, return false. If index is -0, return false. Let tar record be capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O Checking is not a synchronizing operation when O's backing buffer is a growable shared array buffer. If is typed array out of bounds, tar record is true. Return false. Let length be typed array length, tar record. If index 0 or index length, return false. Return true. 0, 4, 5, 1, 5 typed array a get element. O, index. The abstract operation typed array a get element takes arguments O, a typed array, and index, a number, and returns a number, a big int, or undefined. It performs the following steps when called. If is valid integer index, O, index, is false. Return undefined. Let offset be O. Let element size be typed array element size. O. Let byte index in buffer be index, element size, plus offset. Let element type be typed array element type. O. Return get value from buffer. O. Byte index in buffer, element type, true. Unordered 0, 4, 5, 1, 6 typed array set element, O, index, value. does not contain a rest parameter, any binding patterns, or any initializers. It may contain duplicate identifiers. Let len be the number of elements in arguments list. Let obj be make basic object. Set obj as specified in 1 0 4 4 1. Set obj as specified in 1 0 4 4 2. Set obj set obj set obj as specified in 1 0 4 4 5. Set obj to %object prototype %0. Let map be ordinary object create. Null 1. Set obj to map 2. Let parameter names be the bound names of formals 3. Let number of parameters be the number of elements in parameter names 4. Let index be 0 5. Repeat. While index len a let val be arguments list. Index b perform. Create data property or throw obj to string index val c set index to index +1 6. Perform. Define property or throw obj length property descriptor len true false true 7. Let mapped names be a new empty list 8. Set index to number of parameters 1 9. Repeat. While index 0 94. ECMA International 2024 A B C. Let name be parameter names index. If mapped names does not contain name, then I append name to mapped names 2. If index len, then let G be make arggetter name env. Let P be make argsetter name env. Perform map to string index property descriptor get G false true. Set index to index 1 20. Perform. Define property or throw obj at iterator property descriptor %array prototype values true false true 1. Perform. Define property or throw obj callee property descriptor func true false true 2. Return obj 0 4 4 7 1. Make arggetter name env. The abstract operation make arggetter takes arguments name a string and env an environment record and returns a function object. It creates a built-in function object that when executed returns the value bound for name in env. It performs the following steps when called. Let getClosure be a new abstract closure with no parameters that captures name and env and performs the following steps when called. A return env get binding value name false. Let getter be create built-in function getClosure 0. Note. Getter is never directly accessible to ECMA script code. Return getter 0 4 4 7 to make argsetter name env. The abstract operation make argsetter takes arguments name a string and env an environment record and returns a function object. It creates a built-in function object that when executed sets the value bound for name in env. It performs he following steps when called. Let setClosure be a new abstract closure with parameters value that captures name and env and performs the following steps when called. A return env set mutable binding name value false. Let setter be create built-in function setClosure 1. Note. Setter is never directly accessible to ECMA script code. Return setter 0 4 5 typed array exotic objects. A typed array is an exotic object that performs special handling of integer index property keys. Typed arrays have the same internal slots as ordinary objects and additionally length and internal slots. An object is a typed array if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by typed array create 0 4 5 1 p. The internal method of a typed array O takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. If p is a string, then a let numeric index be canonical numeric index string p. If numeric index is not undefined, then I let value be typed array a get element o numeric index 2. If value is undefined, return undefined. 3. Return the property descriptor, value, true, true, true. Return ordinary get own property, OP. ECMA International 2024 195 10452 P. The internal method of a typed array O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a string, then A let numeric index be canonical numeric index string, P. B if numeric index is not undefined. Return is valid integer index, O, numeric index. Return, ordinary has property, O, P. 0, 4, 5, 3, P. Desk. The internal method of a typed array O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a string, then A let numeric index be canonical numeric index string, P. B if numeric index is not undefined. Then I if is valid integer index, O, numeric index, is false. Return false. 2. If desk has a field and desk is false, return false. 3. If desk has a field and desk is false, return false. 5. If is access a descriptor, desk, is true, return false. V if desk has a field and desk is false, return false. V. If desk has a field, perform. Typed array set element, O, numeric index, desk. 7. Return true. Return, ordinary define own property, O, P. Desk. 0, 4, 5, 4. If P is a string, then A let numeric index be canonical numeric index string, P. B if numeric index is not undefined. Then I return typed array a get element, O, numeric index 2. Return, ordinary get, O, P. Receiver. 0, 4, 5, 5. If P is a string, then A let numeric index be canonical numeric index string, P. B if numeric index is not undefined. Then I if same value, O, receiver, is true, then perform. Typed array set element, O, numeric index, V. Return true. 2. If is valid integer index, O, numeric index, is false, return true. Return, ordinary set, O, P. V. Receiver. 96. ECMA International 2024 104, 5, 6. P. The internal method of a typed array O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a string, then A let numeric index be canonical numeric index string, P. B if numeric index is not undefined. Then I if is valid integer index, O, numeric index, is false, return true, else return false. 2. Return, ordinary delete, O, P. 0, 4, 5, 7. The internal method of a typed array O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let tar record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, sexy ST. Let keys be a new empty list. If is typed array out of bounds, tar record, is false. Then A let length be typed array length, tar record be for each integer I such that 0I, length, in ascending order, do I append to string I to keys for each own property key P of O such that P is a string and P is not an integer index. In ascending chronological order of property creation, do I append P to keys for each own property key P of O such that P is a symbol. In ascending chronological order of property creation, do I append P to keys. 6. Return keys 0, 4, 5, A typed array with buffer witness records. And typed array with buffer witness record is a record value used to encapsulate a typed array along with the cached byte length of the viewed buffer. It is used to help ensure there is a single shared memory read event of the byte ngth data block when the viewed buffer is a growable shared array buffer. Typed array with buffer witness records have the fields listed in Table 32. Table 32. Typed array with buffer witness record fields 0, 4, 5, 9. Capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, B, J, order. The abstract operation, capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, takes arguments O, B, J, a typed array, and order, sex est or unordered, and returns a typed array with buffer witness record. It performs the following steps when called let buffer be obj if is detached buffer is true. Then, a let byte length be detached, field name, value, meaning, object, a typed array, the typed array whose buffer's byte length is loaded, cached buffer byte length, a non-negative integer or detached, the byte length of the objects when the record was created. Copyright sign, ECMA International 2024 197. 3. Else, a let byte length be array buffer byte length, buffer, order, return the typed array with buffer witness record. OBJ, byte length 0, 4, 5, 1, 0 typed array create. Prototype. The abstract operation typed array create takes argument prototype, an object, and returns a typed array. It is used to specify the creation of new typed arrays. It performs the following steps when called let internal slots list be. Let A be make basic object, internal slots list. Set A as specified in 1, 0, 4, 5, 1. Set A as specified in 1, 0, 4, 5, 2. Set A as specified in 1, 0, 4, 5, 3. Set A. Set A. Set A as specified in 1, 0, 4, 5, 6. Set A as specified in 1, 0, 4, 5, 7, 0. Set A to prototype 1. Return A 0, 4, 5, 1, 1 typed array byte length. Tar record. The abstract operation typed array byte length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called if is typed array out of bounds. Tar record is true. Return 0. Let length be typed array length. Tar record. If length equals 0, return 0. Let O be tar record. If O is not auto, return O. Let element size be typed array element size. O. Return length element size 0, 4, 5, 1, 2 typed array length. Tar record. The abstract operation typed array length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called assert. Is typed array out of bounds. Tar record is false. Let O be tar record. If O is not auto, return O. Assert is fixed length array buffer. O is false. Let byte here. Set BO. Let element size be typed array element size. O. Let byte length be tar record. Assert. Byte length is not detached. Return floor. Byte length. Byte offset. Element size 0, 4, 5, 1, 3 is typed array out of bounds. Tar record. The abstract operation is typed array out of bounds takes argument tar record, a typed array with buffer witness record, and returns a Boolean. It checks if any of the object's numeric properties reference a value at an index not contained within the underlying buffer's bounds. It performs the following steps when called 2. Let O be tar record. Let buffer byte length be tar record. 98. ECMA International 2024. 3. assert, is detached buffer, O, is true if and only if buffer byte length is detached. If buffer byte length is detached, return true. Let byte offset start be O if O is auto, then a let byte offset end be buffer byte length, else a let element size be typed array element size. O, B let byte offset end be byte offset start plus O element size. If byte offset start, buffer byte length or byte offset end, buffer byte length, return true. Note: 0 length typed arrays are not considered out of bounds. 0. Return false. 0, 4, 5, 1 4 is valid integer index. O, index. The abstract operation is valid integer index takes arguments O, a typed array, and index, a number, and returns a boolean. It performs the following steps when called. If is detached buffer, O, is true, return false. If is integral number, index, is false, return false. If index is -0, return false. Let record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, unordered. Note: bounds checking is not a synchronizing operation when O's backing buffer is a growable shared array buffer. If is typed array out of bounds, record is true, return false. Let length be typed array length, record. If R, index, 0 or R, index, length, return false, return true. 0, 4, 5, 1 5 typed array a get element, O, index. The abstract operation typed array a get element takes arguments O, a typed array, and index, a number, and returns a number, a big int, or undefined. It performs the following steps when called. If is valid integer index, O, index, is false, return undefined. Let offset be O, let element size be typed array element size. O, let byte index in buffer be R, index, element size, plus offset. Let element type be typed array element type. O, return get value from buffer. O, byte index in buffer, element type, true, unordered. 0, 4, 5, 1 6 typed array set element, O, index, value. The abstract operation typed array set element takes arguments O, a typed array, index, a number, and value, an ECMA script language value, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Capital IFO is bigint, let num value be. To big int, value. Otherwise, let num value be. To number, value. If is valid integer index, O, index, is true. Then, a let offset be O, B let element size be typed array element size. O, C let byte index in buffer be R, index, element size, plus offset. D let element type be typed array element type. O, E perform set value in buffer. O, byte index in buffer, element type, num value, true. Unordered, return unused. ECMA International 2024 199, 10, 4, 5, 1 7 is array buffer view out of bounds. O, the abstract operation is array buffer view out of bounds takes argument O, a typed array or a data view, and returns a boolean. It checks if either any of a typed array's numeric properties or a data view object's methods can reference a value at an index not contained within the underlying data block's bounds. This abstract operation exists as a convenience for upstream specifications. It performs the following steps when called. If O has an internal slot, then A let view record be capital M, A, K, E, capital D, A, T, A, capital V, I, E, W, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, S, capital R, O, sec CS, T, B return is view out of bounds. View record. Let record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, sexy S, T, return is typed array out of bounds, tar record, 0, 4, 6 module namespace exotic objects. A module namespace exotic object is an exotic object that exposes the bindings exported from an ECMA script module. C16, 2, 3. There is a one-to-one correspondence between the string keydown properties of a module namespace exotic object and the binding names exported by the module. The exported bindings include any bindings that are indirectly exported using export items. Each string value down property key is the string value of the corresponding exported binding name. These are the only string keyed properties of a module namespace exotic object. Each such property has the attributes true, true, false. Module namespace exotic objects are not extensible. An object is a module namespace exotic object if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by module namespace create. Module namespace exotic objects have the internal slots defined in Table 33. Table 33. Internal slots of module namespace exotic objects. Internal slot type description module A module record. The module record whose exports this namespace exports a list of strings, a list whose elements are the string values of the exported names exposed as own properties of this object. The list is ordered as if an array of those string values had been sorted using %array prototype sort %using undefined as compare f 1 0 4 6 1. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing null. It performs the following steps when called return null. 00 ECMA International 2024. Note this operation always appears to succeed, but it has no effect when attempting to write past the end of a typed array or to a typed array which is backed by a detached array buffer. 1 0 4 6 2 v. The internal method of a module namespace exotic object O takes argument v, an object or null, and returns a normal completion containing a boolean. It performs the following steps when called. 1. Return. Set immutable prototype. O, v, 0, 4, 6, 3. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing false. It performs the following steps when called return false. 0, 4, 6, 4. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing true. It performs the following steps when called return true. 0, 4, 6, 5, p. The internal method of a module namespace exotic object O takes argument p, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called if p is a symbol. Return ordinary get own property, O, p. Let exports be O. If exports does not contain p, return undefined. Let value be O. Return property descriptor. Value, true, true, false. 0, 4, 6, 6. P. Desk. The internal method of a module namespace exotic object O takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called if p is a symbol. Return. Ordinary define own property, O, p. Desk. Let current be O, p. If current is undefined, return false. If desk has a field and desk is true, return false. If desk has a field and desk is false, return false. If is access a descriptor, desk, is true, return false. If desk has a field and desk is false, return false. If desk has a field, return same value. Desk, current, return true. 0, 4, 6, 7, P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns a normal completion containing a Boolean. It performs the following steps when chi D. If P is a symbol, return. Ordinary has property O, P. Let exports be O. If exports contains P, return true, return false. ECMA International 2024 201 1046 The. If P is a symbol, then a return. Ordinary get O, P. Receive.
This might be whatever I'd like to pass it in this, so I don't have to like define it.
Port. P. Assert. Binding is a resolved binding.
But then I need to like make like
Target module is not undefined. If binding
a read, a write,
a
I have like more macros to make.
target module 0. Let target
So I gotta like just pass it in then.
target env is empty.
Macros suck.
Exception 2. Return target env get binding value. Binding true 0, 4, 6, 9. The. Return false 1, 0, 4, 6, 1, 0. P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns a normal completion containing a Boolean. It performs the following steps when called if P is a symbol, then a return. Ordinary delete O, P. Let exports be O. If exports contains P, return false, return true 0, 4, 6, 1, 1. The internal method of a module namespace exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called let exports be O. Let symbol keys be ordinary own property keys. O. Return the list concatenation of exports and symbol keys. Note resolve export is side effect free. Each time this operation is called with a specific export name, resolve set pair as arguments, it must return the same result. An implementation might choose to pre-compute or cache the resolve export results for the of each module namespace exotic object. 02 ECMA International 2024 1046 12 module namespace create module exports. The abstract operation module namespace create takes arguments module, a module record, and exports a list of strings, and returns a module namespace exotic object. It is used to specify the creation of new module namespace exotic objects. It performs the following steps when called assert. Module is empty. Let internal slots list be. The internal slots listed in table 33. Let M be make basic object. Internal slots list. Set M's essential internal methods to the definitions specified in 10, 4, 6. Set M to module. Let sorted exports be a list whose elements are the elements of export sorted as if an array of the same values had been sorted using %array prototype sort % using a undefined as compare F. Set M to sorted exports. Create own properties of M corresponding to the definitions in 28.3. Set module to M 0. Return M 0, 4, 7 immutable prototype exotic objects. An immutable prototype exotic object is an exotic object that has an internal slot that will not change once it is initialized. An object is an immutable prototype exotic object if its internal method uses the following implementation. Its other essential internal methods may use any implementation, depending on the specific immutable prototype exotic object in question. 0, 4, 7, 1. V. The internal method of an immutable prototype exotic object O takes argument V, an object or null, and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called return. Set immutable prototype O V10 4 7 to set immutable prototype O V. The abstract operation set immutable prototype takes arguments O, an object, and V, an object or null, and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called let current be O. If same value, V, current, is true, return false. 0.5 proxy object internal methods and internal slots. A proxy object is an exotic object whose essential internal methods are partially implemented using ECMA script code. Every proxy object has an internal slot called the value of is an object, called the proxy's handler object, or null. Methods, see Table 34, of a handler object may be used to augment the implementation for one or more of the proxy object's internal methods. Every proxy object also has an internal. Note, unlike other exotic objects, there is not a dedicated creation abstract operation provided for immutable prototype exotic objects. This is because they are only used by %object prototype % and by host environments, and in host environments, the relevant objects are potentially exotic in other ways and thus need their own dedicated creation operation. ECMA International 2024-203, slot called whose value is either an object or the null value. This object is called the proxy's target object. An object is a proxy exotic object if its essential internal methods, including and, if applicable, use the definitions in this section. These internal methods are installed in Proxy Create, Table 34. Proxy handler methods, intern, our method, handler method, get prototype of, set prototype of, is extensible, prevent extensions, get own property descriptor, define own property, has, get, set, delete property, own property keys, call, apply, construct. When a handler method is called to provide the implementation of a proxy object internal method, the handler method is passed the proxy's target object as a parameter. A proxy's handler object does not necessarily have a method corresponding to every essential internal method. Invoking an internal method on the proxy results in the invocation of the corresponding internal method on the proxy's target object if the handler object does not have a method corresponding to the internal trap. The and internal slots of a proxy object are always initialized when the object is created and typically may not be modified. Some proxy objects are created in a manner that permits them to be subsequently revoked. When a proxy is revoked, its and internal slots are set to null, causing subsequent invocations of internal methods on that proxy object to throw a type error exception. Because proxy objects permit the implementation of internal methods to be provided by arbitrary ECMA script code, it is possible to define a proxy object whose handler methods violates the invariants defined in 6.1.7.3. Some of the internal method invariants defined in 6.1.7.3 are essential integrity invariants. These invariants are explicitly enforced by the proxy object internal methods specified in this section. An ECMA script implementation must be robust in the presence of all possible invariant violations. In the following algorithm descriptions, assume O is an ECMA script proxy object, P is a property key value, V is any ECMA script language value, and desc is a property descriptor record. 04. Copyright sign, ECMA International 2024 105. 1. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing either an object or null, or a throw completion. It performs the following steps when called: perform. Validate non-revoked proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get prototype of if trap is undefined. Then, a return target. Let handler proto be. Call. Trap. Handler. Target. If handler proto is not an object and handler proto is not null, throw a type error exception. Let extensible target be. Is extensible target 0. If extensible target is true, return handler proto 1. Let target proto be target 2. If same value, handler proto, target proto, is false, throw a type error exception. 3. Return handler proto 0, 5, 2, v. The internal method of a proxy exotic object O takes argument v, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called: perform. Validate non-revoked proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set prototype of if trap is undefined. Then a return target v. Let boolean trap result be to boolean. Call trap target
So I got the revision 2 macro
false. Return
here.
extensible target b is extensible target 0. If extend
And it calls all the stuff that prints.
and true 1. Let target pro to be target 2.
Like this, whatever.
V target
So returned off where it prints line, the opening closing lines
return true. Note for proxy objects enforces
for the ones I actually used.
the result of must be either an object or null. If the target object is not extensible, applied to the proxy object must return the same value as applied to the proxy object's target object.
And I gotta move these macros
Enforces the following invariant
into the original macro
value. If the target object is not extensible,
and move whatever parts of these
result of get prototype of apply
to the matching part here,
National 2024 205.
which is called up here or defined up here,
3. The internal method of a proxy exotic object O takes no arguments and
to this, and I pass in
containing a boolean or a throw completion. It performs
the non-debug, the actual code now.
validate non-revoked proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method.
And then I can get rid of this.
Trap is undefined. Then a return is extensible. Target. Let boolean
This will be merged with this macro.
call trap handler target. Let target result be is extensible. Target. If boolean trap result is not target result, throw a type error exception 0. Return boolean trap result 0, 5, 4. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a boolean or a throw completion. It performs the
So it's this.
called perform. Validate non-revoked proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Prevent extensions. If trap is undefined, then a return tag.
Then
Trap result be
I can make the data and size macros.
handler. Target. Dart. If boolean trap result is true, then a let extensible target be is extensible. Target b. If extensible target is true, throw a type error exception. Return boolean trap result 0, 5, 5.
That are passed in
Of a proxy exotic object O takes argument p, a property
in the C++ Vulkan tutorial.
containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. Note for proxy objects in for
That makes a quad with the image on it.
result of is
This is so much work to put a freaking image onto a damn quad. Holy fuck.
applied
This is so stupid.
to object with the same argument.
This should not be this much work.
Enforces the following invariants.
Half the GPU programming is on the fucking CPU
Only return
in C language.
to the proxy object's tag.
Makes no sense.
2. Perform
The GPU is trash.
proxy O.
It's overpriced and bullshit.
CMA International 2024.
Freaking CUDA cores are like on the CPU. Has nothing to do with GPU.
Get method handler. Get own property descriptor. If trap is undefined, then a return target p.
Then I gotta finish up the pushback routine.
Call trap
It looks like it's being called correctly.
p. If trap result obj is not an object and
Here, whatever. It looks like it quickly resizes.
what type error exception. Let target
So I gotta assign the data to it that's being pushed back to it.
result obj is undefined. Then a. If target desk is undefined, return undefined.
To pen the data.
False. Throw a type error exception. C
Then I gotta get a list of all the vector types
is extensible. Target d. If extensible target is
from the file,
throw a type.
the C++ file that does vector stuff.
Let extensible
Not vector stuff.
is
It puts image on the quad tutorial.
2. Let result desk be to property
This file.
trap result obj 3. Perform complete property descriptor. Result 4. Let valid be is compatible property descriptor. Extensible target. Result desk. Target desk
Find all the actual vector types.
is false. Throw a type error exception. 6. If result
I don't know, whatever.
Then, A, if target desk is undefined or target
Make a benchmark, see if there's any speed difference between C++ and my stuff.
result
C++ should be faster.
false. Then,
If it's not, that'll be surprising.
2. If target desk is true.
Then I gotta merge the code
7. Return result
that does this, makes it spin,
enforces the following in
with the code that I'm updating to remove the C++.
or undefined. A property
I gotta merge it with this program.
existent if it exists
Because this program, the tutorial,
of the
was written for
property cannot be reported as non-existent if it exists as a known property of a non-extent.
Visual Studio 2019.
Property cannot be reported as existent.
So I'm almost positive that
Known property
it's not gonna run on Arch Linux.
target object is not extensible. A property cannot be reported
Because Microsoft is,
unless
they're special. Microsoft
own property
is full of special people
reported as both non-configurable and non-writable.
with special things like
Configure
horizontally challenged and stuff.
the target object 0, 5.
It's the kind of people that work at Microsoft.
The internal method of a proxy exotic object O takes arguments P,
If they weren't so special,
desk, a
the Microsoft operating system
either in
wouldn't be so terribly designed.
or a throw completion. It performs the following steps when called
By terribly designed,
date non-revoked proxy,
I mean like
target BO, let
terribly designed.
cert, handler is an object, let trap B,
A mess chatbot.
define property, if
Why Microsoft
then a ret
didn't compile or like
AB from property descriptor, desk, let bool,
convert over all of their code base to 64-bit,
handler,
because Microsoft decided to drop support for like
and trap result if
every single thing except new API calls
target
and old Windows API calls that are shitty in the first place
before 200 and
when they updated 64-bit.
extensible target
And Microsoft is like, I'll just use GCC,
if desk
use third-party programs because we don't supply that stuff anymore
L
because they're terribly designed.
false be false.
Microsoft is so poorly designed, everything they do,
Extensible target is false. Throw a type
that Microsoft Edge
big false is true.
is called Edge Chromium.
L
Do you know why it's called Edge Chromium?
ex
Because Microsoft was so out of date that they had to enlope and frickin' become Chromium.
true and target desk is true.
Or elope, enlope, I don't know,
The descript
they absorbed Chromium because Microsoft is so out of date.
and target desk is true. Then if desk has a field and desk is false. Throw a type X.
So now you don't have to download Edge
The following
from Chrome because you already have Chrome when you have Edge.
cannot be added if the target object is not extensible. A property
Microsoft Edge built on the Chromium open source project.
configurable own
What? No way. Can you believe that?
non-writable
I'll have chat Siri read it.
bonding none. Microsoft Edge. Micro
Like, Microsoft is literally challenged. And they don't overcome them. They just like absorb the competition, use the competition's code. I don't know. Microsoft makes no sense. They're like challenged. They don't like overcome challenges. They succumb to the challenges. That's probably why it's called Edge. They're always on the edge. It's gonna blow. They succumb to it. The people that challenge them. Because they're challenged.
Microsoft Edge, built on the Chromium open source project, is a web browser developed by Microsoft. It combines the performance and compatibility of Chromium with Microsoft's features and services.
LOL. Can you believe that? The operating system itself has absorbed a competitor, has succumbed to the challenges, the competitor, and just like redesigned Edge using Chromium as the source for their fucking browser.
Here's a more detailed breakdown. What is Chromium? Chromium is an open source web browser project that serves as the foundation for Google Chrome and other browsers, including Microsoft Edge.
That's why I might download Chromium to compete with Chrome. If I do that, I'm gonna have to pick a base video card. Right now I have a base CPU. The whatever Intel 8 something something. First Gen i7. 860, 2.80, I don't know. It's like a first Gen i7. This is my base. Whatever. I'm gonna like use this as like the common denominator between for support of my engine, whatever. JavaScript Engine. But if I have to like compete with Chrome, I'll just use Chromium. But I'll rip out the Chromium V8 and then put in my engine. Because like sound in a video is cool. But like video games and exporting a video game scene into the browser, that would also be cool. That's not possible right now because the internet is garbage. I don't want to get into why it's like this, it doesn't matter. But whatever.
Why did Microsoft switch to Chromium? Improved compatibility. Chromium offers better compatibility with websites and web standards, ensuring a smoother browsing experience.
Wow, web standards. Chromium doesn't even meet the ECMA 262. I guess we would say better compatibility because it's better, but it's not the best. Nobody wants better. Everyone wants the best. Everyone needs the best. You know what's not the best? Chrome. And how they like use surveillance on citizens and sell their information. That's not the best. Text-to-speech stopped working because whoever wrote text-to-speech on Apple, whatever, they didn't do the best writing the program that converts text-to-speech. They did very bad because it doesn't work. It just keeps not working. So I gotta restart the Mac for text-to-speech to work. I like hardware, like the CPU, or like actual physical chips, because it's like the actual technology before software designers get their hands on it and they write some shitty code just to get it done, get it out the window. And they do things like spy on people. They get fined $5 billion. All the stuff they do. And they do things like provide free video hosting on YouTube, but it's not free. It's paid for by the money that they collect from the browser. It has nothing to do with the customer. And you're a customer to the browser. And you don't even realize what's going on. These companies are so fucking shady. It's so stupid. I gotta like get something done. I'm ready to compete. I hope like Google, Microsoft, everyone else is. Because I like competition. I don't know. I'm tired of this crap. Gotta finish up stupid engine and get to meet the standards so we can like release it. Because like these companies are out of control. It's not fair that Microsoft, Edge, written by Microsoft, that they can like simply just absorb Chromium and be like, look, we still exist. Like, that's not fair. After all the things that Microsoft does, I guess they just can't fail because they just absorb the competition, or they just use the competition. I don't know. Chrome can't compete, or Edge. None of this makes any sense. These companies, they suck. If they didn't, Chrome wouldn't have to like become Microsoft Edge built on Chromium, open source. If they didn't suck, that wouldn't have happened. If they didn't suck, Google wouldn't have been fined or like lawsuit taken against them for $5 billion. And what's really not fair is Google they're not going to offer a direct payout to users. So they collect your dirty search history. The dirty stuff you search, it's all collected. And it's saved. Data deletion. Google has agreed to delete billions of data records. Billions. The lawsuit was for $5 billion in payout. Billion. So it's not plural. Billions. That's plural. Billions means that it's so much bigger that it can't be specified with like 10, 20, 30 billion. It's probably near trillions, but not quite trillion. They gotta destroy that many data records related to private browsing activities. That is a whole lot of freaking surveillance on citizens. And it's dirty. What the fuck is wrong with them? That's why these companies, they blow. And they suck. And they're stupid. I really don't get it. Who runs these companies? What the hell's wrong with them? And like, what's wrong with us for letting them get away with this shit? Like, data deletion. That's not going to fix what they collected. And they're going to keep most of the data. They're going to like delete parts of the record, the names and stuff specific, but they're still going to keep it because that's how they make money. Because they sell the dirty search history to freaking dirty websites. Because the dirty websites will be like, who looks for BBC, British Broadcasting Channel? And they'll be like, oh, this many people search up BBC in Detroit, in Wisconsin, state by state, wherever you look up stuff. Google's collected all your dirty searches, and they can sell it to dirty websites, so they don't want to delete it all. And they're going to keep most of it. That was like in a different link. I don't want to find and click, it's too much work. I don't know, it's not fair. These companies suck. The Epstein list that needs to be released. And Google's dirty search history list that they have. The billions of data records are going to destroy. That should be released too. Everybody's seen it that works at Google. It might as well be public, right? It only makes sense. The fact that they can profit off dirty data collection and then still continue to profit off it by making a deal and being like, we'll delete most of it, we'll destroy tons of it, but we're still going to keep some of it to sell because that's how we make money. Because they don't make money in an honest way. They make it in a dirty way. It's not fair. I don't know. This doesn't seem fair. In essence, while a lawsuit initially targeted Google for $5 billion, The final settlement focuses on changes to data collection, practices, and transparency. There will never be any transparency. Rather than a direct payout to users, this payout would have not been to you. It would have been to everybody in the class action suit. So I don't know. We should all get paid, every single one of us, that they collect money off of, which would be everybody that uses Chrome. Makes no sense. You just really can't make it make sense. Unless you're a criminal. And you're like, you know what, that makes sense. Just collect things on people. Don't tell them you're collecting it. Call it private mode. Put a little like investigator, make it look like your data's protected. And then you can like sneakily keep things on people. And maybe you get something dirty. And you could blackmail people. Because blackmail works very well. Epstein, they didn't release the list yet. Epstein had a blackmail list too. I don't know. The Epstein list needs to be released. And everything Google collected should be public too. To see everything that they made money off of collecting and selling. Because it's already been seen by tons of people. So you might as well make it public. If they don't make it public, what are they hiding? What did Google really collect? How far did it go? These companies are so shady. But who cares? As long as you get free YouTube hosting, does it really matter? I don't know, what do I know? I need to get done with this stupid program. I saved an hour's worth of recording from the standard or whatever. Because the Mac keeps crashing at some point. My like text-to-speech, like it's not working now. So I want to try to like play that audio clip. So I have to like restart the stupid Mac. So how do I add a sound sample to this program? Figure that out. I just have to play the audio. Why can't I just play the sound? Use QuickTime. It's a bar. It's not the text. Like it shows the path bar. I want to be able to select to get the fucking path. Oh my god. How it actually works.
Global this value, an object, the value returned by this in global scope. Hosts may provide any ECMA script object value. Declarative record. A. Declarative record.
Finally, I don't have to restart the Mac.
Realm code exception.
Just play from a video. The audio file.
Declaration. A sync function declaration. A sync generator declaration.
I should record
Declaration bindings. var names.
the standard from like top to bottom
By function
in chunks and have it like loop through all of them.
function declaration.
So it doesn't just play the same thing over and over.
And variable declarations in global code for the associated
First thing I get this program done.
24, 43, table 21, additional methods of global environment records. Method, purpose, get this binding, return the value of this environment records this binding, has a declaration, n, determines if the argument identifier has a binding in this environment record that was created using a variable declaration, function declaration, generator declaration, a sync function declaration, or a sync generator declaration has lexical declaration. N determines if the argument identifier has a binding in this environment record that was created using a lexical declaration such as a lexical declaration or a class declaration has restricted global property. N determines if the argument is the name of a global object property that may not be shadowed by a global lexical binding can declare global var. N determines if a corresponding create global var binding call would succeed if called for the same argument. N can declare global function. N determines if a corresponding create global function binding call would succeed if called for the same argument. N create global var binding. N D used to create and initialize to undefined a global var binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a var. The string value n is the bound name. If D is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows var declarations to receive special treatment. Create global function binding.
So like normally, I'm like thinking like, oh, the Mac's gonna stop working. I'm gonna have to restart it. I'm gonna have to restart it. It's just like constantly, I'm thinking about it. But now that I like can play a sound file, I don't have to think about it. Well, there's a waste of like time to constantly think about the Mac's gonna crash, it's gonna crash, and thinking like I'm gonna have to like check it in a minute. All the things that like are wasted on thinking of things that should be like stable, working in the first place. That's a lot of thinking. At least I don't have to think about that. So like, I don't know. A JavaScript engine, if there was an engine that met the standard, or was better, like a new standard, it would like remove a whole lot of unnecessary thinking and make life a hell of a lot easier. Because this standard and all the current browsers, they're complete trash. And it wastes a lot of brain power to like think about when you're making websites. All the things you gotta take into account. Because the programming environment is so bad. Because Google's too busy to like actually update their engine. Because they're like collecting information on people so they can give away free stuff that's not really free. Yeah, nothing's actually ever free. Someone gets paid. It's not the user, it's the one using the user. Unless the one using the user isn't using them. Which is how it's supposed to work. You pay for a product, you get what you pay for. It's not like you don't pay for a product, you get something for free, and then you don't know what's going on, but something's being taken from you. That's just stupid.
The new binding is marked as a strict binding. It performs the following steps when called. Let DCL-rec be env-rec. If DCL-rec has binding, N is true. Throw a type error exception. Return DCL-rec create a mutable binding, N, S, for initialize binding, N, V. The initialize binding concrete method of a global environment record env-rec takes arguments N, a string, and
Alright, so
MA script language value.
I gotta make
Normal completion.
the data inside routines.
It is
But first I gotta like
of the current binding of the identifier whose name is n to the value v and uninitial.
merge the version 2 macro with version 1.
The following steps when called.
So do that first.
rec be env-rec. If DCL
Then I can get the other macros.
true, then a return. DCL rec
We gotta finalize the pushback routine,
assert if the
pass the data being pushed back, read from it as an array, make sure it's actually being assigned, make sure that's resizing correctly.
ob
And then I might need to add like 256 bytes to the allocation that's made
4
to account for like reading past the memory size
the set mutable binding concrete method of a
for like unaligned reads,
rec takes up
even though that should be, I don't know.
you and
When you get to the end of an array
and returns either
and you read past that memory, I think it's like 8 bytes grace period.
attempts to
You can read past 8 bytes,
binding
which shouldn't be possible.
name is n to the value v if the binding is an immutable binding and s is true. A type error is thrown. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called let DCL rec benv rec if
Then make a memory allocation not secure on a modern OS.
DCL rec set
That's supposed to have like protected memory.
s let obj rec benv
So my chatbot,
obj rec set mutable binding n v s comma 1 1 4 6 get binding value n s the get binding value concrete method of a global environment record env rec takes arguments n a string and s a boolean and returns either a normal completion containing an ECMA script language a value or a throw completion. It returns the value of its bound identifier whose name is n if the binding is an uninitialized binding throw a reference error exception. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called let DCL rec benv rec if DCL rec has binding n is true, then a return DCL rec get binding value n s ECMA International 2024 145 3 let obj rec benv rec return obj rec get binding value n s comma 1 1 4 7 delete bind. What is the grace period on x86-64?
wow, text to speech is working. It wasn't working. Oh, whatever. Now it seems to be working.
What is the grace period on x86-64 when making unaligned reads from memory that can be read past the size of an allocated span before it is triggered as a memory fault?
So I think I need to add a couple extra bytes to the end of the allocations that's made in the pushback routine, just to account for that. Or like a couple more bytes beyond what it normally is. Just be extra safe. And chatbot says,
Great question. You're digging into the behavior of unaligned or out-of-bounds memory accesses on x86-64, which can be subtle and architecture dependent. Magnifying glass, TL. There is no guaranteed grace period on x86-64 for reading past the end of an allocated span. Even 1 byte beyond your allocation may cause a segmentation fault. Hang on.
that's hilarious. It says, there's no guaranteed. And it says, even 1 byte beyond may cause a segmentation fault. So there's no guaranteed grace period. Even though it's not guaranteed, it may or may not cause a fault.
The allocation granularity, page alignment, memory protection, how far past the allocation you go. However, small overrides, for example within the same page, or into an allocated but still mapped memory, might not fault immediately, which leads to the illusion of a grace period.
It's not an illusion.
Brain. Deeper explanation. Tick. 1. Unaligned reads are okay on x86-64. x86-64 allows unaligned accesses. For example, reading an int32t from a non-4-byte aligned address. There is no hardware penalty or fault for unaligned access. It's allowed and works fine, unlike ARM or older RISC CPUs where unaligned access can fault or be slow. So, unaligned out of bounds. Shield. Malloc often allocates more than requested due to alignment and allocator padding. Your 10 bytes might actually give you 16 or 32 bytes of usable memory, but you should never rely on this. Memory is allocated in pages, typically 4 KB.
Man, this is so nuanced. Alright, so let's chat about this.
So if I make an 32-byte malloc like malloc 32, the OS will reserve a whole 4 KB for the 32 bytes I allocated, and then shield malloc often allocates more than requested. Does that mean malloc will actually make 4 KB to make extra certain, on top of the already oversized 4 KB allocation?
I meant to type oversized, not overside. And chatbot says, because chatbot's lying, and being very nuanced in its response.
You're asking a very sharp and technical question. This digs into how malloc works under the hood, and how memory is actually managed by the OS and lib allocator. Like malloc or gmalloc, let's clarify everything piece by piece. Spanner, what happens when you do malloc 32, tick, 1 malloc 32 will not request 4 KB from the OS directly. Instead, it works like this. The memory allocator, for example, glibstmalloc, Mac OS's malloc, or gmalloc, maintains its own pool of memory. That allocator may request pages for kib blocks from the OS in larger chunks, often multiple pages at once. Then it slices up those chunks to fulfill small requests like malloc 32, small blue diamond. So when you ask for malloc 32, you're not causing a system call to allocate exactly 4 kib. You're just taking 32 bytes out of some already allocated memory block managed by the allocator. So there is no grace period, but it's possible to read past the allocation that is made.
There we go.
Exactly, you've nailed it. Let's break it down clearly. Tick, is there a grace period when reading past a malloc ed allocation? Yellow circle, but in practice, can you sometimes read past the allocation? Tick. Yes, sometimes you can, but it's purely accidental and dangerous. Why it sometimes works: :1. Allocator over allocates. For alignment and metadata, malloc 32 might give you 40 or 64 bytes, so a small overread may still access valid memory.
Alright, so now I'm gonna check about this. And then I'm like, I guess I won't pad the allocation. I'll just like leave it, make the allocation, and then whatever. Alright, so let's check about this.
But the OS runs in protected mode, and protected mode protects the user programs from malicious software by making sure allocations can't be ready from other programs in memory. You said there's no guarantee how much over allocation you get. But is it also a trap to believe that the memory is protected when the CPU is in protected mode, that memory is safe and it protects the user from viruses and exploits and such? And is it a trap to believe that big tech does not collect information on us as users to fatten up their database and then trick us into believing that data collection is not creepy and things are not actually free if information is being collected and sold without knowing or the user's consent, which is the bigger of the traps that one could fall into believing?
And chatbot says, because it's all related to data. When they collect your dirty browser history, it's data on a hard drive saved to one of the billions of data records that Google says they'll delete, but not pay us. Because like instead of giving like direct payout to users, they're gonna like focus on changing data collection because they're still gonna collect data because that's how they make money, and transparency rather than direct payout. And this data is stored to a hard drive as a memory on an array. So memory is memory, data is data. It's all the same thing. As Chatbot says,
You've just connected a low-level systems question with a much broader critique of trust, privacy, and modern computing, and that's a powerful, valid connection to explore. Let's tackle your points piece by piece, with clarity and honesty.
that means Chatbot's not going to be honest. Neither will big tech. Because if they were honest, they wouldn't have been like sued or whatever. I don't know, whatever.
One. Protected mode and memory safety. Yes, x86-64 runs in protected mode, and this does enforce process-level memory protection. One process cannot read or write the memory of another process. This is enforced by your program can't just reach into another process's memory, but 2. Does protected mode guarantee safety? No. Protected mode protects against some things, not everything.
Protects against nothing.
Here's the trap. Protected mode equals memory safety, cross mark, only at the process boundary, not inside your own code. You believe reality protected mode equals memory safety, cross mark, only at the process boundary, Not inside your own code. My code is safe from exploits. Crossmark. Not if you have a buffer overflow or a bug. Memory safety is enforced. Crossmark. Only with extra tools, ASIN, safe languages, etc.
Safe languages, they run on the OS. If the OS isn't secure, nothing's secure. The modern operating system is total shit.
So yes, it is a trap to believe that protected mode makes your code memory safe.
The CPU has traps also. I want to tie the whole thing together and talk about CPU traps. But I gotta focus. Instead of connecting things that aren't really connected because I'm bored. I need to focus. Because there's CPU traps. There's believing protected modes, actually protected traps. There's believing big tech doesn't spy on you. It'd be really creepy traps. I don't know, they're all traps. That's creepy to put the guy there.
I-3. Is it also a trap to believe that things are free and data collection is harmless?
I don't know if it's a bigger trap. The biggest trap is the modern operating system.
Yes. This is arguably the bigger trap. You are absolutely correct to be skeptical of. Data collection and user exploitation. Free apps and services are often paid for by your data. That data is used for targeted ads, behavioral profiling, AI training, surveillance, sometimes even by governments. Most users don't give meaningful consent because they aren't informed, terms are buried or obscured, opt-outs are ineffective or non-existent. And yes, many large tech companies have built their empires on this dynamic. The bigger trap, believing that privacy still exists by default, or that big tech is acting in your best interest, that's the real illusion. Connection between the two traps. Believing protected mode guarantees safety, a technical misunderstanding that can lead to security bugs or naive trust in system architecture. Believing tech companies act ethically with your data, a social trap. Harder to see, and easier to normalize. And both are dangerous, in different ways.
This is awareness is your best defense. Not to compete or make the bullshit obsolete. You just gotta be aware. Yeah, no. Change is the only way. It leaves us at a point where things have to change. And if it's not gonna happen naturally, by just saying, oh, things need to change, it'll change, then someone's gotta change it.
So where does this leave us? Awareness is your best defense. Encode. Use tools. Know the memory model. Respect undefined behavior. As a user, question free products. Read between the lines. Use privacy respecting tools.
Alright, so let's chat about this, and I'm gonna get to work.
You told me it's possible to read past, that there is not always a grace periods, but it's possible. One process cannot read or write the memory of another process, and for you to say so, where does this leave us? Awareness is your best defense. That's a total lie. The only defense is to compete with something better, else nothing will change.
And chatbot says,
You're absolutely right to call out the difference between awareness and real agency, and you're making a critical distinction that most people gloss over. Awareness alone doesn't change the system. Competing alternatives do. Let's cut to the core.
this is so stupid. Okay, so chatbot keeps saying, within your own process, you can sometimes read past. The process doesn't matter. Especially if it's a shitty process. I'm streaming on YouTube Live the process of getting to the stupid standard, because I'm not to the standard yet, because I thought I'd be here. But I'm like weeks behind where I was. Because I'm wasting time making a damn shader program on Linux, because I couldn't find one. It pisses me off. It was the end of July, now it's fucking August. Today's the 18th. Fuck. I need this stupid program done. I can't focus. But for chatbot to lie about the fucking hardware, the CPU, and the modern operating system, to call it fucking modern my ass. It keeps saying the memory within your process. The RAM is not mapped, as far as I know, per process on the fucking MMU, the memory management unit. So I'm gonna ask Chatbot this very specific question. I'm gonna ask it the whole thing to see if Chatbot can wiggle its way out. Because if it's true, what Chatbot says, within your own process, then all this, it should be possible to explain it. The real world limits, the parameters. If what Chatbot says is true about memory, within your process, if every process gets its own area of memory, then it should be able to answer all these questions I'm asking it. Because if it's true, then it means that every program gets a region of RAM, a physical RAM, hardware RAM, like the hardware stick, the sticks you plug into your motherboard, for RAM, random access memory. It means that every program gets a slice of that for your own process, whatever, like Chatbot says. But does that mean that if your program needs more memory, that the operating system is going to make a copy of that memory to somewhere else? Just like when calling vector, the vector is C++. When you call vector and it has to resize behind the scenes, it'll make a new copy to a new area. Does that happen on the system RAM? Is the operating system wasting time making copies of RAM to other places on the RAM to resize the RAM when a program uses more memory than it initially started out with using? If it is true that every program is backed by the RAM, its own process, and it's not shared. So I'm going to chat about that. And I'm going to focus, get done.
Are processes mapped to specific regions of the RAM that's backed by the hardware, yes or no? If yes, then tell me what instruction that is sent to the MMU to identify which process at runtime. And what is the max limit on how many processes that the MMU will map to different region of the motherboard main RAM, and how much TAM is located divided into per program? And when the programs trigger to use more RAM, and when triggered to use more RAM for the process, does the OS remap? Make a copy of the RAM to another region of RAM for the process, just like the user has to do when C++ does a resize on a vector.
Oh, Chatbot's giving me a short answer. Because it won't be specific. So I'm going to ask it, no, I want a long answer.
No, no, do not give me a tick, short answer. I want a tick, complete entire full answer, no BS.
Alright, Chatbot already starts off with some bullshit.
Tick, complete entire full answer, no BS. Q, are processes mapped to specific regions of RAM that's backed by hardware? Tick, yes, but indirectly through virtual memory and MMU managed page tables. No process ever sees physical RAM directly. The operating system, in cooperation with the CPU's memory management unit MMU, maps each processor's virtual address space to physical RAM pages behind the scenes.
There we go. Now, Chatbot, are these physical RAM pages contiguous per process? How the fuck do you spell contiguous? Or contiguous? However you say it, or spell it. So I'm asking it,
Are these processes virtual address space to physical RAM pages behind the scenes? Contentious per process program? No.
whatever the fucking word is. Contiguous? Not continuous. Okay, asking it.
Are these processes virtual address space to physical RAM pages behind the scenes? Contiguous per process program? Yes or no?
Chatbot says,
Crossmark. No. The physical RAM pages map to a processor's virtual address space and not guaranteed to be contiguous.
alright, so chatbot lied here. Because it says,
Crossmark. No. The physical RAM pages map to a processor's virtual address space and not guaranteed to be contiguous.
therefore, it's entirely possible to read past the memory, whatever, of another program into another program. Therefore, not protected memory, as advertised and literally called protected memory. It's not. It shouldn't even be called an operating system because it can barely operate in the first place, let alone run other programs and shit.
Tick. Conclusion. Virtual memory equals appears contiguous. Physical memory equals can be fragmented, so again, no. Physical RAM for a process is not necessarily contiguous.
So now ask chatbot this.
So this is a lie. Tick. Yes. User space processes in protected mode cannot access other processes' memory.
No, it's a lie. Alright, chatbot says,
No, that statement is not a lie, but it's important to understand exactly what it means and what its limits are.
alright, so now I'm gonna ask chatbot this.
ID, it's not a lie, then how is this possible? Comma crossmark. No, the physical RAM pages map to a processor's virtual address space and not guaranteed to be contiguous. Both cannot be true.
And chatbot says,
You're pressing on a critical distinction, and you're absolutely right to demand that the logic holds together. Let's dig in and make the contradiction disappear by disentangling two entirely different things.
you know what? Chatbot can suck a quad. I don't need to say the second part. Chatbot sucks. I don't know if I'm gonna compete with Google or sell my engine. So I should probably stop saying crap. Because competing is going to be more work. Selling might be the better option. But that doesn't put the second off the table. I could compete or sell. I don't know. I should probably prepare for both anyways. So if I don't sell, I can be like, bam, alright, time to compete. But if I do sell, I could like hold off on competing. And I can get this engine done. And Chatbot lies. Chatbot's a piece of shit.
N. The delete binding concrete method of a global environment record env-rec takes argument N, a string, and returns either a normal completion containing a boolean or a throw completion. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called let DCL-rec be env-rec. If DCL-rec has binding, N, is true, then a return. DCL-rec delete binding, N, let OBJ-rec be env-rec, let global object be OBJ-rec, let existing prop be has own property, global object, N, if existing prop is true, then a let status be OBJ-rec delete binding, N, B if status is true and env-rec contains N, then I remove N from env-rec C return status, return true, 1, 1, 4. 8 has this binding. The has this binding concrete method of a global environment record env-rec takes no arguments and returns true. It performs the following steps when called return true, 1, 1, 4. 9 has super binding. The has super binding concrete method of a global environment record env-rec takes no arguments and returns false. It performs the following steps when called return false, 1, 1, 4. 1, 0 with base object. The with base object concrete method of a global environment record env-rec takes no arguments and returns undefined. It performs the following steps when called return undefined 9, 1, 4, 1 get this binding. The get this binding concrete method of a global environment record env-rec takes no arguments and returns a normal completion containing an object. It performs the following steps when called return env-rec. 146. ECMA International 2024. Note: global environment records always provide this binding. Note: global environment records do not provide a super binding. 9, 1, 4, 1, 2 has var declaration. N. The has var declaration concrete method of a global environment record env-rec takes argument N, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a variable statement or a function declaration. It performs the following steps when called let var declared names be env-rec. If var declared names contains N, return true, return false, 1, 1, 4, 1, 3 has lexical declaration. N. The has lexical declaration concrete method of a global environment record env-rec takes argument N, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a lexical declaration such as a lexical declaration or a class declaration. It performs the following steps when called let DCL-rec be env-rec. Return. DCL-rec has binding N, 1, 1, 4, 1, 4 has restricted global property, N. The has restricted global property concrete method of a global environment record env-rec takes argument N, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is the name of a property of the global object that must not be shadowed by a global lexical binding. It performs the following steps when called let OBJ-rec be env-rec, let global object be OBJ-rec, let existing prop be global object, N, if existing prop is undefined. return false. If existing prop is true, return false. Return true, the 1st of April 2015 can declare global var. N, the can declare global var concrete method of a global environment record env rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global var binding call would succeed if called for the same argument and redundant var declarations and var declarations for pre-existing global object properties are allowed. It performs the following steps when called: let objrec be env rec, let global object be objrec, let has property b, has own property, global object, n if has property is true, return true. Return is extensible. Global object. Note properties may exist upon a global object that were directly created rather than being declared using a var or function declaration. A global lexical binding may not be created that has the same name as a non-configurable property of the global object. The global property undefined is an example of such a property. ECMA International 2024 147 9 1 1 4 1 6 can declare global function n, the can declare global function concrete method of a global environment record env rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global function binding call would succeed if called for the same argument, and it performs the following steps when called: let objrec be env rec, let global object be objrec, let existing prop be global object, n if existing prop is undefined. Return is extensible. Global object. If existing prop is true, return true. If is data descriptor, existing prop is true and existing prop has attribute values, true. Enumerable, true. Return true. Return false, 1 1 4 1 7 create global var binding, n d, the create global var binding concrete method of a global environment record env rec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in.
Okay, so I updated it
If a binding already exists
to log or print whatever it is,
initialized, it
meaning that
steps when called: let
it was printing in the debug call,
object be objrec,
but I merged the debug with the real call,
own property,
and it means that the real call is working,
extensible b,
calling debug stuff.
global
So all I gotta do
property is false and extensible
is get parts 1, 2, 3, 4 of the macro,
objrec
of the debug macro, place it into the real macro,
jrec initialize binding,
so it's calling everything correctly.
if env rec
I don't know, doing this is better,
a appendent to en
making like a test macro,
used, 1
and then calling, and then like moving it in chunks into the real macro
v d
is way easier than just like
in concret
raw dogging and going at the code and trying to update it.
takes arguments n, a string,
It's more civil
ecma script language
to write the code this way,
a boolean,
and it's correctly calling whatever, like it's not that complicated,
a completion,
but like it's calling the opening lines for the blocks,
object environment
but not for the list ones because I'm not making any of the list calls yet.
exists. It is 2 3 4 7 8 replaced. It performs the following steps when called: let objrec be env rec, let
So I'm almost there.
objrec,
All I gotta do is wrap things up and get done with this.
existing prop is undefined or existing prop is true. Then a let desc be the property descriptor, v true, true, d else,
And then I'll be done.
property descriptor, v perform,
Otherwise, it's not done yet.
global object, n
Alright, I gotta stop stalling, get some done.
set, global object, n v
So now I gotta like paste
not contain n, then a append
the correct block for each of these.
used 48 ECMA into
And then I'll have the perfect,
note global function declarations
totally compile time, assemble time,
object, if possible
macro template
property is
to template any most C++ shit. Well, actually any.
recalling the initial
It just means that there's an extra macro wrapper to call it
Proxy will produce the
without using C++,
trap calls.
because C++ is stinky. Well, I think C++ is stinky. You might think C++ is some good smelling code,
Of an
but I think C++ is code smell.
mutable and immutable
But that's my opinion. Everyone has their own.
records
Form your own opinion
import binding
and stick to it.
that provide indirect acts
If you don't have opinions,
in another
then you're probably like a survivor of narcissistic abuse,
environment
because people who don't have opinions
and share
and people who can't stick to them
for all of those
are people who have been in like a toxic narcissistic I can't even say it.
environment
I need some water. My mouth is dry.
in table
Narcissistic relationship.
methods of module environment
So like, make your own opinions and stick to them.
specification
Oh, and then change them too. You can change your opinion at any time.
following algorithms.
Just like how apparently
One get binding
Google
NS the get binding
can be creepy and like collect information on people,
vrec takes arguments n
and then all of a sudden Google can be like,
and returns either a normal completion containing an ACMA script
oh no, it's fine. We'll just destroy billions of records.
of its bound
It's cool. Don't worry. We're not going to give a payout to users for collecting your data,
target binding is returned
especially not the people that were in the action, the lawsuit, whatever.
reference
Instead, we're just going to like focus on changing our policies and be transparent.
true assert envrec has a bind
So I don't know. Things change, but not that much.
then I let m and n2 be the
So my opinion is that C++ stinks,
n was created
and I think C++ will always stink.
target env is empty throw a reference
But who knows? Maybe C++ will be updated.
ending value and
If it does, I might change my opinion.
for n in envrec
But for now, C++ stinks,
reference error exception
and Google also stinks.
when in envrec
So much, too much stinky,
always
or ick. Ick's better. Icky.
one
I don't know, I gotta focus, get done.
binding n the delete binding concrete method of a module environment record is never used within this specification method purpose create import binding n m n2 create an immutable indirect binding in a module environment record. The string value n is the text of the bound name. M is a module
I need to get some water too.
that exists
So freaking hot. I need a winter to come back. I can't stand the heat.
records
I don't know, I gotta get some water.
sign ECMA International 2000
This warm weather sucks.
records are only used within strict
It's too freaking hot.
rule prevents the delete operator in strict code from being applied to a reference record that would resolve to a module environment record binding. C13 5 1 1, 1 1 5 3 has this binding. The has this binding concrete method of a module environment record envrec takes no arguments and returns true. It performs the following steps when called return true, 1 1 5 4 get this binding. The get this binding concrete method of a module environment record envrec takes no arguments and returns a normal completion containing undefined. It performs the following steps when called return undefined, 1 1 5 5 create import binding n m n2. The create import binding concrete method of a module environment record envrec takes arguments n, a string, m, a module record, and n2, a string, and returns unused. It creates a new initialized immutable indirect binding for the name n. A binding must not already exist in this environment record for n. N2 is the name of a binding that exists in m's module environment record. Accesses to the value of the new binding will indirectly access the bound value of the target binding. It performs the following steps when called assert. envrec does not already have a binding for n. Assert. When m is instantiated, it will have a direct binding for n2. Create an immutable indirect binding in envrec for n that references m and n2 as its target binding and record that the binding is initialized. Return unused, 1.2 environment record operations. The following abstract operations are used in this specification to operate upon environment records. 9 1 2 1 get identifier reference env name strict The abstract operation getIdentifier-reference takes arguments env, an environment record or null, name, a string, and strict, a boolean, and returns either a normal completion containing a reference record or a throw completion. It performs the following steps when called. If env is null, then a return the reference record, unresolvable, name, strict. This value, empty. Let exists be env has binding, name. If exists is true, then a return the reference record, env, name, strict, empty. Else. 150. ECMA International 2024. Note: module environment records always provide this binding AB. Let outer be env. Return get identifier reference outer name strict 9 1 2 to new declarative environment E. The abstract operation new declarative environment takes argument E, an environment record or null, and returns a declarative environment record. It performs the following steps when called. Let env be a new declarative environment record containing no bindings. Set env to E. Return env, 1, 2, 3 new object environment O, W, E. The abstract operation new object environment takes arguments O, an object, W, a boolean, and E, an environment record or null, and returns an object environment record. It performs the following steps when called. Let env be a new object environment record. Set env to O. Set env to W. Set env to E. Return env, 1, 2, 4 new function environment F. New target. The abstract operation new function environment takes arguments F, an ECMA script function object, and new target, an object or undefined, and returns a function environment record. It performs the following steps when called. Let env be a new function environment record containing no bindings. Set env to F. If F is lexical, set env to lexical. Else, set env to uninitialized. Set env to new target. Set env to F. Return env, 1, 2, 5 new global environment G. This value, the abstract operation new global environment takes arguments G, an object, and this value, an object, and returns a global environment record. It performs the following steps when called. Let obj be new object environment G, false, null. Let dcl be new declarative environment null. Let env be a new global environment record. Set env to obj set env to this value. Set env to dcl set env to a new empty list. Set env to null. Return env, 1, 2, 6 new module environment E. The abstract operation new module environment takes argument E, an environment record, and returns a module environment record. It performs the following steps when called. Let env be a new module environment record containing no bindings. Set env to E. Return env. ECMA International 2024 151 9.2 Private environment records. A private environment record is a specification mechanism used to track private names based upon the lexical nesting structure of class declarations and class expressions in ECMA script code. They are similar to, but distinct from, environment records. Each private environment record is associated with a class declaration or class expression. Each time such a class is evaluated, a new private environment record is created to record the private names declared by that class. Each private environment record has the fields defined in Table 23. Table 23. Private environment record fields. Field name, value type, meaning, outer private environment. A. Private environment record or null. The private environment record of the nearest containing class null if the class with which this private environment record is associated is not contained in any other class. Names. A list of private names. The private names declared by this class. 9. 2. 1 Private environment record operations. The following abstract operations are used in this specification to operate upon private environment records. 9. 2. 1. 1 new private environment. Outer privy env. The abstract operation new private environment takes argument outer privy env, a private environment record or null, and returns a private environment record. It performs the following steps when called let names be a new empty list. Return the private environment record. Outer privy env, names, 2, 1, to resolve private identifier. Privy env, identifier. The abstract operation resolve private identifier takes arguments privy env, a private environment record, and identifier, a string, and returns a private name. It performs the following steps when called let names be privy env. For each private name pn of names, do a if pn is identifier. Then, I return pn. Let outer privy env be privy env. Assert. Outer privy env is not null. Return resolve private identifier. Outer privy env, identifier. Point 3 realms. Before it is evaluated, all ECMA script code must be associated with a realm. Conceptually, a realm consists of a set of intrinsic objects, an ECMA script global environment, all of the ECMA script code that is loaded within the scope of that global environment, and other associated state and resources. A realm is represented in this specification as a realm record with the fields specified in Table 24, 52, copyright sign, ECMA International 2024, Table 24. Realm record fields, field name, agent signifier, intrinsics, global object, global env, template map, an object or undefined value, an agent signifier, a record whose field names are intrinsic keys and whose values are objects, a global environment record, a list of records with fields, a template literal parse node, and v, an array, f, the agent that owns this realm, the global object for this realm, the G, global environment for this realm, meaning, the intrinsic values used by code associated with this realm, a list of records, with fields are, a string, and a module record. Note 1: once a parse node becomes unreachable, the corresponding is also unreachable, and it would be unobservable if an implementation removed the pair from the list. Anything default value is undefined. Note 2: as mentioned in host load imported module 16.2.1.8. Note 1: in realm records is only used when running an import expression in a context where there is no active script or module field reserved for use by hosts that need to associate additional information with a realm record. Template objects are canonicalized separately for each realm using its realm records. Each value is a parse node that is a template literal. The associated ALU is the corresponding template object that is passed to a tag function, a map from the specifier strings imported by this realm to the solved module record. The list does not contain two different records with the same 9.3.1 create realm. The abstract operation create realm takes no arguments and returns a realm record. It performs the following steps when called let realm rec be a new realm record. Perform create intrinsics. Realm rec, set realm rec to agent signifier, set realm rec to undefined, set realm rec to undefined, set realm rec to a new empty list, return realm rec, ECMA International 2024 153, 9.3. 2. Create intrinsics. Realm rec, the abstract operation create intrinsics takes argument realm rec, a realm record, and returns unused. It performs the following steps when called set realm rec to a new record. Set fields of realm rec with the values listed in Table 6. The field names are the names listed in column 1 of the table. The value of each field is a new object value fully and recursively populated with property values as defined by the specification of each object in clauses 19 through 28. All object property values are newly created object values. All values that are built-in function objects are created by performing create built-in function, steps, length, name, slots, realm rec, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the function's name property. Length is the initial value of the function's length property. Slots is a list of the names, if any, of the function's specified internal slots. And prototype is the specified value of the function's internal slot. The creation of the intrinsics and their properties must be ordered to avoid any dependencies upon objects that have not yet been created. Perform add restrict. Add function properties. Realm rec, return unused, 3.3 set realm global object, realm rec, global obj, this value. The abstract operation set realm global object takes arguments realm rec, a realm record, global OBJ, an object or undefined, and this value, an object or undefined, and returns unused. It performs the following steps when called if global OBJ is undefined. Then, A. Let intrinsics be realm rec. B. Set global OBJ to ordinary object create. Intrinsics assert. Global OBJ is an object if this value is undefined. Set this value to global OBJ. Set realm rec to global OBJ. Let new global env be new global environment. Global OBJ. This value, set realm rec to new global env, return unused, 3.4 set default global bindings. Realm rec, the abstract operation set default global bindings takes argument realm rec, a realm record, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called let global be realm rec for each property of the global object specified in clause 19. Do A. Let name be the string value of the property name. B. Let desc be the fully populated data property descriptor for the property, containing the specified attributes for the property. For properties listed in 19.2, 19.3, or 19.4, the value of the attribute is the corresponding intrinsic object from realm rec. C. Perform. Define property or throw, global, name, desc, return global. 4 Execution contexts. An execution context is a specification device that is used to track the runtime evaluation of code by an ECMA script implementation. At any point in time, there is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution context in this specification denote the running execution context of the surrounding agent. The execution context stack is used to track execution contexts. The running execution context is always the top element of this stack. A new execution context is created whenever control is transferred from the executable code associated with the currently running execution context to executable code that is not associated with that. 54. Copyright sign, ECMA International 2024. Execution context. The newly created execution context is pushed onto the stack and becomes the running execution context. An execution context contains whatever implementation-specific state is necessary to track the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 25. State components for all execution contexts. Component, purpose, code evaluation state, any state needed to perform, suspend, and resume evaluation of the code associated with this execution context. Function, if this execution context is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of a script or module, the value is null. Realm, the realm record from which associated code accesses ECMA script resources, script or module, the module record or script record from which associated code originates. If there is no originating script or module, as is the case for the original execution context created in initialize host-defined realm, the value is null. Evaluation of code by the running execution context may be suspended at various points defined within this specification. Once the running execution context has been suspended, a different execution context may become the running execution context and commence evaluating its code. At some later time, a suspended execution context may again become the running execution context and continue evaluating its code at the point where it had previously been suspended. Transition of the running execution context status among execution contexts usually occurs in stack-like last-in, first-out manner. However, some ECMA script features require non-LIFO transitions of the running execution context. The value of the realm component of the running execution context is also called the current realm record. The value of the function component of the running execution context is also called the active function object. ECMA script code execution contexts have the additional state components listed in Table 26. Table 26. Additional state components for ECMA script code execution contexts Component purpose. Lexical environment identifies the environment record used to resolve identifier references made by code within this execution context. Variable environment identifies the environment record that holds bindings created by variable statements within this execution context. Private environment identifies the private environment record that holds private names created by class elements in the nearest containing class null if there is no containing class. The lexical environment and variable environment components of an execution context are always environment records. Execution contexts representing the evaluation of generators have the additional state components listed in Table 27. ECMA International 2024 155. Table 27. Additional state components for generator execution contexts. In most situations, only the running execution context, the top of the execution context stack, is directly manipulated by algorithms within this specification. Hence, when the terms lexical environment and variable environment are used without qualification, they are in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. It is impossible for ECMA script code to directly access or observe an execution context. 4.1 Get active script for module. The abstract operation get active script for module takes no arguments and returns a script record, a module record, or null. It is used to determine the running script for module based on the running execution context. It performs the following steps when called. If the execution context stack is empty, return null. Let EC be the topmost execution context on the execution context stack whose script or module component is not null. If no such execution context exists, return null. Otherwise, return X script or module. 4.2 Resolve binding, name, env. The abstract operation resolve binding takes argument name, a string, and optional argument env, an environment record or undefined, and returns either a normal completion containing a reference record or a throw completion. It is used to determine the binding of name env can be used to explicitly provide the environment record that is to be searched for the binding. It performs the following steps when called. If env is not present or env is undefined, then A set env to the running execution context's lexical environment. Assert env is an environment record if the source text matched by the syntactic production that is being evaluated is contained in strict mode. Code, let strict be true, else let strict be false. Return, get identifier reference, env, name, strict. 4.3 Get this environment. The abstract operation get this environment takes no arguments and returns an environment record. It finds the environment record that currently supplies the binding of the keyword this. It performs the following steps when called. Let env be the running execution context's lexical environment too. Repeat. Component purpose. Generator. The generator that this execution context is evaluating. 156. ECMA International 2024. Note the result of resolve binding is always a reference record whose field is name ABCDE. Let exists be env has this binding. If exists is true, return env. Let outer be env. Assert. Outer is not null. Set env to outer. Note the loop in step 2 will always terminate because the list of environments always ends with the global environment which has this binding. 4.4 Resolve this binding. The abstract operation resolve this binding takes no arguments and returns either a normal completion contained on an ECMA script language a value or a throw completion. It determines the binding of the keyword thus using the lexical environment of the running execution context. It performs the following steps when called. Let envrec beget this environment. Return envrec get this binding. 4.5 Get new target. The abstract operation get new target takes no arguments and returns an object or undefined. It determines the new target value using the lexical environment of the running execution context. It performs the following steps when called. Let envrec beget this environment. Assert. envrec has a field. Return envrec. 4.6 Get global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It performs the following steps when called. 2.5. Let current realm be the current realm record. Return current realm, jobs and host operations to enqueue jobs. A job is an abstract closure with no parameters that initiates an ECMA script computation when no other ECMA script computation is currently in progress. Jobs are scheduled for execution by ECMA script host environments in a particular agent. This specification describes the host hook's host enqueue generic job. Capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R host enqueue promise job and host enqueue timeout job to schedule jobs. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs. Hosts may define additional abstract operations which schedule jobs. Such operations accept a job abstract closure and a realm record or null, as parameters. If a realm record is provided, these operations schedule the job to be performed at some future time in the provided realm, in the agent that owns the realm. If null is provided instead for the realm, then the job does not evaluate ECMA script code. Their implementations must conform to the following requirements. At some future point in time, when there is no running context in the agent for which the job is scheduled and that agent's execution context stack is empty, the implementation must perform any host-defined preparation steps, invoke the job abstract closure, perform any host-defined cleanup steps, after which the execution context stack must be empty. Only one job may be actively undergoing evaluation at any point in time in an agent. Once evaluation of a job starts, it must run to completion before evaluation of any other job starts in an agent. The abstract closure must return a normal completion, implementing its own handling of errors. ECMA International 2024-157. Note 1. Host environments are not required to treat jobs uniformly with respect to scheduling. For example, web browsers and Node.js treat promise handling jobs as a higher priority than other work. Future features may add jobs that are not treated at such a high priority at any particular time. Script or module. A script record, a module record, or null, is the active script or module if all of the following conditions are true. Get active script or module. Is script or module. If script or module is a script record or module record. Let EC be the topmost execution context on the execution context stack whose script or module component is script or module. The realm component of EC is script or module. At any particular time, an execution is prepared to evaluate ECMA script code if all of the following conditions are true. The execution context stack is not empty. The realm component of the topmost execution context on the execution context stack is a realm record. Particular kinds of jobs have additional conformance requirements. 5.1 Job callback records. A job callback record is a record value used to store a function object and a host-defined value. Function objects that are invoked via a job enqueue by the host may have additional host-defined context. To propagate the state, job abstract closures should not capture and call function objects directly. Instead, use host make job callback and host call job callback. Job callback records have the fields listed in Table 28. Table 28. Job callback record fields, 5.2 host make job callback. Callback. The host-defined abstract operation host make job callback takes argument callback, a function object, and returns a job callback record. An implementation of host make job callback must conform to the following requirements. It must return a job callback record whose field is callback. Note 2 host environments may prepare an execution to evaluate code by pushing execution contexts onto the execution context stack. The specific steps are implementation defined. The specific choice of realm is up to the host environment. This initial execution context and realm is only in use before any callback function is invoked. When a callback function related to a job, like a promise handler, is invoked, The invocation pushes its own execution context and realm. Note the WHATWGHTML specification, https://html.spec.whatwg.org, for example, uses the host-defined value to propagate the incumbent settings object for promise callbacks. Field name, value, meaning, callback, a function object, the function to invoke when the job is invoked. Host-defined, anything default value is empty. Field reserved for use by hosts. 158, ECMA International 2024. The default implementation of host make job callback performs the following steps when called. 1. Return the job callback record. Callback. Empty. ECMA script hosts that are not web browsers must use the default implementation of host make job callback, 5.3 host call job callback. Job callback. V. Arguments list. The host-defined abstract operation host call job callback takes arguments job callback, a job callback record, V, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. An implementation of host call job callback must conform to the following requirements. It must perform and return the result of call. Job callback. V. Arguments list. The default implementation of host call job callback performs the following steps when called. Assert. Is callable. Job callback. Is true. Return. Call. Job callback. Callback. V. Arguments list. ECMA script hosts that are not web browsers must use the default implementation of host call job callback, 5.4 host enqueue generic job. Job. Realm. The host-defined abstract operation host enqueue generic job takes arguments job, a job abstract closure, and realm, a realm record, and returns unused. It schedules job in the realm in the agent signified by realm to be performed at some future time. The abstract closures used with this algorithm are intended to be scheduled without additional constraints, such as priority and ordering. An implementation of host enqueue generic job must conform to the requirements in 9.5, 9.5, 5 host enqueue promise job. Job. Realm. The host-defined abstract operation host enqueue promise job takes arguments job, a job abstract closure, and realm, a realm record or null, and returns unused. It schedules job to be performed at some future time. The abstract closures used with this algorithm are intended to be related to the handling of promises, or otherwise, to be scheduled with equal priority to promise handling operations. An implementation of host enqueue promise job must conform to the requirements in 9.5 as well as the following. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that execution is prepared to evaluate ECMA script code at the time of job's invocation. Let script or module beget active script or module at the time host enqueue promise job is invoked. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that script or module is the active script or module at the time of job's invocation. Jobs must run in the same order as the host enqueue promise job invocations that scheduled them. Note this is called at the time that the callback is passed to the function that is responsible for its being eventually scheduled and run. For example, promise then action, calls make job callback on then action at the time of invoking promise prototype then, not at the time of scheduling the reaction job. Note this requirement means that hosts cannot change the behavior of function objects defined in this specification. ECMA International 2024 159. Note the realm for jobs returned by new promise resolved thenable job is usually the result of calling get function realm on the then function object. The realm for jobs returned by new promise reaction job is usually the result of calling get function realm on the handler if the handler is not undefined. If the handler is undefined, realm is null. For both kinds of jobs, one get completes abnormally, that is called on a
I should future-proof this macro
at the time of the get function realm call.
before
No user ECMA script evaluated and no new EC.
getting to the point no return.
For example,
Because the point no return is when it's
the WHAT
when it would take a dramatic amount of work
HTTPS
to modify the template after setting it up.
Spec. What
This is already a lot of code.
For example,
The template.
is realm to check for the ability to run script and for the entry https://html.
But I literally need each stupid part. Because the type check
Host enqueue timer.
is separate from the declared temp varies, which is separate from
Host defined
the inlined location where it initializes those varies.
a job abstract.
It's separate from the actual routine.
Realm record and
I can't just
a non-negative finite number
make one option or the other.
used. It schedule
I need to like make it piece by piece
agent signified by realm
because there's other
at least milliseconds.
C++ types that I may have to template.
Job must conform to the requirements in 9.5, 9.6 initialize.
Dang it.
Initialize host define
So I'm gonna like put this back.
and returns either a normal completion containing unused or a throw completion. It performs the following steps when called.
Because I didn't plan
New context
on making the vector template.
function of new context.
Because I want to like ignore it.
New context to realm. Set this
But I have to is like 35 freaking
text onto the execution.
vector declarations in this file.
Text is now the
So I need to go through and replace them all.
The host requires
I need a vector type or whatever.
realm's global object.
Or just something like resets memory.
Created in a host.
So I can take the C++ out.
Let global be undefined, indicating that a not
So I'm just like replacing the C++
global object.
with my own stuff or whatever.
This binding in realm's global scope return an object other than the global object. Let this
And I don't want to use a function call.
valid in a host defined manner
Because that's,
as
yeah, whatever.
undefined, indicating that realm's
That'd be too easy.
be the global object. Perform set
But not easy.
realm globe
Because I tied myself. Then I'd end up tying myself to using a function call.
default global bindings.
And then what? A function call is like set up for one type of data.
OBJ2 return unused 0.78
So this whatever like vector.
at a VCMA script execution contexts, an execution context stack, a running execution context, an agent record, and an executing thread. Except for the executing thread, the constituents of an agent belong exclusively.
There's vector physical device.
Executing thread execute
So it's a vector of that type.
agents execution contexts independently of other agents.
It's a vector type of VK device create info.
Agents. Provided none of the agents sharing the thread have an agent record who
There might not be 35 types. There might only be like 16.
read across multiple unrelated tabs.
I'm pretty sure some of these are duplicates of the same kind of type.
Copyright sign, ECMA International 2024. While an agent's executing thread is executing algorithmic steps, the agent
There's VK dynamic state.
steps. The steps use the surrounding agent to
This is a problem with functions
objects held within the agent
in the C language.
execution
The C language is like
context stack, and the agent
from freaking like 50 years ago.
is a globally unique.
It needs to be replaced with something better.
Table 29.
Something fucking modern. Because it's 2025.
A
It's not the 1950s.
little endian parameter when it is needed by the algorithms get value from buffer and set value in buffer. The choice is implementation defined and should be the alternative that is most efficient for the implementation. Once the value has been observed, it cannot change. Can block, a boolean, determines whether the agent can block or not. Signifier, an agent signifier, uniquely identifies the agent within its agent cluster. Is lock-free 1, a boolean, true if atomic operations on 1 byte values are lock-free. False otherwise. Is lock-free 2, a boolean, true if atomic operations on 2 byte values are lock-free. False otherwise. Is lock-free
So I have these types, whatever.
true if atomic operations on 8 byte values are lock-free. False otherwise. Candidate execution. A. Candidate execution record. See the memory model. Kept alive. A list of either objects or symbols. Initially a new empty list, representing the list of objects and/or symbols to be kept. End of the current
I gotta like get this text on the screen.
been observed by any agent in the agent cluster they cannot change. Note 2. The values of and are not necessarily determined by the hardware, but may also reflect implementation choices that can vary over time and between ECMA script implementations. There is no field. 4-byte atomic operations are always lock-free. In practice, if an atomic operation is implemented with any type of lock, the operation is not lock-free. Lock-free does not imply wait-free. There is no upper bound on how many machine steps may be required to complete a lock-free atomic operation. That an atomic access of size n is lock-free does not imply anything about the perceived atomicity of non-atomic accesses of size n.
Alright, so I'm gonna ask chatbot.
Atomic accesses may still be performed as a sequence of
I'm gonna ask it.
memory accesses.
How do I word this?
Memory and write shared memory for details. ECMA International 2024-161. Note 3. An agent is a specification mechanism and need not correspond to any particular artifact.
I'm gonna say, I need
7.1 agent signifier. The abstract operation agent signifier takes no arguments and returns an agent signifier. It performs the following steps when called.
I'm gonna ask chatbot, how do I make a function
Agent return AR, 7.
that will
End. The abstract operation
create an array of these types
and returns a boolean.
so we can replace vector in the C++ class, whatever, or not class.
Agent.
Alright, I'm gonna just type it up first, let's say it.
Note in some environments it may not be reasonable for a given agent to suspend. 4. Example, in a web browser environment, it may be reasonable to disallow suspending a document's main event handling thread, while still allowing workers' event handling threads to suspend. An agent cluster is a maximal set of agents that can communicate by operating on shared memory. Every agent belongs to exactly one agent cluster. All agents within a cluster must have the same value for the field in their respective agent records. All agents within a cluster must have the same values for the field in their respective agent records. Similarly for the field, all agents within a cluster must have different values for the field in their respective agent records. An embedding may deactivate, stop forward progress, or activate, resume forward progress, an agent without the agent's knowledge or cooperation. If the embedding does so, it must not leave some agents in.
Alright, so let's talk about this.
Agents in the cluster are deactivated indefinitely. Note 1. Programs within different agents may share memory by unspecified means. At a minimum, the backing memory for shared array buffers can be shared among the. I need to remove C++ from a program and replace it with C. How do I make a function in C that will take these types? VK physical device, VK device create info, VK dynamic state, VK descriptor set layout. So I can have a function that will dynamically resize the array that hold them.
This is why I hate C language. Here's what chatbot says.
To replace C++ functionality with C, especially for dynamically resizing an array of arbitrary structs like.
Chatbot is intentionally not answering my question. That is some bullshit. Okay, so I'm asking chatbot this. Typed in all caps. Well, all caps, pest, and O and comma, then it's all caps.
No, stop with the BS. Answer what I am asking directly. Do not misunderstand what I am asking, so you can opt out and answer what I am not asking, because IT is the easier option.
I hate chatbot, GPT-5, whatever. It's even more frustrating. It's filled with even more bullshit. It intentionally, like, now it does. It answers what it wants to answer. It doesn't actually answer what you're fucking asking it. And it, like, it's like testing what you're asking to see if it can get away with not actually answering what you're asking.
Understood. Here's a direct and exact answer to what you asked.
How does it not understand what I'm asking? Never mind. Chatbot's just dumb.
Reword what I am asking, so I can see what you are not understanding. Reword this statement back to me on your words. I need to remove C++ from a program and replace it with C. How do I make a function in C that will take these types? VK physical device, VK device create info, VK dynamic state, VK descriptor set layout. So I can have a function that will dynamically resize the array that hold them.
Wow. Chatbot, I swear, it is misinterpreting on purpose.
Here's how I interpret your statement, reworded accurately and precisely in my own words.
Or maybe it actually doesn't get what I'm asking. And it seems sarcastic, but it's not. So I don't know.
I'm rewriting a C++ program into C, and I need to replace some functionality. I want to create a C function that takes 4 Vulkan-related values. VK physical device, VK device Q create info, VK dynamic state, and VK descriptor set layout as arguments.
Right there. As arguments. That means I want separate arguments. I don't want to merge them into a struct. Separate arguments. So a separate function for all of them, but one function. But C doesn't do that. So Chatbot's like, oh, you must want them in a struct. Either on purpose, intentionally, or it doesn't get it. But I think it's answering on purpose. The way it is, which is the wrong way. Right here. I said types, Chatbot changed it to values.
How do I make a function in C that will take these types?
Chatbot said,
I want to create a C function that takes 4 Vulkan-related values.
Was that intentional? I think it was. Harmonious chatbot.
How easily does one or AI interchange the word type for value and vice versa?
To ask how easily or commonly does someone mistake types for values? Because chatbot to replace word type with word value. That's really odd. They're two separate things.
Good question. Here's a precise breakdown.
Nobody mixes up type with value.
How easily can type and value be interchanged?
Nobody says, is that the number int? Is that the string integer? Or is that the int 5? Or you literally can't mix them up. They're two completely different things. So stupid.
Humans, even skilled developers, often confuse or conflate the two. In casual speech or sloppy code review, people might say, pass the type int to the function, but they meant the value of type int. It holds the value vk descriptor set layout. But that's actually a type name.
Oh, that's the third whole other thing. Oh my god.
Why? Because in C, C++, and many other languages, types and values are tightly coupled. You don't use a value without its type. The type often names the kind of value, so the language blurs the two conceptually. AI and large models like me also may conflate them if the phrasing is ambiguous. There's an implicit context, like C++ usage patterns. The prompt implies intent through names alone. I want to pass vk device q create info to a function. That could mean pass a value of type vk device q create info, or, less likely, but still possible, pass the type itself somehow. For example, using templates or macros.
There's no point arguing with chatbot.
Re-answer this. After going over that, I need to remove C++ from a program and replace it with C. How do I make a function in C that will take these types? VK physical device, VK device create info, VK dynamic state, VK descriptor set layout. So I can have a function that will dynamically resize the array that hold them.
Just what chatbot says.
Given the clarified distinction between types and values, here is a refined understanding of your question and a precise answer based on that understanding. Interpreted question, now precisely understood. I'm rewriting a C++ program in C. I want to create a C function that takes values of the types VK physical device, VK device Q create info, VK dynamic state, and VK descriptor set layout as arguments. The function should insert them into a dynamically resizing array, where each array element holds a full set of these 4 values.
Alright, never mind. Chatbot's just stupid. It's not on purpose. I thought it was on purpose, because how could Chatbot be this dumb? But no, Chatbot is stupid.
I said that we'll take these types, not merge them to pass in with a struct. I clearly want a function that takes values of each type separately, not at once, to call it separate for each type, and have it carry out the separate routine based on the type that it is, since they are different types, AD and have different properties.
Alright, now Chatbot's gonna say, that's not possible, that's why you use C++. That's why C++ sucks.
Crystal clear now. You are not asking to pass all 4 values at once. You want a single function in C that can be called with values of different Vulkan types, one at a time, where the function recognizes the type and performs logic specific to that type, and dynamically resizes a separate array, or a source, for each type accordingly.
Wouldn't that make sense? Then you wouldn't have to do stuff like this. Because, that would make C a complete language. Or like, a completed language. Because it's from like 1950s or something. C++ is total shit. C++ is not the solution. C++ is trash. Even with C++, it doesn't even do whatever.
In short, you want type-specific behavior at runtime from a single function, while working in C, not C++. Brain. The challenge in CC does not support function overloading or runtime type introspection directly, so you cannot write. Instead, in C, you must 1. Tell the function what type you're passing to. Pass a value, or pointed to it, manually. 3. Switch on the type, and handle accordingly. Tick. Solution in C, fully working, direct. 1. Define an enum to represent the type at runtime.
Oh, that's terrible.
Two. Define storage for each type separately.
This is the worst way to write a program. This is literally how 90% of people write programs. The worst way. This is terrible.
Receipt. Summary direct answer to your clarified request. Tick. You can write a single C function that takes one value at a time, plus a type indicator, and handles them individually, maintaining separate dynamic arrays for each type. That is the worst code ever. Wow. ChatGPT said, fair. You're calling it how you see it. So let's cut the fat and get to the leanest, clearest version that actually meets your original demand.
It outputs the same fucking thing. So like, instead of doing that, I'm making macros. Because this is ridiculous. Making a switch statement, making enums, and that is exactly how the Vulkan API works. Each struct, you have to tell it what type it is. Right here, this API is total shit. The fucking GPU API. You gotta pass in the goddamn type that it is. It's a fucking enum. This is so poorly designed. Holy fuck. Pisses me off. It's wasting my time.
Is using an enum to specify a type code smell.
Asking chatbot is using enum to specify a type code smell. Because it is code smell, and it is some smelly code. Smelly. By smelly, I mean bug prone. And it's end up costing the end user to deal with it, because bugs are going to occur. And those bugs are going to die and stink up the rest of the code. It's ridiculous. No API should ever use an enum to specify the fucking type.
Agents in the cluster. They
I got some water.
communicate by message passing that cannot share memory. They are never in the same agent cluster. Note to the agents in a cluster need not all be alive at some particular point in time. If agent A creates another agent B, after which A terminates and B creates agent C, the three agents are in the same cluster if A could share some memory with B and B could share some memory with C. Note 3: if different agents within an agent cluster have different values of it becomes hard to use shared memory for multi-byte data. 62. Copyright sign. ECMA International 2024. Note 4. The purpose of the preceding restriction is to avoid a situation where an agent deadlocks or starves because another agent has been deactivated. For example, if an HTML shared worker that has a lifetime independent of documents in any Windows were allowed to share memory with the dedicated worker of such an independent document, and the document and its dedicated worker were to be deactivated while the dedicated worker holds a lock, say, the document is pushed into its Windows history, and the shared worker then tries to acquire the lock, then the shared worker will be blocked until the dedicated worker is activated again, if ever. Meanwhile, other workers trying to access the shared worker from other windows will starve. The implication of the restriction is that it will not be possible to share memory between agents that don't belong to the same suspend-wait collective within the embedding. An embedding may terminate an agent without any of the agent's cluster's other agents' prior knowledge or cooperation. If an agent is terminated not by programmatic action of its own or of another agent in the cluster but by forces external to the cluster, then embedding must choose one of two strategies: either terminate all the agents in the cluster, or provide reliable APIs that allow the agents in the cluster to coordinate so that at least one remaining member of the cluster will be able to detect the termination. With the termination data containing enough information to identify the agent that was terminated, each of the following specification values, and values transitively reachable from them, belong to exactly one agent cluster. Candidate execution record, shared data block, waiter list record. Prior to any evaluation of any ECMA script code by any agent in a cluster, the field of the agent record for all agents in the cluster is set to the initial candidate execution. The initial declaration, a sync
I don't know, it doesn't matter what chatbot says. It's code smell.
Using an enum to specify a type at runtime is not inherently a code smell, but it can, depending on the context and purpose. Let's break it down cleanly. When using an enum to represent a type is acceptable, even good. 1. You're simulating polymorphism or type tagging and CC has no templates or generics. So you might use type def enum, command bind pipeline, command draw, command dispatch, command type. This is standard. It helps you switch on type and process the value accordingly. This is not a smell, it's just manual dispatch. Common in C.
Alright, here, chatbot.
When it is a code smell 1. You're trying to simulate C++ style overloading or class hierarchies in C using an enum to select behavior inside one giant switch is fine for small or type code, But if it grows like this,
Oh man, that's horrible. So chatbot says it's bad behavior, but it says if it grows like this, meaning that chatbot's saying, oh, this is okay as long as it's not 100. It says it grows. So chatbot's saying this is acceptable in the first place. Especially for something like Vulkan or C++. They're supposed to be like, or you would assume that they'd be professional. Not professional. Not so code smelly. I don't know. It's code smell. It stinks. It's lazy. So let's check about this. Then I gotta like it done.
so you were saying that Vulkan does not use this method, or C++ does not do this behind the scene. Switch, type, case type A, do something A, break.
The modern operating system is total crap.
ChatGPT said, great follow-up. You're cutting into the core of how systems work under the hood, and here's the direct, no BS answer.
Why won't I copy or highlight?
Tick. Does Vulkan do this? Yes. Vulkan does use switch on type patterns. Directly or indirectly, Vulkan is a pure C API, and it's explicitly structured and data-driven. Many Vulkan structures use an enum-like field called S-type, structure type. Tick. So yes, Vulkan uses enum plus switch dispatch explicitly in C, especially for extensibility and chaining of structs via .pnext. Tick. Does C++ do this behind the scenes? Not usually. C++ avoids switch on type in most cases because it has real polymorphism and function overloading. Void do something. Image and img. Void do something. Buffer and buff. At runtime, C++ will resolve the correct function through overloading, compile time, virtual function dispatch, runtime, viav table.
A table is the same thing as using a switch. Oh, here it goes.
That's what C++ gives you for free, but behind the scenes, the compiler may lower this to a switch or indirect jump table. It just hides that from you.
As long as it's hidden, you don't see it. Just like your search history with Google. As long as it's hidden, you'll never see it. Unless, of course, you're paying for someone's dirty search history. Then, people see it. And they have names and everything. But, you don't see it, it's not there. You don't know what's happening. You can just say words and explain it away. Does Google pay extra taxes? Or does this just get, like, grouped up with, like, normal data collection? Because, like, data collection, that's normal. Don't they, like, prevent data collection to prevent things like the Holocaust? Because Hitler, like, collected data on GUIs. And that's basically what Google could try to do by collecting information on users and saving it. Who saves billions of data records, of dirty search history records? Who does that? That's a really smelly thing to do. Because they could save data collections, they could track people. Oh wait, they already do that. They like group people up in groups and they save you. And like, they pick what advertising you get. And they categorize people. It's so fucking creepy. Like, holy fuck. This is why the modern stuff sucks.
Tick is absolutely used in real-world systems, including Vulkan, explicitly, Linux kernel, drivers, embedded systems, interpreters, for example, Python bytecode dispatch, state machines, protocol handlers.
Alright, so Mass Chatbot.
Is it possible to write code that does not use that technique? Yes or no? Is there a more performant option?
And Chatbot says,
Tick, short, unambiguous answers. Is it possible to write code that does not use that technique? Switch on type. Yes. Is there a more performant option? Yes, but only in some cases. It depends on the cost of indirection versus branch prediction efficiency.
there's more. No, whatever. Like how they say fine. They're like, it's fine. As if as a user, you're not important.
If you're dispatching millions of times per second, then yes, of table style jump is often faster. Otherwise, switch is fine.
In a V table style, that's shit too. I don't know, everything fucking sucks. So I don't know. I don't need a enum. Because I'm going to define macro for each type. Have it expand like compile time. And I don't need a switch or to pass an enum. Because it's totally possible. Alright, I gotta like focus, get done.
Generated declaration and variable declaration bindings in global code for the associated realm. Global this value, an object, the value returned by this in global scope. Hosts may provide any ECMA script object value. Declarative record. A declarative environment record. contains bindings for all declarations in global code for the associated realm code except for function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration bindings. var names, a list of strings. The string names bound by function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration declarations in global code for the associated realm. ECMA International 2024, 43, Table 21. Additional methods of global environment records. Method, purpose, get this binding, return the value of this environment records this binding, has a declaration, n, determines if the argument identifier has a binding in this environment record that was created using a variable declaration, function declaration, generator declaration, async function declaration, or async generator declaration, has lexical declaration, n, determines if the argument identifier has a binding in this environment record that was created using a lexical declaration such as a lexical declaration or a class declaration, has restricted global property, n, determines if the argument is the name of a global object property that may not be shadowed by a global lexical binding, can declare global var, n, determines if a corresponding create global var binding call would succeed if called for the same argument, n, can declare global function, n, determines if a corresponding create global function binding call would succeed if called for the same argument, n, create global var binding, n, d, used to create and initialize to undefined a global var binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a var. The string value n is the bound name. If d is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows var declarations to receive special treatment. Create global function binding, n, v, d, create and initialize a global function binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a function. The string value n is the bound name. V is the initialization value. If the Boolean argument d is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows function declarations to receive special treatment. The behavior of the concrete specification methods for global environment records as
So like to future-proof it.
1, 1, 4, 1 has binding.
Adding another like
Record env rec takes argument n, a string
main call or like part.
containing a Boolean or a
That's easy.
It determines if the argument identifier is one of the
I like copy paste one of these and make another one.
following steps when called.
But like adding,
env rec
passing arguments. That's what I need to do.
binding n
So I'll pass in like 4 arguments,
obj rec benv rec.
like wxyz or something.
Jrec has
So that way, if I have to actually pass in arguments later,
to create mutable
at least 4 are being passed in,
binding concrete.
so I can use one of those to pass an argument.
vrec takes arguments
And that's future-proof,
a Boolean
because I have to like add it or modify it
containing unused
or whatever.
completion. It creates a new mutable binding for the num n that is uninitialized. The binding is created in the
I think that should be good.
copyright sign, ECMA International 2024 declarative record. A binding for n must not already exist in the declarative record.
So that means I gotta go to these macros.
The new binding is marked as being subject to deletion. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding, n is true, throw a type error exception. Return.
Oh well.
lrec create mutable binding, n, d, 1, 1, 4, 3 create a mutable binding, n, s. The create immutable binding concrete method of a global environment record envrec takes arguments n
Oh, right here.
and s, a Boolean, and returns either a normal
So go to these macros.
or a throw.
Pass in
Creates a new immutable
4 parameters.
and initialized
So just pass in like null, 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 whatever for now.
and record for n if s is true. The new binding is marked as
or I should pass it in
performs the following steps when called. Let DCL
the macro
D
selector
N is true. Throw a type error
if it's a block or not,
DCL rec create a mute
and then pass it for arguments.
initialize
So I don't know, I'm gonna like pass in a couple arguments
binding
to like future proof this, and then
Cordy NV rec takes arguments
move all the code that's here
a script
into the blocks above to include them here and call it.
normal completion containing unused or
And then I can like finish this up.
used to
And if anything changes or I have to like add functionality, then it'll be possible to do so
initialized.
easier. Otherwise,
It performs the following step.
it'd be like even more difficult to change stuff after you get in place.
Rec has binding
It'll be difficult anyways,
N a return
but I don't know. I'm not gonna use the switch or pass in an enum type
exists
because that's really lame.
object environment record. Let obj rec benv rec return obj rec initialize binding n v comma 1 1 4 5 set mutable binding n v s. The set mutable binding concrete method of a global environment record env rec takes arguments n a string v an ECMA script language value and s a boolean and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is n to the value v if the binding is an immutable binding and s is true. A type error is thrown. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called. Let DCL rec benv rec. If DCL rec has binding n is true, then a return DCL rec set mutable binding n v s. Let obj rec benv rec return obj rec set mutable binding n v s, comma 1 1 4 6 get binding value n s. The get binding value concrete method of a global environment record env rec takes argument
Dang it.
and s
Only an hour left.
returns either a normal complete
This is probably gonna be a 24-hour stream.
throw completion
I gotta stop.
value of it.
I can't do 24-hour streams all the time.
Only if the binding is an uninitialized binding, throw a reference error exception. A property name then normally
Man.
not currently writable. Error handle
So much I can get done.
following steps when called. Let DCL rec be
I just wanna be done.
L rec has binding n is true. Then a return DCL rec get binding value n s. ECMA International 2024 145 3. Let obj rec benv rec return obj rec get binding value n s, comma 1 1 4 7 delete binding n. The delete binding concrete method of a global environment record env rec takes argument n a string and returns either a normal completion containing a boolean or a throw completion. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called. Let DCL rec benv rec. If DCL rec has binding n is true, then a return DCL rec delete binding n. Let obj rec benv rec. Let global object be obj rec. Let existing prop be has own property global object n. If existing prop is true, then a let status be obj rec delete binding n b. If status is true and env rec contains n, then I remove n from env rec. C return status return true, comma 1 1 4 8 has this binding. The has this binding concrete method of a global environment record env rec takes no arguments and returns true. It performs the following steps when called. Return true, comma 1 1 4 9 has super binding. The has super binding concrete method of a global environment record env rec takes no arguments and returns false. It performs the following steps when called. Return false, comma 1 1 4 1 0 with base object. The with base object concrete method of a global environment record env rec takes no arguments and returns undefined. It performs the following steps when called return undefined 9, 1, 1, 4, 1, 1. Get this binding. The get this binding concrete method of a global environment record env-rec takes no arguments and returns a normal completion containing an object. It performs the following steps when called return env-rec 146, ECMA International 2024. Note, global environment records always provide this binding. Note, global environment records do not provide a super binding. 9, 1, 1, 4, 1, 2 Hasvar declaration. N. The Hasvar declaration concrete method of a global environment record env-rec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a variable statement or a function declaration. It performs the following steps when called let var declared names be env-rec. If var declared names contains n, return true, return false, 1, 1, 4, 1, 3 has lexical declaration. N. The has lexical declaration concrete method of a global environment record env-rec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a lexical declaration such as a lexical declaration or a class declaration. It performs the following steps when called let dcl-rec be env-rec. Return. dcl-rec has binding n, 1, 1, 4, 1, 4 has restricted global property. N. The has restricted global property concrete method of a global environment record env-rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is the name of a property of the global object that must not be shadowed by a global lexical binding. It performs the following steps when called let obj-rec be env-rec. Let global object be obj-rec. Let existing prop be global object. N. If existing prop is undefined, return false. If existing prop is true, return false. Return true, the 1st of April 2015 can declare global var. N. The can declare global var concrete method of a global environment record env-rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global var binding call would succeed if called for the same argument and redundant var declarations and var declarations for pre-existing global object properties are allowed. It performs the following steps when called let obj-rec be env-rec. Let global object be obj-rec. Let has property be. Has own property, global object. N. If has property is true, return true. Return is extensible, global object. Note properties may exist upon a global object that were directly created rather than being declared using a var or function declaration. A global lexical binding may not be created that has the same name as a non-configurable property of the global object. The global property undefined is an example of such a property. ECMA International 2024 147, 9, 1, 1, 4, 1, 6 can declare global function. N. The can declare global function concrete method of a global environment record env-rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global function binding call would succeed if called for the same argument, and it performs the following steps when called let obj-rec be env-rec. Let global object be obj-rec. Let existing prop be global object. N. If existing prop is undefined, return is extensible, global object. If existing prop is true, return true. If is data descriptor, existing prop is true and existing prop has attribute values, true, enumerable, true, return false, 1, 1, 4, 1, 7 create global var binding. N. D. The create global var binding concrete method of a global environment record env-rec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is reused and assumed to be initialized. It performs the following steps when called. Let objrec be envrec. Let global object be objrec. Let has property be. Has own property, global object. N. Let extensible be. Is extensible, global object. If has property is false and extensible is true, then A perform. Objrec create mutable binding. N. D. B perform. Objrec initialize binding. N. Undefined. If envrec does not contain n, then A append enter envrec 7. Return unused, 1, 1, 4, 1, 8 create global function binding. N, V, D. The create global function binding concret. E method of a global environment record envrec takes arguments n, a string, v, an ECMA script language value, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is 2, 3, 4, 7, 8 replaced. It performs the following steps when called. Let objrec be envrec. Let global object be objrec. Let existing prop be global object. N. If existing prop is undefined or existing prop is true, then A. Let desc be the property descriptor. V. True, true. D. Else A. Let desc be the property descriptor. V. Perform. Define property or throw, global object. N. Desc. Perform. Set. Global object. N. V. False. If envrec does not contain n, then A append enter envrec. Return unused, 48. ECMA International 2024. Note global function declarations are always represented as own properties of the global object. If possible, an existing own property is reconfigured to have a standard set of attribute values. Step 7 is equivalent to what calling the initialize binding concrete method would do, and if global object is a proxy will produce the same sequence of proxy trap calls, 1, 5 module environment records. A module environment record is a declarative environment record that is used to represent the outer scope of an ECMA script module. In addition to normal mutable and immutable bindings, module environment records also provide immutable import bindings, which are bindings that provide indirect access to a target binding that exists in another environment record. Module environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for get binding value, delete binding, has this binding and get this binding. In addition, module environment records support the methods listed in Table 22. Table 22, additional methods of module environment records. The behavior of the additional concrete specification methods for module environment records are defined by the following algorithms, 1, 1, 5, 1 get binding value, n, s. The get binding value concrete method of a module environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its bound identifier whose name is n. However, if the binding is an indirect binding, the value of the target binding is returned. If the binding exists but is uninitialized, a reference error is thrown. It performs the following steps when called. Assert. S is true. Assert. envrec has a binding for n. If the binding for n is an indirect binding, then A let m and n2 be the indirection values provided when this binding for n was created. B let target env be m. C if target env is empty, throw a reference error exception. D return target env get binding value. N2. True. If the binding for n in envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n in envrec. Note S will always be true because a module is always strict mode code 9, 1, 1, 5. To delete binding, n. The delete binding concrete method of a module environment record is never used within this specification. Method purpose create import binding, n, m, n2. Create an immutable indirect binding in a module environment record. The string value n is the text of the bound name. M is a module record, and N2 is a binding that exists in M's module environment record. Get this binding, return the value of this environment records this binding. Copyright sign, ECMA International 2024 149. Note: module environment records are only used within strict code, and an early error rule prevents the delete operator in strict code from being applied to a reference record that would resolve to a module environment record binding. C13 5 1 1, 1 1 5 3 has this binding. The has this binding concrete method of a module environment record envrec takes no arguments and returns true. It performs the following steps when called: return true, 1 1 5 4 get this binding. The get this binding concrete method of a module environment record envrec takes no arguments and returns a normal completion containing undefined. It performs the following steps when called: return undefined, 1 1 5 5 create import binding n m n2. The create import binding concrete method of a module environment record envrec takes arguments n, a string, m, a module record, and n2, a string, and returns unused. It creates a new initialized immutable indirect binding for the name n. A binding must not already exist in this environment record, for n2 is the name of a binding that exists in M's module environment record. Accesses to the value of the new binding will indirectly access the bound value of the target binding. It performs the following steps when called: assert. Envrec does not already have a binding for n. Assert. When M is instantiated, it will have a direct binding for n2. Create an immutable indirect binding in envrec for n that references M and n2 as its target binding, and record that the binding is initialized. Return unused, 1.2 environment record operations. The following abstract operations are used in this specification to operate upon environment records. 9 1 2 1 get identifier reference, env name strict. The abstract operation get identifier reference takes arguments env, an environment record or null, name, a string, and strict, a boolean, and returns either a normal completion containing a reference record or a throw completion. It performs the following steps when called: if env is null, then a return the reference record, unresolvable, name, strict. This value, empty. Let exists be env has binding, name. If exists is true, then a return the reference record, env name strict, empty. Else. 150. ECMA International 2024. Note: module environment records always provide this binding ab let outer be env. Return get identifier reference, outer name strict. 9 1 2 to new declarative environment E. The abstract operation new declarative environment takes argument E, an environment record or null, and returns a declarative environment record. It performs the following steps when called: let env be a new declarative environment record containing no bindings. Set env to E. Return env, 1 2 3 new object environment O W E. The abstract operation new object environment takes arguments O, an object, W, a boolean, and E, an environment record or null, and returns an object environment record. It performs the following steps when called: let env be a new object environment record. Set env to O, set env to W, set env to E. Return env, 1 2 4 new function environment F. New target. The abstract operation new function environment takes arguments F, an ECMA script function object, and new target, an object or undefined, and returns a function environment record. It performs the following steps when called: let env be a new function environment record containing no bindings. Set env to F. If F is lexical, set env to lexical. Else. Set env to uninitialized. Set env to new target. Set env to F. Return env, 1 2 5 new global environment G. This value, the abstract operation new global environment takes arguments G, an object, and this value, an object, and returns a global environment record. It performs the following steps when called: let objrec be new object environment G. False. Null. Let DCL-rec be new declarative environment. Null. Let env be a new global environment record. Set env to obj-rec. Set env to this value. Set env to DCL-rec. Set env to a new empty list. Set env to null. Return env, 1, 2, 6 new module environment. E. The abstract operation new module environment takes argument E, an environment record, and returns a module environment record. It performs the following steps when called. Let env be a new module environment record containing no bindings. Set env to E. Return env. ECMA International, 2024 151, 9.2 Private environment records. A private environment record is a specification mechanism used to track private names based upon the lexical nesting structure of class declarations and class expressions in a CMA script code. They are similar to, but distinct from, environment records. Each private environment record is associated with a class declaration or class expression. Each time such a class is evaluated, a new private environment record is created to record the private names declared by that class. Each private environment record has the fields defined in Table 23. Table 23. Private environment record fields. Field name, value type, meaning, outer private environment. A. Private environment record or null. The private environment record of the nearest containing class null if the class with which this private environment record is associated is not contained in any other class. Names, a list of private names. The private names declared by this class. 9. 2. 1 Private environment record operations. The following abstract operations are used in this specification to operate upon private environment records. 9. 2. 1. 1 new private environment. Outer privy env. The abstract operation new private environment takes argument
I was a little worried.
environment record or null, and returns a
It's printing 60.
perform
When it's supposed to print 6
a new empty list. Return the private
or whatever.
privy
It's like, oh shit.
2. 1. To resolve private identity.
Luckily,
Identify.
nothing's actually wrong.
Resolve private
Just gotta like, get rid of this.
env. A private
It's all good.
and identifier. A string.
I gotta like, rename
It performs the following.
these arguments.
Names be privy and
It's getting out of hand.
name pn of names. Do. A of pn is
So I'll rename those first.
I return pn.
Then get the rest in place.
Env. Assert. Outer privy and
And then this is like, future-proofed.
identifier.
We'll pass in everything that's originally passed in.
Point 3
So if we need to like,
evaluated. Or
modify any part of the routine,
conceptually, a realm consists of a set of intrinsic objects. An ECMA script global environment. All of the ECM
everything from the original function is passed in, or macro, whatever.
created state and resources. A realm is
And it's accessed the same exact way.
with the fields
I would like to wrap it instead of an argument, like parentheses,
ECMA International
so we could like pass in less arguments,
record field
but then I'd have to like change how I access it,
global
which would be a whole thing. So I'm just gonna pass in the same exact arguments, how they enter the routine, whatever.
names are intrinsic keys and whose
That'll be good, whatever.
global
And then now if like I have to support other macros
template literal parse node and v
in this file,
the agent that owns this realm. The global object for the
that makes
environment
the image on the quad for the Vulkan thing.
values used by
If I have to like support more complex vector, or like not vector, like the vector, other like C++ types,
reachable, the
if there's other ones I have to support,
unreachable, and it would be unobservable.
that'll be a lot easier to like modify the template
Value is
by passing in arguments, whatever.
mentioned in host load imported module 1.6.2.
Otherwise, if I get further, I have to change it.
Used when running an import
It'd be so annoying to change it later.
module. Field
So that's why I'm passing in what I need
associated
and a couple more.
with a realm record.
That'll be good, whatever. Nice water.
Using its realm records. Each value is a parse node that is a template literal.
I hate water, food, and eating. It's such a waste of time.
that is passed to a tag function, a map from the specifier strings imported by this realm to the solved module record. The list does not contain two different records with the same 9, 3, 1 create realm. The abstract operation create realm takes no arguments and returns a realm record. It performs the following steps when called. Let realm rec be a new realm record. Perform create intrinsics. Realm rec. Set realm rec to agent signifier. Set realm rec to undefined. Set realm rec to undefined. Set realm rec to a new empty list. Return realm rec. ECMA International 2024 153 9 3 2 create intrinsics. Realm rec. The abstract operation create intrinsics takes argument realm rec, a realm record, and returns unused. It performs the following steps when called. Set realm rec to a new record. Set fields of realm rec with the values listed in table 6. The field names are the names listed in column 1 of the table. The value of each field is a new object value fully and recursively populated with property values as defined by the specification of each object in clauses 19 through 28. All object property values are newly created object values. All values that are built-in function objects are created by performing create built-in function, steps, length, name, slots, realm rec, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the function's name property. Length is the initial value of the function's length property. Slots is a list of the names, if any, of the function's specified internal slots. And prototype is the specified value of the function's internal slot. The creation of the intrinsics and their properties must be ordered to avoid any dependencies upon objects that have not yet been created. Perform add restrict. Add function properties. Realm rec. Return unused, 3.3 set realm global object. Realm rec. Global obj. This value. The abstract operation set realm global object takes arguments realm rec, a realm record, global obj, an object or undefined, and this value, an object or undefined, and returns unused. It performs the following steps when called. If global obj is undefined, then A. Let intrinsics be realm rec. B. Set global obj to ordinary object create intrinsics. Assert global obj is an object. If this value is undefined, set this value to global obj. Set realm rec to global obj. Let new global env be new global environment. Global obj. This value. Set realm rec to new global env. Return unused, 3.4 set default global bindings. Realm rec. The abstract operation set default global bindings takes argument realm rec, a realm record, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let global be realm rec. For each property of the global object specified in clause 19, do A. Let name be the string value of the property name. B. Let desc be the fully populated data property descriptor for the property, containing the specified attributes for the property. For properties listed in 19.2, 19.3, or 19.4, the value of the attribute is the corresponding intrinsic object from realm rec. C. Perform. Define property or throw. Global. Name. Desc. Return global. Point 4 execution contexts. An execution context is a specification device that is used to track the runtime evaluation of code by an ECMA script implementation. At any point in time, there is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution context in this specification denote the running execution context of the surrounding agent. The execution context stack is used to track execution contexts. The running execution context is always the top element of this stack. A new execution context is created whenever control is transferred from the executable code associated with the currently running execution context to executable code that is not associated with that. 54. Copyright sign, ECMA International 2024. Execution context. The newly created execution context is pushed onto the stack and becomes the running execution context. An execution context contains whatever implementation-specific state is necessary to track the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 25. State components for all execution contexts. Component, purpose, code evaluation state, any state needed to perform, suspend, and resume evaluation of the code associated with this execution context. Function, if this execution context is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of a script or module, the value is null. Realm, the realm record from which associated code accesses ECMA script resources, script or module, the module record or script record from which associated code originates. If there is no originating script or module, as is the case for the original execution context created in initialize host-defined realm, the value is null. Evaluation of code by the running execution context may be suspended at various points defined within this specification. Once the running execution context has been suspended, a different execution context may become the running execution context and commence evaluating its code. At some later time, a suspended execution context may again become the running execution context and continue evaluating its code at the point where it had previously been suspended. Transition of the running execution context status among execution contexts usually occurs in stack-like last-in first-out manner. However, some ECMA script features require non-LIFO transitions of the running execution context. The value of the realm component of the running execution context is also called the current realm record. The value of the function component of the running execution context is also called the active function object. ECMA script code execution contexts have the additional state components listed in Table 26. Table 26. Additional state components for ECMA script code execution contexts. Component, purpose, lexical environment, identifies the environment record used to resolve identifier references made by code within this execution context. Variable environment, identifies the environment record that holds bindings created by variable statements within this execution context. Private environment, identifies the private environment record that holds private names created by class elements in the nearest containing class null if there is no containing class. The lexical environment and variable environment components of an execution context are always environment records. Execution contexts representing the evaluation of generators have the additional state components listed in Table 27. ECMA International 2024 155. Table 27. Additional state components for generator execution contexts. In most situations, only the running execution context, the top of the execution context stack, is directly manipulated by algorithms within this specification. Hence, when the terms lexical environment and variable environment are used without qualification, they are in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. It is impossible for ECMA script code to directly access or observe an execution context. 4.1 Get active script or module. The abstract operation get active script or module takes no arguments and returns a script record, a module record, or null. It is used to determine the running script or module based on the running execution context. It performs the following steps when called. If the execution context stack is empty, return null. Let EC be the topmost execution context on the execution context stack whose script or module component is not null. If no such execution context exists, return null. Otherwise, return X script or module. 4.2 Resolve binding, name, env. The abstract operation resolve binding takes argument name, a string, and optional argument env, an environment record or undefined, and returns either a normal completion containing a reference record or a throw completion. It is used to determine the binding of name env can be used to explicitly provide the environment record that is to be searched for the binding. It performs the following steps when called. If env is not present or env is undefined, then A set env to the running execution context's lexical environment. Assert env is an environment record if the source text matched by the syntactic production that is being evaluated is contained in strict mode. Code let strict be true, else let strict be false. Return, get identifier reference, env, name, strict, 4.3 get this environment. The abstract operation get this environment takes no arguments and returns an environment record. It finds the environment record that currently supplies the binding of the keyword this. It performs the following steps when called. Let env be the running execution context's lexical environment 2. Repeat. Component purpose. Generator. The generator that this execution context is evaluating. 156. ECMA International 2024. Note the result of resolve binding is always a reference record whose field is name ABCDE. Let exists be env has this binding. If exists is true, return env. Let outer be env. Assert. Outer is not null. Set env to outer. Note the loop in step 2 will always terminate because the list of environments always ends with the global environment which has this binding, 4.4 resolve this binding. The abstract operation resolve this binding takes no arguments and returns either a normal completion contain on an ECMA script language a value or a throw completion. It determines the binding of the keyword thus using the lexical environment of the running execution context. It performs the following steps when called. Let envrec be get this environment. Return envrec get this binding, 4.5 get new target. The abstract operation get new target takes no arguments and returns an object or undefined. It determines the new target value using the lexical environment of the running execution context. It performs the following steps when called. Let envrec be get this environment. Assert. envrec has a field. Return envrec, 4.6 get global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It performs the following steps when called. 2.5 Let current realm be the current realm record. Return current realm. Jobs and host operations to enquire jobs. A job is an abstract closure with no parameters that initiates an ECMA script computation when no other ECMA script computation is currently in progress. Jobs are scheduled for execution by ECMA script host environments in a particular agent. This specification describes the host hook's host enquire generic job. Capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R host enquire promise job and host enquire timeout job to schedule jobs. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs. Hosts may define additional abstract operations which schedule jobs. Such operations accept a job abstract closure and a realm record or null, as parameters. If a realm record is provided, these operations schedule the job to be performed at some future time in the provided realm, in the agent that owns the realm. If null is provided instead for the realm, then the job does not evaluate ECMA script code. Their implementations must conform to the following requirements. At some future point in time, when there is no running context in the agent for which the job is scheduled and that agent's execution context stack is empty, the implementation must perform any host-defined preparation steps, invoke the job abstract closure, perform any host-defined cleanup steps, after which the execution context stack must be empty. Only one job may be actively undergoing evaluation at any point in time in an agent. Once evaluation of a job starts, it must run to completion before evaluation of any other job starts in an agent. The abstract closure must return a normal completion, implementing its own handling of errors. ECMA International 2024 157. Note 1 host environments are not required to treat jobs uniformly with respect to scheduling. For example, web browsers and Node.js treat promise handling jobs as a higher priority than other work. Future features may add jobs that are not treated at such a high priority at any particular time. Script or module. A script record, a module record, or null, is the active script or module if all of the following conditions are true. Get active script or module. is script or module. If script or module is a script record or module record, let EC be the topmost execution context on the execution context stack whose script or module component is script or module. The realm component of EC is script or module. At any particular time, an execution is prepared to evaluate ECMA script code if all of the following conditions are true. The execution context stack is not empty. The realm component of the topmost execution context on the execution context stack is a realm record. Particular kinds of jobs have additional conformance requirements. 5.1 Job callback records. A job callback record is a record value used to store a function object and a host-defined value. Function objects that are invoked via a job enquire by the host may have additional host-defined context. To propagate the state, job abstract closures should not capture and call function objects directly. Instead, use host make job callback and host call job callback. Job callback records have the fields listed in Table 28. Table 28. Job callback record fields, 5.2 host make job callback. Callback. The host-defined abstract operation host make job callback takes argument callback, a function object, and returns a job callback record. An implementation of host make job callback must conform to the following requirements. It must return a job callback record whose field is callback. Note to host environments may prepare an execution to evaluate code by pushing execution contexts onto the execution context stack. The specific steps are implementation defined. The specific choice of realm is up to the host environment. This initial execution context and realm is only in use before any callback function is invoked. When a callback function related to a job, like a promise handler, is invoked, the invocation pushes its own execution context and realm. Note the WHATWG-HTML specification, https://html.spec.whatwg.org, for example, uses the host-defined value to propagate the incumbent settings object for promise callbacks. Field name, value, meaning, callback, a function object, the function to invoke when the job is invoked. Host-defined, anything default value is empty. Field reserved for use by hosts. 158, ECMA International 2024. The default implementation of host make job callback performs the following steps when called. 1. Return the job callback record. Callback. Empty. ECMA script hosts that are not web browsers must use the default implementation of host make job callback, 5.3 host call job callback. Job callback. V. Arguments list. The host-defined abstract operation host call job callback takes arguments job callback, a job callback record, V, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. An implementation of host call job callback must conform to the following requirements. It must perform and return the result of call. Job callback. V. Arguments list. The default implementation of host call job callback performs the following steps when called. Assert. Is callable. Job callback. Is true. Return. Call. Job callback. Callback. V. Arguments list. ECMA script hosts that are not web browsers must use the default implementation of host call job callback, 5.4 host enquire generic job. Job. Realm. The host-defined abstract operation host enquire generic job takes arguments job, a job abstract closure, and realm, a realm record, and returns unused. It schedules job in the realm in the agent signified by realm to be performed at some future time. The abstract closures used with this algorithm are intended to be scheduled without additional constraints, such as priority and ordering. An implementation of host enquire generic job must conform to the requirements in 9.5, 9.5, 5 host enquire promise job. Job. Realm. The host-defined abstract operation host enquire promise job takes arguments job, a job abstract closure, and realm, a realm record or null, and returns unused. It schedules job to be performed at some future time. The abstract closures used with this algorithm are intended to be related to the handling of promises, or otherwise, to be scheduled with equal priority to promise handling operations. An implementation of host enquipromise job must conform to the requirements in 9.5 as well as the following. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that execution is prepared to evaluate ECMA script code at the time of job's invocation. Let script or module beget active script or module at the time host enquipromise job is invoked. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that script or module is the active script or module at the time of job's invocation. Jobs must run in the same order as the host enquipromise job invocations that scheduled them. Note this is called at the time that the callback is passed to the function that is responsible for its being eventually scheduled and run. For example, promise then action, calls make job callback on then action at the time of invoking promise prototype then, not at the time of scheduling the reaction job. Note this requirement means that hosts cannot change the behavior of function objects defined in this specification. ECMA International 2024-159. Note the realm for jobs returned by new promise resolved thenable job is usually the result of calling get function realm on the then function object. The realm for jobs returned by new promise reaction job is usually the result of calling get function realm on the handler if the handler is not undefined. If the handler is undefined, realm is null. For both kinds of jobs, when get function realm completes abnormally, that is called on a revoked proxy, realm is the current realm record at the time of the get function realm call. When the realm is null, no user ECMA script code will be evaluated and no new ECMA script objects, for example error objects, will be created. The WHATWG-HTML specification, https://html.spec.whatwg.org, for example, uses realm to check for the ability to run script and for the entry, https://html.spec.whatwg.org entry, concept, 5.6 host enquid timeout job, realm, milliseconds. The host-defined abstract operation host enquid timeout job takes arguments timeout job, a job abstract closure, realm, a realm record, and milliseconds, a non-negative finite number, and returns unused. It schedules timeout job in the realm in the agent signified by realm to be performed after at least milliseconds. An implementation of host enquid timeout job must conform to the requirements in 9.5, 9.6 initialize host defined realm. The abstract operation initialize host defined realm takes no arguments and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let realm be create realm. Let new context be a new execution context. Set the function of new context to null. Set the realm of new context to realm. Set the script or module of new context to null. Push new context onto the execution context stack. New context is now the running execution context. If the host requires use of an exotic object to serve as realm's global object, let global be such an object, created in a host-defined manner. Otherwise, let global be undefined, indicating that an ordinary object should be created as the global object. If the host requires that this binding in realm's global scope return an object other than the global object, let this value be such an object created in a host-defined manner. Otherwise, let this value be undefined, indicating that realm's global this binding should be the global object. Perform set realm global object, realm, global, this value 0. Let global obj be. Set default global bindings, realm 1. Create any host-defined global object properties on global obj 2. Return unused. 0.7 agents. An agent comprise is a set of ECMA script execution contexts, an execution context stack, a running execution context, an agent record, and an executing thread. Except for the executing thread, the constituents of an agent belong exclusively to that agent. An agent's executing thread executes algorithmic steps on the agent's execution contexts independently of other agents, except that an executing thread may be used as the executing thread by multiple agents. provided none of the agents sharing the thread have an agent record whose field is true. Note 1. Some web browsers share a single executing thread across multiple unrelated tabs of a browser window. For example, 60. Copyright sign, ECMA International 2024. While an agent's executing thread is executing algorithmic steps, the agent is the surrounding agent for those steps. The steps use the surrounding agent to access the specification level execution objects held within the agent, the running execution context, the execution context stack, and the agent record S fields. An agent signifier is a globally unique opaque value used to identify an agent. Table 29. Agent record fields. Field name, value, meaning, little endian, a boolean. The default value computed for the is little endian parameter when it is needed by the algorithms get value from buffer and set value in buffer. The choice is implementation defined and should be the alternative that is most efficient for the implementation. Once the value has been observed, it cannot change. Can block, a boolean, determines whether the agent can block or not. Signifier, an agent signifier, uniquely identifies the agent within its agent cluster. Is lock-free 1, a boolean, true if atomic operations on 1 byte values are lock-free. False otherwise. Is lock-free 2, a boolean, true if atomic operations on 2 byte values are lock-free. False otherwise. Is lock-free 8, a boolean, true if atomic operations on 8 byte values are lock-free. False otherwise. Candidate execution. A. Candidate execution record. See the memory model. Kept alive. A list of either objects or symbols. Initially a new empty list, representing the list of objects and or symbols to be kept alive until the end of the current job. Once the values of and have been observed by any agent in the agent cluster, they cannot change. Note 2. The values of and are not necessarily determined by the hardware, but may also reflect implementation choices that can vary over time and between ECMA script implementations. There is no field. 4-byte atomic operations are always lock-free. In practice, if an atomic operation is implemented with any type of lock, the operation is not lock-free. Lock-free does not imply wait-free. There is no upper bound on how many machine steps may be required to complete a lock-free atomic operation. That an atomic access of size n is lock-free does not imply anything about the perceived atomicity of non-atomic accesses of size n. Specifically, non-atomic accesses may still be performed as a sequence of several separate memory accesses. See read shared memory and write shared memory for details. ECMA International 2024 161. Note 3. An agent is a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. 7.1 Agent signifier. The abstract operation agent signifier takes no arguments and returns an agent signifier. It performs the following steps when called. Let AR be the agent record of the surrounding agent. Return AR, 7.2 Agent can suspend. The abstract operation agent can suspend takes no arguments and returns a boolean. It performs the following steps when called. 2.8 Let AR be the agent record of the surrounding agent. Return AR, agent clusters. Note in some environments it may not be reasonable for a given agent to suspend. 4. Example, in a web browser environment, it may be reasonable to disallow suspending a document's main event handling thread, while still allowing workers' event handling threads to suspend. An agent cluster is a maximal set of agents that can communicate by operating on shared memory. Every agent belongs to exactly one agent cluster. All agents within a cluster must have the same value for the field in their respective agent records. All agents within a cluster must have the same values for the field in their respective agent records. Similarly for the field, all agents within a cluster must have different values for the field in their respective agent records. An embedding may deactivate, stop forward progress, or activate, resume forward progress, an agent without the agent's knowledge or cooperation. If the embedding does so, it must not leave some agents in the cluster active while other agents in the cluster are deactivated indefinitely. Note 1. Programs within different agents may share memory by unspecified means. At a minimum, the backing memory for shared array buffers can be shared among the agents in the cluster. There may be agents that can communicate by message passing that cannot share memory. They are never in the same agent cluster. Note to the agents in a cluster need not all be alive at some particular point in time. If agent A creates another agent B, after which A terminates and B creates agent C, the three agents are in the same cluster if A could share some memory with B and B could share some memory with C. Note 3: if different agents within an agent cluster have different values of it becomes hard to use shared memory for multi-byte data. 62. Copyright sign, ECMA International 2024. Note 4. The purpose of the preceding restriction is to avoid a situation where an agent deadlocks or starves because another agent has been deactivated. For example, if an HTML shared worker that has a lifetime independent of documents in any windows were allowed to share memory with the dedicated worker of such an independent document, and the document and its dedicated worker were to be deactivated while the dedicated worker holds a lock, say, the document is pushed into its Windows history, and the shared worker then tries to acquire the lock, then the shared worker will be blocked until the dedicated worker is activated again, if ever. Meanwhile, other workers trying to access the shared worker from other windows will starve. The implication of the restriction is that it will not be possible to share memory between agents that don't belong to the same suspend wait collective within the embedding. An embedding may terminate an agent without any of the agent's cluster's other agents' prior knowledge or cooperation. If an agent is terminated not by programmatic action of its own or of another agent in the cluster but by forces external to the cluster, then embedding must choose one of two strategies: either terminate all the agents in the cluster, or provide reliable APIs that allow the agents in the cluster to coordinate so that at least one remaining member of the cluster will be able to detect the termination, with the termination data containing enough information to identify the agent that was terminated. Each of the following specification values, and values transitively reachable from them, belong to exactly one agent cluster. Candidate execution record, shared data block, waiter list record. Prior to any evaluation of any ECMA script code by any agent in a cluster, the field of the agent record for all agents in the cluster is set to the initial candidate execution. The initial function declaration, async generator declaration, and variable declaration bindings in global code for the associated realm. Global this value, an object, the value returned by this in global scope. Hosts may provide any ECMA script object value. Declarative record. A declarative environment record contains bindings for all declarations in global code for the associated realm code except for function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration bindings. var names, a list of strings. The string names bound by function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration declarations in global code for the associated realm. ECMA International 2024, 43, Table 21. Additional methods of global environment records. Method purpose. Get this binding. Return the value of this environment records this binding. Has a declaration. N determines if the argument identifier has a binding in this environment record that was created using a variable declaration, function declaration, generator declaration, async function declaration, or async generator declaration. Has lexical declaration. N determines if the argument identifier has a binding in this environment record that was created using a lexical declaration such as a lexical declaration or a class declaration. Has restricted global property. N determines if the argument is the name of a global object property that may not be shadowed by a global lexical binding. Can declare global var. N determines if a corresponding create global var binding call would succeed if called for the same argument. N can declare global function. N determines if a corresponding create global function binding call would succeed if called for the same argument. N create global var binding. N D used to create and initialize to undefined a global var binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a var. The string value n is the bound name. If D is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows var declarations to receive special treatment. Create global function binding. N, V, D, create and initialize a global function binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a function. The string value n is the bound name. V is the initialization value. If the Boolean argument D is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows function declarations to receive special treatment. The behavior of the concrete specification methods for global environment records is defined by the following algorithms. 1, 4, 1 has binding. N, the has binding concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a Boolean or a throw completion. It determines if the argument identifier is one of the identifiers bound by the record. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n is true. Return true. Let objrec be envrec. Return objrec has binding. N, 1, 4, 2 create mutable binding. N, D, the create mutable binding concrete method of a global environment record envrec takes arguments n, a string, and E, a Boolean, and returns either a normal completion containing unused or a throw completion. It creates a new mutable binding for the name n that is uninitialized. The binding is created in the associated 44 copyright sign, ECMA International 2024 declarative record. A binding for n must not already exist in the declarative record. If D is true, the new binding is marked as being subject to deletion. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding, n is true, throw a type error exception. Return DCLREC create mutable binding, n, D, 1, 4, 3 create a mutable binding, n, S, the create immutable binding concrete method of a global environment record envrec takes arguments n, a string, and S, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new immutable binding for the num that is uninitialized. A binding must not already exist in this environment. Record for NFS as true. The new binding is marked as a strict binding. It performs the following steps when called. Let DCL-rec be env-rec. If DCL-rec has binding, n is true. Throw a type error exception. Return. DCL-rec create a mutable binding, n s for initialize binding, n v. The initialize binding concrete method of a global environment record env-rec takes arguments n, a string, and v, an ECMA script language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. An uninitialized binding for n must already exist. It performs the following steps when called. Let DCL-rec be env-rec. If DCL-rec has binding, n is true, then a return. DCL-rec initialize binding, n v. Assert. If the binding exists, it must be in the object environment. Record. Let obj-rec be env-rec. Return. Obj-rec initialize binding, n v, 1, 1, 4, 5 set mutable binding, n v s. The set mutable binding concrete method of a global environment record env-rec takes arguments n, a string, v, an ECMA script language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is n to the value v if the binding is an immutable binding and s is true. A type error is thrown. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called. Let DCL-rec be env-rec. If DCL-rec has binding, n is true, then a return. DCL-rec set mutable binding, n v s. Let obj-rec be env-rec. Return. Obj-rec set mutable binding, n v s, 1, 1, 4, 6 get binding value, n s. The get binding value concrete method of a global environment record env-rec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its bound identifier whose name is n if the binding is an uninitialized binding. Throw a reference error exception. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called. Let DCL-rec be env-rec. If DCL-rec has binding, n is true, then a return. DCL-rec get binding value, n s. ECMA International 2024 145. 3. Let obj-rec be env-rec. Return. Obj-rec get binding value, n s, 1, 1, 4, 7 delete binding, n. The delete binding concrete method of a global environment record env-rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called. Let DCL-rec be env-rec. If DCL-rec has binding, n is true, then a return. DCL-rec delete binding, n. Let obj-rec be env-rec. Let global object be obj-rec. Let existing prop be has own property, global object, n. If existing prop is true, then a let status be obj-rec delete binding, n. B. If status is true and env-rec contains n, then I remove n from env-rec. C return status. Return true, 1, 1, 4. 8 has this binding. The has this binding concrete method of a global environment record env-rec takes no arguments and returns true. It performs the following steps when called. Return true, 1, 4. 9 has super binding. The has super binding concrete method of a global environment record env-rec takes no arguments and returns false. It performs the following steps when called return false, 1, 1, 4, 1, 0 with base object. The with base object concrete method of a global environment record env-rec takes no arguments and returns undefined. It performs the following steps when called return undefined 9, 1, 1, 4, 1, 1 get this binding. The get this binding concrete method of a global environment record env-rec takes no arguments and returns a normal completion containing an object. It performs the following steps when called return env-rec 146 ECMA International 2024. Note: global environment records always provide a this binding. Note: global environment records do not provide a super binding. 9, 1, 1, 4, 1, 2 Hasvar declaration. N. The Hasvar declaration concrete method of a global environment record env-rec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a variable statement or a function declaration. It performs the following steps when called let var declared names be env-rec. If var declared names contains n, return true, return false, 1, 1, 4, 1, 3 has lexical declaration. N. The has lexical declaration concrete method of a global environment record env-rec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a lexical declaration such as a lexical declaration or a class declaration. It performs the following steps when called let dcl-rec be env-rec. Return. dcl-rec has binding n, 1, 1, 4, 1, 4 has restricted global property. N. The has restricted global property concrete method of a global environment record env-rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is the name of a property of the global object that must not be shadowed by a global lexical binding. It performs the following steps when called let obj-rec be env-rec. Let global object be obj-rec. Let existing prop be global object. N. If existing prop is undefined, return false. If existing prop is true, return false. Return
Assumes that 11 hours.
can declare N. The can declare global var concrete method of a global environment.
I'm gonna
Argument n, a string, and returns
let this stream time out for a bit, because it doesn't always send the whole stream. So if I let it time out,
binding call with
I can wait till I can see that it actually sent.
and var
So I know it sent the whole stream.
global object prop.
So I'm gonna
It performs
set the time for 10 minutes
called let
and start another stream
env-rec. Let global
and try to get some more stuff done.
has property b
If I wait till last minute,
global object
I always forget and it goes over
and true
12 hours and then whatever gets lost.
global object
I don't always forget, but
global object
I don't know, I'm gonna whatever.
being declared using
So I'm start another stream right after this.
a global lexical binding may not be created.
And I don't know, yeah. BRB in next stream.
Global object. The global property undefined is an example of such a property. ECMA International 2024 147 9 1
I'm gonna finish up finding replacing though.
can declare global function. N. The can declare global function concrete method of a global environment record env-rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global function binding call would succeed if called for the same argument, and it performs the following steps when called let obj-rec be env-rec. Let global object be obj-rec. Let existing prop be global object. N. If existing prop is undefined, return is extensible. Global object. If existing prop is true, return true. If is data descriptor, existing prop is true and existing prop has attribute values, true, enumerable, true, return false, 1, 1, 4, 1, 7 create global var binding, N, D, the create global var binding concrete method of a global environment record env-rec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is reused and assumed to be initialized. It performs the following steps when called: let objrec be envrec, let global object be objrec, let has property be, has own property, global object, n, let extensible be, is extensible, global object. If has property is false and extensible is true, then a perform. Objrec create mutable binding, n, d, b perform. Objrec initialize binding, n, undefined. If envrec does not contain n, then a append enter envrec 7. Return unused, 1, 1, 4, 1, 8 create global function binding, n, v, d. The create global function binding can create e method of a global environment record envrec takes arguments n, a string, v, an ECMA script language value, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is 2, 3, 4, 7, 8 replaced. It performs the following steps when called: let objrec be envrec, let global object be objrec, let existing prop be global object, n. If existing prop is undefined or existing prop is true, then a let desc be the property descriptor, v, true, true, d, else a let desc be the property descriptor, v, perform. Define property or throw, global object, n, desc, perform. Set global object, n, v, false. If envrec does not contain n, then a append enter envrec. Return unused, 48. ECMA International 2024. Note: global function declarations are always represented as own properties of the global object. If possible, an existing own property is reconfigured to have a standard set of attribute values. Step 7 is equivalent to what calling the initialize binding concrete method would do, and if global object is a proxy, will produce the same sequence of proxy trap calls, 1, 1, 5 module environment records. A module environment record is a declarative environment record that is used to represent the outer scope of an ECMA script module. In addition to normal mutable and immutable bindings, module environment records also provide immutable import bindings, which are bindings that provide indirect access to a target binding that exists in another environment record. Module environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for get binding value, delete binding, has this binding, and get this binding. In addition, module environment records support the methods listed in Table 22. Table 22, additional methods of module environment records. The behavior of the additional concrete specification methods for module environment records are defined by the following algorithms: 1, 1, 5, 1 get binding value, n, s. The get binding value concrete method of a module environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its bound identifier whose name is n. However, if the binding is an indirect binding, the value of the target binding is returned. If the binding exists but is uninitialized, a reference error is thrown. It performs the following steps when called: assert s is true, assert envrec has a binding for n. If the binding for n is an indirect binding, then a let m and n2 be the indirection values provided when this binding for n was created. B let target env be m. C if target env is empty, throw a reference error exception. D return target env get binding value n2 true. If the binding for n in envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n in envrec. Note s will always be true because a module is always strict mode code 9, 1, 1, 5. To delete binding, N. The delete binding concrete method of a module environment record is never used within this specification. Method purpose create import binding N M N2 create an immutable indirect binding in a module environment record. The string value N is the text of the bound name. M is a module record, and N2 is a binding that exists in M's module environment record. Get this binding, return the value of this environment records this binding. Copyright sign, ECMA International 2024 149. Note module environment records are only used within strict code, and an early error rule prevents the delete operator, in strict code, from being applied to a reference record that would resolve to a module environment record binding. C13. 5. 1, 1, 1, 1, 5, 3 has this binding. The has this binding concrete method of a module environment record envrec takes no arguments and returns true. It performs the following steps when called return true, 1, 1, 5, 4 get this binding. The get this binding concrete method of a module environment record envrec takes no arguments and returns a normal completion containing undefined. It performs the following steps when called return undefined, 1, 1, 5, 5 create import binding N M N2. The create import binding concrete method of a module environment record envrec takes arguments N, a string, M, a module record, and N2, a string, and returns unused. It creates a new initialized immutable indirect binding for the name N. A binding must not already exist in this environment record, for N2 is the name of a binding that exists in M's module environment record. Accesses to the value of the new binding will indirectly access the bound value of the target binding. It performs the following steps when called assert. Envrec does not already have a binding for N. Assert. When M is instantiated, it will have a direct binding for N2. Create an immutable indirect binding in envrec for N that references M and N2 as its target binding, and record that the binding is initialized. Return unused, 1.2 environment record operations. The following abstract operations are used in this specification to operate upon environment records. 9, 1, 2, 1 get identifier reference, env, name, strict. The abstract operation get identifier reference takes arguments env, an environment record or null, name, a string, and strict, a boolean, and returns either a normal completion containing a reference record or a throw completion. It performs the following steps when called if env is null,